these models, right? You've got text to speech, you've got, rather I should say, text to image with DALL-E, you've got coding, you've got language.
Your ChatGPT has completely changed the conversation about AI. I think those of us who have been on the inside of AI definitely have kind of thought about it as like, of course, it's changing the world and we see it every day. But I think ChatGPT made it real for millions of people by showing them what it can do and how powerful it is, and their imaginations are now freed.
How can this be really useful towards someone who may have, say, limited mobility? One of my colleagues, Christina, her arms are paralyzed and she types with her toes. And watching her use this product is really cool because she said, oh, I now just have to type one sentence rather than typing lots of sentences to plan a trip, for example.
You know, how do we set the right mental model for a technology like this? You know, it's super impressive. It can create, it can cite information. And so we found that people tend to over-trust or over-rely the kind of information it generates. And so a lot of what our team did was like, how do you set the right mental model for users? Reminding them, hey, you know, this is from the internet, just as reliable as the internet. Some things are factual, some things are not.
So hi everyone, welcome to the Global AI Bootcamp 2023. We welcome you as one of the attendees of our yearly global event with more than 70 locations around the world. And Sammy, do you know that this is already the 5th event in a row?
5 already?
Yes.
Okay.
It's our 5th anniversary.
Wow, it's crazy. Time really flies.
Yeah, we started in 2018. Together with the global XR community. And then in 2019, it really exploded with lots of locations around the globe.
Exactly.
Then we had a couple of years which were virtual and some were hybrid. And now we're back with our 5th anniversary, a big event with lots of locations around the world.
It's really a nice history already, but I think there's a lot of people also that we need to thank, and actually those people are right now together with you in the room, and that's the local organizers. They've been working hard to find a venue, to find speakers, to find sponsors, or maybe even catering for some food. So please, thank you to all the local organizers. Give them a random applause for all the work that they've been doing. I think they really earn it because of doing all that kind of work.
Yes, thank you.
Yeah. But you know, there's also some other people who've been doing a lot of work over the last 5 years. And one person specifically, well, it's sad that you cannot see him, but we can see him. So give me a second. Let me switch on my phone and my camera. Here, do you see this guy here? He's one of the founding fathers of the global AI community and has been working for us for over 5 years, of course, doing everything. And now somehow he found a new passion in producing videos like this. So should we go inside?
Let's go inside.
Okay, let's go.
Come on inside. So hi John, welcome to the Global AI Bootcamp Keynote.
Hi, thank you very much for having me.
Yes, and thank you for being here with me.
It's my pleasure.
Yeah. Before we start, can you tell us who you are and what you do at Microsoft?
Sure. I'm John Montgomery, and I am the Corporate Vice President of Product in charge of Azure AI, which includes the Azure Cognitive Services, Azure OpenAI Service, Azure Machine Learning, and our AI frameworks.
So if we look at the past year, what is your most memorable moment in terms of AI advancements?
The last year has been amazing. I tend to think about the world in terms of customer impact, more so than like research impact or product advances. And in the last year, I would say, we've seen several interesting customer things happen. One of the biggest, I mean, I could pick, So there are little ones like the improvements we've seen in our cognitive, like neural voices. Mm-hmm. The quality is getting better, it's taking less training data, and that's enabled customers like Duolingo to add languages and to make the interactions kind of more personal. We've done a whole bunch inside of Azure Machine Learning to make it scale better, to make training better, and that's impacted a bunch of customers, ranging from big ones like Chevron to some of our newer customers. I think, though, if you look back at the last year, probably the single kind of biggest thing is around Azure OpenAI service going general availability, and ChatGPT. And those are probably the biggest things in the last year. ChatGPT has completely changed the conversation about AI. I think those of us who have been on the inside of AI definitely have kind of thought about it as like, of course, it's changing the world and we see it every day. But I think ChatGPT made it real for millions of people by showing them what it can do and how powerful it is, and their imaginations are now freed.
Yeah, that's totally true. I've used it for a couple of times now, and it is really, really big, and it's really game-changing.
I have to ask you then, what's the coolest thing you've done with ChatGPT?
Ooh, I have written some social media posts for my podcast.
Cool.
And it's very good at it, even better than I am.
It is very good at things like
Yeah,
that, yes.
yeah, that's totally true. You also lead a team at Microsoft, and that team focuses on building tools that are used by customers to create their own AI solutions. So can you share a customer story with us that really stood out for you?
Wow. So when I think about my customers, I really kind of think about it in two cohorts. Microsoft is actually my largest customer. All of the AI services at Microsoft, they're using Azure Machine Learning for training or for inference. They're calling our cognitive services. They're using the Azure OpenAI service. And that includes things like GitHub Copilot, which is built on Azure OpenAI. It includes things like Dynamics 365. I think, though, from a first-party perspective, in the last few days, we've seen some really huge announcements. There was one that actually happened just today, where we're seeing the potential of ChatGPT-like things in Bing. We've also seen a massive announcement around Viva Sales and Teams Premium. We've been working for years with the Teams team to do transcription of meetings. And that transcription can drive things like closed captioning. But we haven't tapped the full potential until Teams Premium came out. And now you can get meeting summaries sent to you and action items assigned to you in Teams. And that's just showing the power of what AI can do. So from a first-party perspective, I think that one is super interesting. From a kind of a third-party customer perspective, I'm going to pick a totally different one. And I would focus more on the impact that some of our responsible AI tooling has had. The National Health Service in the UK has been completely inundated since the start of COVID. And they have been using the responsible AI tools inside Azure Machine Learning to help drive clarity and confidence in some of the machine learning models they've created to figure out where surgery patients should go for their hip and knee surgeries, whether they need to go to a major medical center or they can go to a smaller regional medical center based on a risk assessment profile. And so, obviously helping customers is huge. And that was just an amazing example of, basically doctors kind of working with their data science teams to help an immediate and local problem using the tools my team creates.
What do you think are the 3 topics that people should be educated in?
I'd call out 3 things. And it might be the same even if I were talking to like my sister who is an educator in Germany. The first thing is understanding responsible AI, understanding safety, understanding regulation, and understanding kind of the current truth and the current lay of the land around these large language models. There is a huge amount of fear, uncertainty, and doubt out there being spread by everything from competitors to folks who just don't know anything. The regulations are changing very, very quickly, and the technology is changing very quickly. I think understanding responsible AI, what it means, understanding what Microsoft is doing, is probably first and foremost on the list, and making it real, because it is going to change very quickly, but that knowledge is the foundation of kind of answering a bunch of questions about things. I think the second thing that I would point to as something everybody should know about is kind of large language models and this evolution we're seeing around what you can do when you can't actually take a model and retrain it from scratch. I think we've trained ourselves over the years that the only way you can do powerful things with a model is retrain it from scratch on your own data. These models, it doesn't work that way. I mean, these models take months to train on supercomputers, right? And I think now we're starting to give people fine-tuning APIs and more tools on top of it, understanding what you can do with these, understanding prompt engineering, and what's coming after that. That is kind of a major thing for everybody. The third one is actually more a kind of a longer lead pair of technologies. The first one of that is reinforcement learning, and then the second one is privacy-preserving training or federated learning. And these may be like the nuclear fusion of artificial intelligence. We've been talking about them for years, and we're starting to see point applications. I think the ChatGPT's use of RLHF is starting to cause a lot of more interest in reinforcement learning. And certainly as we roll these models out more and more, dealing with the questions about how do you actually fine-tune a model without needing to take the data back to the source is something that we're going to have to think about more and more. So knowing about those two categories of technology is probably a useful background thread. It's not immediately practical for most developers or data scientists or IT admins, but knowing what they are and basically how they work is probably another good foundational thing for folks to understand.
Sounds like lots of good things to dive into for IT pros, developers, data scientists.
Absolutely.
Yes. Thank you so much, John, for being here with me.
It's been great to be here. Thank you.
Well, that was a very interesting conversation you had with John. He really showed us what the strategy Microsoft has for implementing AI in their products and also the future that they're looking into. But also he shared us 3 different topics that can help us to learn more about AI.
Yes, that was really valuable. And he also briefly mentioned OpenAI. And that's what you're going to focus on together with Bob, right?
Yeah, really looking forward to that conversation.
Yeah.
Thank you, Bob, so much for making time for a quick chat. Could you introduce yourself for the people who do not know you?
Sure. Well, it's a pleasure to be here. My name is Bob Brainart. I'm within the Microsoft AI Platform Engineering Organization. And myself and my team have the fun of engaging with customers and partners all over the world to bring them onto Azure OpenAI service, customers, partners, MVPs.
Can you explain to people what OpenAI exactly is?
Yeah, so OpenAI, it's the latest in the series of models that are produced by OpenAI. They're large language models, they're generative models, they're transformer models. And really what that means is instead of taking a smaller purpose-built model, something that does text analytics, something that does translation, it basically has multiple capabilities built into the service itself. So in the case of OpenAI, it has fantastic language capabilities with the GPT-3 models. Also, one of the cousins of that is ChatGPT, which has really captured the hearts and the minds of everyone around the world. And there's also the ability to do text to image with the DALL-E model. And then last we have Codex, extremely important, really to democratize software development and providing people access to SQL databases that aren't SQL devs. So it just brings all of these different capabilities together through a single API. And it's super powerful because it enables people to take what they would have been using, like 6, 7, 8 pre-built task-specific models, and then use the OpenAI service to do a whole variety of tasks. We call this model as a platform. So it's really a platform to build applications on top of.
Okay. I can imagine with the services now open to the public, the information that is putting in by the public is also very interesting to make use to improve new models.
Yeah, that's a great point. Because like with our friends at OpenAI, yeah, when ChatGPT is learning, millions of people are using it, that feedback goes right into training the next instance of the model, and it's really powerful because it builds in real-time feedback. And like one of the common things we get with enterprise customers is they don't want their data to go into the model. I think I know where this was going. And so we do have that enterprise promise in Azure that your data is your data. Yes, you can use your data to train the model, but an enterprise's company secrets and so forth are not going to go back into the model training. But so we have the best of both worlds. So we have OpenAI continually retraining, and then our enterprise customers with that sort of data security value that we provide.
Yeah, which is very important, of course. Well, it's quite interesting. Now, you've been talking about Azure OpenAI, but there's also just OpenAI. Mm-hmm. What exactly is the difference?
Yeah, that's a great question. Yeah, I always like to start off just by talking about what is the same. First of all, every OpenAI model that's released is trained on the Azure supercomputer. So think of OpenAI as an Azure ISV of sorts, very strategically important one, but nevertheless they're very similar to other partners we have, right? In terms of just sitting on that Azure infrastructure. And then, same with, of course, Azure OpenAI Service, a completely separate instance of Azure infrastructure, but still, both sit on that. So that's similarity number one. Similarity number two, it's the same models. Yeah, these models are stochastic. You will get different responses if you ask the same question multiple times. You'll get that with OpenAI as well as across OpenAI and Azure OpenAI. But the models are exactly the same. They're the same code base, the same instances of the models. When you get text DaVinci 003 on OpenAI, you can take that work, reproduce it, again, within the stochastic characteristics of the models and get the same type of responses. So we see customers working on OpenAI and then directly transferring that knowledge over to Azure OpenAI Service very seamlessly. We have one customer, Trellant, a startup, who moved from OpenAI to Azure OpenAI. He said it was literally 3 lines of code, to change his app to be able to use Azure OpenAI. A couple of things on the differences. Customer preference is super important to us. We love when customers work on OpenAI, but what we see with the largest enterprise customers and also ISVs that work with enterprise is there's certain security features and enterprise features that companies need to take something into production. There's also regulatory compliance. So if you look at from a security perspective, we support, the Azure networking like ExpressRoute and private links. We support, we have this data security policy that your data is your data. We also, the service is HIPAA compliant, for like healthcare companies, SOC 2 compliant. So regulatory compliance is also super important. One of the other major differences is geodiversity. We do offer Azure OpenAI Service in multiple Azure regions around the world.
So what you're actually doing, you have the OpenAI services, you're building a nice layer on top of it with extra security, making sure it's in different regions, actually bring it to an enterprise level. So you've talked now how enterprise organizations are already making use of these services. Can you give us any example, a use case?
Oh yeah, absolutely. So we see with use cases, the language use cases are grouped into 4 sort of buckets or broad categories. The first we call reason over structured and unstructured data. And in the beginning we were kind of looking at all these different model capabilities, and they're basically classification, sentiment, type of classification, search, and then entity extraction. And we said, what are people actually doing? Well, they're getting reasoning, they're gathering reasoning over data, over structured and unstructured data. And then that usually feeds into other model capabilities where, a customer will take a call center record, do those types of things, and then use the summarization capability. So summarization is the other use case category, very common with call center transcripts, large technical documents, et cetera. The third one is conversational AI, and I don't need to explain that. You can look at ChatGPT and see the amazing capabilities that we have there. And so the other one is writing assistants. Companies that are using OpenAI to basically write blog posts. A lot of people in this audience will have children that are using it to write homework assignments. It is done out there. And then also we see it a lot in marketing campaigns for developing taglines for email headers, et cetera. So there are a few case studies that were out there. I mentioned Trellant. CarMax is a customer that's been using it to summarize thousands of automobile reviews down to a very coherent description. Saving thousands of hours of collating all that information together. We have Farmlands out of New Zealand who's actually using it to look at the sentiment of their agriculture retail customers. Really interesting use case. I mentioned Trellant. What they're doing is they're using a Codex model to generate doc strings for code documentation for legacy code. So there's a lot of really interesting customer engagements out there, and more to come.
Yeah, I can imagine that. It's interesting times that are coming with all the new things that are coming up. Well, linked to that, how do you think the future of OpenAI services is going to be?
Yeah, I mean, the future happens every minute. I think we heard some announcements today, about incorporating OpenAI into Bing search. So yeah, it's a very, very fast-moving space, but there's really a few key areas. One is responsible AI, and we'll cover that in a bit. The second is, if you take a look at these models, right? You've got text-to-speech, you've got, text-to-image with DALL-E, you've got coding, you've got language. Multimodal is something that we're looking at moving forward, where these multiple model capabilities are all converging onto sort of a single model, single API. So that's something to look forward to. Also, being used, for more forward-looking, like external users, social media type things. Right now, responsible AI is a bit of a concern, just because these models are generative, and we have to take the responsible AI and really test it out over time. But I think we're going to start seeing it much more wide used in that. As well as in mission-critical applications. I mean, Azure OpenAI Service is built for those types of enterprise deployments. But really the big things are multimodal and also some of the advancements in responsible AI.
Okay. Well, you already answered my last question a bit concerning responsible AI. I think that's something we really need to look more into because it's so important. But Bob, I can only thank you for this very nice conversation. And I'm really looking forward to what OpenAI is really going to bring in the next coming levels, next weeks, months, and for Microsoft and also for the world. Thank you very much.
Thank you for having me.
So Bob really told us a lot of exciting stuff about OpenAI. This is really going to be a huge game changer in the tech industry.
Yeah.
I'm really looking forward to everything that this is going to bring in the upcoming years.
For sure, I'm also looking forward to that. But I think our next guest will really giving us an example how OpenAI has been embedded in a business application. Let's have a view also on that.
Let's do that.
Hey Sharon, thank you for joining me today. I hope you're doing well.
Yeah, thanks for having me.
Well, I've heard you've been working also on the release of Bing OpenAI, the combination of it. Can you tell us a little bit more about it?
Yeah, it's been super exciting. We've seen the buzz, all this week. And our team really came in towards the end of last year, really thinking about the responsible AI and, how do we think about the societal implications of releasing something like this following the ChatGPT launch and the excitement over it.
Yeah. Well, since you are focused on the ethical part of AI, what were the things you really had to look into in releasing a product like that?
Yeah, I think the initial version was really about understanding, how do we set the right mental model for a technology like this? It's super impressive. It can create, it can cite information. And so we found that people tend to over-trust or over-rely the kind of information it generates. And so a lot of what our team did was like, how do you set the right mental model for users? Reminding them, hey, this is from the internet, just as reliable as the internet. Some things are factual, some things are not. So that was our initial step, was really around education, around user transparency. But there's so many more places that we want to go to in terms of what is the future human AI interaction model that we really want to create with a technology like this.
Okay, that's quite interesting. Now, the tool the model that is used behind the service is ChatGPT, where it consumes a lot of data to get trained.
Right.
How does it get curated that the data is, for example, unbiased?
Yeah, so there's like a slight note where it's actually not using the ChatGPT 3 model directly. It's actually using something called Prometheus, which was a joint model that was created from Bing and OpenAI to really tailor ChatGPT but for a search scenario. So for example, limitations of ChatGPT is that it doesn't have current events, right? If you use it on OpenAI, it's limited to I think the end of 2021. Prometheus now allows actual grounding that against Bing's existing search index. So you have a grounding of that information. You're able to actually have citations. It's able to point to the sources it's referencing. And so those are the new things in terms of bias. But like I said, this is based off of the internet. And so there's a lot of biases inherently woven into the internet. And so it's a little bit it's inescapable for it to be able to replicate some of those biases. I would say on the platform level, there's been a lot of work in terms of safety, like content moderation, how do we think about safe inputs and outputs? If users tend to ask, being like, hey, I got this, prescription for my medication, does that look right? It will, tell you, hey, you should consult the medical professional. And so we had to think about those kind of safety scenarios as well. Yeah.
Now, I have a question also concerning what a company needs to do to get an ethical AI strategy, but I think it's a good idea to also get a little bit more clear overview of what ethical AI exactly is.
Yeah, it's a loaded question.
Yeah.
I think, there's so many aspects to that. I would say with ethical AI, it's not about right or wrong, right? Because, your ethics are different from my ethics. And, how do we really determine what that is, especially for a company like Microsoft? We're an international company with international consumers. And so when we say ethics, we're really about how do we be really intentional about what we build? When we build something, how do you think about not just its initial impact, but the second order implications? And so again, it's that word implications. How do you think about the deeper consequences? How do we think about not just your direct customers, but like who is affected by your product, even though they don't necessarily use it? For example, back to the ChatGPT scenario, if people are using it for medical professionals, even if doctors aren't directly using it, it might affect them because, their patients might not be going to them and say, hey, I got this prescription or this diagnosis, what do you think? And so we think about those different layers. And so I think for a lot of companies for ethical AI strategy, it's investing in that longer tail consequences because those longer term things will affect you and just being more intentional about, thinking about the consequences and implications of what you're building.
Okay. What advice would you be able to give organizations that want to implement AI in their solutions?
I honestly do think it's really about, the innovation part is what's captivating everybody, but really thinking about not just the application, but the implications. And when you talked about your earlier question of how do you build an ethical AI strategy, I think at the core of the culture and the leadership, you need to believe that's important. It's not always easy because ethical AI, you might not see the bottom line, impact right away. But on the long scale, at Microsoft at least, we take it so seriously because, we're not just a company here for the next 10 years. We hope to be around for a much longer time. And to do that, we have to be building towards a better society for that to exist.
Okay, thank you very much for these nice answers on my questions. I'm looking forward to see more of you and your team also read articles or see videos about it. Thank you very much.
Thanks, Sammy.
Well, that was a really interesting conversation I just had. I'm really looking forward to where AI is going to be embedded in even more business applications.
Yeah, me too. And there is also another field where AI can have a huge impact.
Okay.
That's accessibility.
Oh yeah, of course.
Yeah, so we're now at the Inclusive Tech Lab where we're going to have a chat with Donna Sarkar about this. So let's go inside. So hi Donna, thank you so much for joining me today. How are you doing?
Awesome. Thank you so much for being here.
Yes, really great to be here and have a conversation together with you. So I'm going to ask you a couple of questions. So we start with the first one.
Let's go.
Can you tell me who you are and what you do at Microsoft?
Absolutely. I'm Donna Sarkar. I lead the accessibility tech program for the company, which means I look after the, let's say, many thousands of products we ship externally, all of our websites, and all of our internal tools.
So we talked a lot about AI and how it can help people in their daily lives and in their work. Can you explain how AI can also help people with an accessibility need?
Definitely. So I absolutely love both of these topics and the intersection, right? Because AI is magical and having quite a moment right now. And accessibility, I think, is one of the most fascinating tech areas because you're legitly innovating with a real purpose. You're not making like Uber for fresh fruit, right? It's got like a real reason to exist, all this cool innovation. And when you look at the intersection of the two, you're looking at ways where you're legitly solving the equity divide. And there's three things that I've seen Microsoft do in the last few years that I think it's really important to call out. The first one that we talk about a lot are captions, right? These are Azure Cognitive Services, Azure Speech Services, derived captions, and they've been starting to make them themselves make their way into every product. First was, of course, PowerPoint, which if you don't have captions on in PowerPoint by default, do it. Second one is Teams. And the third one, and most recent, and I think the coolest, is Windows 11, because they're available offline as well.
Yes, it's really built into the product. Uses the mic, and then
Yes.
Yeah, that sounds really great.
Yeah, so captions is the first one. The second one is totally nerdy, but I love GitHub Copilot. I absolutely love it. I'm a developer, so having this machine generate the first draft of code for me that I can then refine is pretty cool. The part of GitHub Copilot that I don't think people know about is GitHub Copilot Labs. This is the experimental mode of Copilot where they test all these interesting features and functionality before they go live to everybody. They're part of their nightly insider builds. And there's a brand new one called Explain, where you can highlight a chunk of code and it'll explain in natural language what it does. I use it when I'm getting familiar with a new code base or some product that I've never worked with before. The third thing that I've really liked is for neurodivergent folks, right? I'm a neurodivergent person. I have dyslexia. And one of the things I have really appreciated is this thing called Teams Meeting Recap. So say you and I have a Teams meeting and we record it, and then I'm thinking, what did I agree to do in the meeting, right? Because you assigned me some homework and I promptly forgot because neurodivergent urge to forget. But the recap meeting notes actually just call out and say action items assigned to Donna, action items assigned to Hank, assigned to everyone. And what a good way to, first of all, volunteer people to do work, but also a really, really solid way to make sure that whether you were in the meeting or not in the meeting, you didn't miss anything really obvious. So
It really sounds amazing.
yeah, so those were the three that I've really loved recently.
Wow. Which project really stood out for you?
So, of course, we're looking at recency bias, right? We just had the Bing Edge launch on Tuesday. That was a big deal. That was fun, though. My team got to work closely with the product teams to make sure that not only are these new generative AI experiences accessible from a screen reader or any other disability type point of view, like, yes, I can use them, but they're useful and usable, right? So how can this be really useful towards someone who may have, say, limited mobility? One of my colleagues, Christina, her arms are paralyzed and she types with her toes. And watching her use this product is really cool because she said, oh, I now just have to type one sentence rather than typing lots of sentences to plan a trip, for example, right? We're trying to plan a conference, an offsite, and she's able to do research so quickly now compared to before. And the same with me, because I will get distracted on anything. So being able to plan just a wheelchair-friendly trip to Europe with a whole bunch of takeaways, and in line, it's like, look up airfare, look up hotels. It's just a pretty magical experience.
Yeah.
So, and I think we're only getting started at what this thing can do. And that's the Bing part. The Edge part that I found very, very fascinating was this feature called Summarize, where using, I think it's only in the Bing Edge, the Edge dev build right now, which is you copy in a whole chunk of text and it'll pull out a summary of it. And we just did that with this document that we were supposed to read. It was a very long document. It was 12 pages. And I thought maybe we can just try the summary feature. And I did the summary feature and I asked my legal friend who's really good at reading documents, is it accurate? And they said, actually, it's pretty accurate. So you can imagine that's kind of a game changer for people because it gives you this like easy button shortcut key toward not having to read a large quantity of words if you are a dyslexic person like me.
Yeah, it's really a major step forward for including everyone here.
That's right. And just making life easier for all kinds of people.
Yeah. It is really difficult without including everyone to build these types of products. Yeah,
right.
Nearly impossible.
Oh, and I'll give you one plug before I leave you. We have our Microsoft Ability Summit coming up on March 8th, which is our big accessibility conference. There will be a lot of surprises, a lot of new things announced, a lot of really cool tech demos. And there are some pretty amazing A-list guests attending this conference. It's one of my favorite things of the year, so I highly recommend everyone check it out. Just look up Ability Summit Microsoft 2023. I'll see you there.
Okay. Thank you so much
Thank
for this conversation.
Good morning, good afternoon, good evening, everyone. I hope you're having a great Global AI Bootcamp London so far. Hi, everyone. My name's Terry McCann. I'm one of your co-organizers today. I'm an AI MVP and love all of this stuff, right? And watching the keynote back, I look back, so looking back at the kind of history that Sammy and the team were taking you through of the Global AI Bootcamp, and it brings back all these great memories from being in person pre-pandemic at the kind of first Global AI Bootcamp that we ran in London, and just reflecting back on previous years. It's just a phenomenal event that's been created, and I thank the team very much. And I wanted to start by just reflecting a bit back on the keynote that we just saw. And one of the things I'm always blown away by at the Global AI Bootcamps is just how great the keynotes always are. They're always kind of struck a good chord, and they're always just really enjoyable to watch. And I found this one particularly interesting, getting an idea and an understanding of what the different product teams have been involved with and how they've been using it and kind of their influence on a lot of the products that we're seeing. You know, always super interesting to see. And I love John Montgomery's kind of question around what were the interesting things that you've been doing with ChatGPT. And I was thinking back, like, what are the interesting things that I've been doing? And I've used ChatGPT for a whole load of like useful things, but also some silly things, because that's the great thing about AI, right? Why use it just for work-related things when you can do silly things like create poems to serenade your colleagues or write blogs about ChatGPT written by ChatGPT, right? These are some of the interesting things that we can kind of use it for. But I've also used it for the normal things, right? Writing sales copy, responding to emails. And also, if you get frustrated with somebody commenting about something on LinkedIn, you can use ChatGPT to just write a response. So those things are always a lot of fun. But I think they raised some really interesting points in the keynote, particularly around the idea of over trusting the responses. And we saw this a lot with Google's Bard as well, and kind of what the impact it can have by a generative model generating something that doesn't necessarily portray reality. And I think, you know, it's one of those really interesting topics that everyone always needs to be aware of, that it is only as reliable as the data that it's trained on. And when we're looking for more and more data and bigger models, we have to look wider, right, at a lot of natural language. And I just thought, I didn't know that Bing was backed by Prometheus and not by ChatGPT. So it's a very interesting, an interesting model that you have there. I always think ChatGPT really shows its age as well when you ask it questions such as, who is the monarch of England? And it will come back with Queen Elizabeth, because as they mentioned, right, it has been aged. So there's some really interesting topics being raised in that keynote. And so a huge thank you to Sammy and all of the team for putting that keynote together and for organizing the whole host of events that you're part of today. And what I would also just say, like one small plug would be, if you want to learn more about large language models, go and check out our podcast, Totally Skewed, where we have an episode devoted exclusively to large language models. So welcome everybody to the Global AI Bootcamp London. This is the second year that we're doing this remote. And in 2022, the 2022 event was probably my favorite event of the whole year. We ran it quite simply. It was just a single track with 8 speakers from 5 different countries, covering a whole host of different topics, from ethics all the way through to ML ops. And I personally learned an absolute ton from that day. And I often reflect back on some of the sessions that I saw because they were just so great. And this year, I really hope it's no exception to that. But what we wanted to do this year was go slightly bigger. So you might be watching this from YouTube, where today we are streaming our content, not just through our normal channels, but also across YouTube, hopefully to give everybody more ability to see a lot of the great content that we have from our speakers today. And I said we're going bigger, right? So how are we going bigger this year? Well, for starters, we've got 2 tracks this year. We've got our 2 tracks, which are Johnny 5 and Wally, and you can kind of chop and change between which one you want to see most. And with the content being streamed, you should be able to catch up on it later via YouTube. But what's the difference, right? Where should you focus your time? And so Johnny 5 is more around applied AI use cases, kind of practical tutorials focused around AI and data science. So today, you could learn things such as, how is AI impacting the financial sector? What are some of the use cases, and so what are some of the ways in which a key industry like finance is really being improved and kind of revolutionized using AI and machine learning? You can also learn topics such as Tensorflow.js, how to build a model, embed that in one of your web applications, potentially, enabling you to scale your models across your web apps. Looking at digital twins, IoT, with the Internet of Things, Azure ML, communicating model results effectively. That's a really interesting one that I'm really excited to see. And then also how to give your application a voice, right? How to use kind of text to speech. So really looking forward to that. Then over on the Wally track, our track is more dedicated to ML ops, model development, model deployment, and extending machine learning. So we've got talks around getting started with ML ops, using DevOps to really expand the maintenance and your kind of usage of machine learning. We've got talks that focus around Onyx, responsible AI, Power BI, and how to build out enterprise chatbots. So I really hope that there is something there for everybody today. And I'm really looking forward to your comments and being able to kind of chat with our presenters about their topics and about their particular areas of interest. So we do really encourage you to add your comments into the chat, and then hopefully we can try and answer those questions that you have with our speakers live today. So 2023 for me truly is the year of AI. And in particular, just looking back at what the keynote was covering in terms of the huge amount of content coming from Microsoft this year, all aimed at really trying to democratize AI and machine learning. So this year really is the year for AI and machine learning, and in particular, as they all mentioned, right, the year for large language models. And so large language models have really started to kind of infiltrate our daily lives, from the ways that we work to the ways that we learn and the ways that we entertain. One of my particular favorite uses of large language models recently is the never-ending episode of Seinfeld that is constantly airing on Twitch. It's a great way to kill a load of time if you want to, and generate some hilarious, very Seinfeld-y content. And so it has really infiltrated our daily lives. And as Donna mentioned in the keynote, things like Copilot have really improved my personal efficiency as a developer, ensuring that I can generate an aspect of the code that I want to use. But also ChatGPT, by having DaVinci and the Codex models behind it, are also able to be very useful for generating code snippets to kind of reinforce a point that I'm trying to make in some content or a communication back with my wider team or back with a customer. And so I really think that with ChatGPT also becoming available in beta across the OpenAI service, it's never been easier for anybody to get started with machine learning and AI, and also to create a company from scratch almost within a handful of hours to really offer value back to whoever it is that you're trying to service. So with that, I really hope that you have a really great global AI bootcamp. And one of the things I love about the Global AI Bootcamp is that it has content for everybody. So today, if you're coming here thinking, gosh, I have no idea about any of the things that they talked about in the keynote, don't worry, right? We've got content for you. If you're an incredibly advanced practitioner who's been building out machine learning models for years and years, then we have content for you as well, right? And we have something for everybody in between. So I really hope that today you can learn something that you can take back to your day job, to take back to your colleagues, to take back to whatever it is you want to do, or to hopefully encourage you to start thinking about how you might be able to use AI to advance your own career. And we really wish that, everybody has a really great day. So before going into what are the first kind of talks that we have today, I just want to call out a huge thank you to everybody who is part of the Global AI Bootcamp globally, but also to our organizing committee today. So a huge thank you to everybody involved in organizing today. And you'll see a lot of them speaking across today and giving various different talks. But also thank you to our sponsor, Advancing Analytics, who have put together all of the streaming that you're seeing together today and everything else. So a huge thank you to kind of devoting the time and the effort around that as well. So everyone, have an awesome day. But right, where can you start, right? Where should you focus today? So what are our kind of two first talks that we have? So in Johnny 5, we've got Sebastiano talking about digital twins. And digital twins are one of these really interesting topics that come up time and time again, particularly if you work in manufacturing, but also in a lot of wider areas and some really interesting use cases as well around augmented reality. And what we saw a lot with kind of Facebook's metaverse, right, is your own personal digital twin. And so it's a really interesting topic and one that I'm really excited to learn a bit more about. So that's over in Johnny 5. Or if you want something a little bit different and you want to know more about how you could possibly do real-time scoring in machine learning, hopefully in a nice, interesting and simple way using Azure Functions, then you want to head over to Wally and see Alex's talk around real-time scoring using Azure Functions. So two incredibly interesting topics, both that I'm really excited to see, but I can only watch one. So it's going to be a challenge. But I know that with the streaming, I'm going to be able to catch back up on a lot of these talks later. And so I'm really looking forward to seeing both talks today. So to close out, thank you to everyone involved in the Global AI Bootcamp. And I really hope everybody watching today has an incredible day and learns a lot and can take something away from the Global AI Bootcamp. So thank you very much and enjoy your day.
Hello everyone and welcome again back to Global AI Bootcamp London. So before I introduce our next speaker, just some reminders. We are in the Johnny 5 room at the moment. If you'd like to go to the Wally room to see Alex Billington's talk on the real-time scoring using Azure Functions, it will be in a different stream on the same YouTube channel. Also a reminder, if you have any questions during the talk, you can use YouTube comments and I'll moderate them and present them back to the speaker at the end of the session if we've got time, and you can get them answered then. So without further ado, I will introduce Sebastiano. Here we are. And talk about creating a digital twin.
Hi. So first of all, thanks for the invitation. So I guess that we can start, and today I will talk you about creating your digital twin related to NLP, because when we talk about digital twins, we can refer also to a lot of environments, but we want to focus on creating your digital copy to talk with. Before that, let me introduce myself for people who don't know me. I'm Sebastiano Galazzo. I'm the CTO of course, AI company named Synapsia, and Microsoft MVP for AI category. I guess that I stick with artificial intelligence since more 20 years now. So I could say that it's not a job, but also a great passion. So anyway, we can start our journey. And before, let me share some thoughts. Everything I will tell you, of course, is based on my own experience. As you know, AI is something that changes very, very quickly. And there are a lot of opinion. And so I will tell you what I did, my path, and maybe also my mistakes in order to allow you to avoid them, in order to speed up your job, and who knows, maybe to trigger a spike or ideas for your next project. Well, there are a lot of buzzwords that nobody needs a presentation. Also in our keynote, and Terry before talked about ChatGPT. Of course, needs no presentation. And everybody knows how powerful it could be. So what I'm going to show you is how to create our digital copy through our own model, through our own solution. And so the first question could be, but does it worth to do that if we have a tool, a powerful tool like ChatGPT? If you are following this session, and I created it, of course, in my opinion, the answer is yes. But as I write in the slide, guys, don't believe that everything is easy or magically that you can do with a finger snapping, because it's not true. It's not for free, because you have to pay GPUs, a lot, some cost, and is not effortless. Say that based on our experience, of course, is far way cheaper than using this kind of tools, the more famous tools in production for real business use. Anyway, the business considerations are up to you. Here we are to talk about the techniques. So without starting from the age of the stones and how everything started, but it's important that we remember how traditional chatbots works in order to understand better some technical choices that we did in our solution. So the reference point, in my opinion, but not because I'm a Microsoft MVP, but because I used everything and I guess that is the best product of this category, is Microsoft LUIS. Now is under the CLU news solution. And basically what you do is to design your conversation in a way that is showed in the graph on the right. So you have to imagine more or less all the stages of the conversation, and then add a lot of sentences in order to manage all possible cases. So, well, Microsoft LUIS, like other tools of this family, is basically a classifier. So what you do is to create a list of intents, like book a flight, location finder, make a reservation, or everything you want. And each time you provide a query, the model classifies in which category it falls with the highest probability. Then it's up to you to match an answer to that label. Okay. So it works, of course, and I believe that is still a valuable solution because I'm not a fan of last fashion at all cost. And the pro of using a solution like that is, of course, that it is easy to use, good performances, and very important, you have most the full control of the conversation. For people who deal with NLP and what are some cons of ChatGPT that I will introduce after, will understand what I mean. And again, I think that is still a valuable option, but of course there are cons. One of the main cons is that they are you have a restricted domain because the larger the domain is, I mean the number of intents that you have in your project, the most difficult it is to balance and to make the model working. So let's say until you play, okay, or the model is very, very small, they perform very, very well. It's something different when you have a much more complex situation. So, of course, now here that comes help OpenAI. That again needs no presentation. I will not spend time introducing what it is. Of course, everybody knows that is the state of the art. But I want to focus on the main difference between how OpenAI works compared to Microsoft LUIS, because this is one of the key of our solution and why we did some choices in our architecture. So basically, the difference is that this kind of models try to predict the best word in the sentence. So without going in deep, of course, there is a lot of literature, and this is not the goal of this session. You have to keep in mind that principle. So you do not classify a sentence. You really create the answer. That's awesome, really awesome, because everybody knows that we got an unprecedented conversation capabilities. But of course, there are some cons. And one of the main cons that everybody knows is that the large language models are trained with unsupervised content coming from the web. The web is full of content coming from human, and not all human are smart or good people. And then despite they did a very good job, an amazing job trying to reduce biases in their data set, and based on what I described in the slide before, or that you don't have the control on the answer, because compared to Microsoft Lewis, that it's up to you to match the answer to the correct label. In this case, you totally don't have the control over that, and you are subjected to some kind of biases. This is a well-known problem, and of course, costs. Anyway, is a news of yesterday, I guess, that OpenAI dropped the cost of the best model. Anyway, is still much more expensive than common solutions like Microsoft Lewis. And if you want to do something more custom, of course, you can fine-tune your model, but say that it costs twice than the standard model. So why I'm focusing so much on cons? Because when again we want to play, when we want to create our own video and catchy video about ChatGPT or how it works, that's good, that's fine, okay? But when we have to create something for business, for real users, this is very, very painful, could be very, very painful, even though if you face with one of these biases, or even if it's not a bias, but being on the fact that you don't have the control on the answer, could happen, because happened in tons of tests that we did, that the model will reply in a way that is not good for you. So we need to find a way to address the cons of this kind of model. Else we can't create our own digital twin, because nobody wants that our digital copy start talking about something that doesn't represent me, or worst, start talking very bad some argument and so on. So the key point that we have to address are biases, and the only way, at least for common people like us, is to use our own dataset. In fact, we invested a lot on our dataset, and try to solve the other limitations and cost, because of course OpenAI, thanks also to Microsoft and Azure, they can take into account to have thousands of GPU to run this huge large language model. Anyway, if you want to create our own, I don't know you, but I guess that for a company, for a normal company, it's impossible to have all these powerful computation and the systems. So we need to find a way to solve the issue, and we did that using a well-known paradigm, divide et impera. I will show you how. So after this introduction, we can start talking about the creation of our digital copy. First, let me clarify that we don't don't want to create another Alexa. Okay. We try to create a tool that is really useful for business cases, for real business cases. So one of the application could be, for example, to be your secretary, managing emails, calendar, phone calls. Yes, phone calls, because we already did successful test with phone calls. And I read also, I listened, before talking about emails and chat GPT, that they can manage your content, and that is amazing, of course. But again, in real life, we don't want that we face the risk that ChatGPT answers on our behalf in a way that we don't want, and that could happen. This is the reason why, again, we want to create our own solution, maybe less powerful from a conversational point of view. Less powerful doesn't mean is not able to do it, but much more safe. And anyway, of course, there are a lot of applications in for smart search, web and local, and obviously in the metaverse. Because that project, for example, started because 6 months ago, the main request was how we can create 1,000 of virtual profiles of people inside the metaverse to interact with with high conversational skills. Of course, in 6 months in our in our field, that means thousands of years, and so the project was modified along the path, but this is one of the applications. Well, we said that we want to create our own solution, for sure, but we don't want to reinvent the wheel. So we will use, we do not start from scratch. We will use tools and solutions and repositories like Microsoft Azure, Hugging Face for models, and GitHub, of course, for the code. In fact, well, I started from this project that you can download from the web. Of course, it's open source, and I strongly suggest you to start first from this project, because compared to other projects I studied, this is one of the most powerful and well done. Okay. So maybe you saw the date of the repository. Don't pay attention to that, because of course that's yes, that's true. 4 years ago, 3 years ago, but we are talking about the age of the Python script. We want to train our own model, so this is not a problem. And anyway, like as I showed you in the previous slide, if we want to fit our model in our GPU, we can't use models like GPT-3. First of all, it's not available, of course, and then you after that you have to imagine that GPT-2 XL doesn't fit my NVIDIA 3019 with 24 gigabyte of RAMs. Doesn't fit. it means that you have to use a smaller model. And when people thinks that they have to use a smaller model or a more aged model, they always believe that okay, it's not good because it's not the last model or stuff like that. That's not true, guys. So we are going to use a vanilla versions, like, let's say, of GPT-2, the small version, guys, the small version. I tried also the medium version. It fits in my GPU. I have basically I have two GPU, two NVIDIA 3019. But anyway, I could say that with the one GPU, you can train a GPT-2 medium, okay? But you are almost to the limit. So I suggest to use the model, the starting model of that project. So is a GPT-2 version that is between small and medium. Is a perfect size, and I can assert, I can guarantee that is enough for a lot of scenarios. So guys, don't worry. Well, first, of course, we need to talk about the dataset, because we said that to address some common issues, some well-known issues of GPT-3, Chat GPT, we need our own dataset, and we need to work on it. And thanks also to the project that I shared before, I started from a persona chat dataset, and of course I did some modifiers that I will tell you, but this is the starting point. So the idea is that to use the context that here is named the personality, to inspire the model for the next answer. Okay, so as you can see, you here have 4 sentences that describes you. So I like to remodel homes, I like to go hunting, I like to shoot a bow, and my favorite holiday is Halloween. In the history, needs no explanation. So the history is the conversation, how it develops, and the candidates. In the candidates here, it's really important, because the last sentence of the candidates is the reply of the whole conversation inside the history, and all sentences before, please pay attention, are sentences that are not related to the answer, but they are totally different, and based on the parameters that you will use for training, they will be used in a way that you could imagine like that. Okay, when you are close to this situation, please don't take into account the first, don't take into account the second, and so on, but the real answer is the last one. It works with a mechanism named masks, and they are useful if you want to tell to the model what is not the answer. Okay. So don't make the mistake I did that in the first stage I thought, oh guys, but this dataset is wrong. So I started to fill the candidates with answers that were most similar. Of course, it was a huge mistake that I did, and after studying the code much better, and I would say the documentation, but there is no documentation, so I'm very happy to share that because I busted a bit of time here. So I've understood why all the sentences were so different from the answer. Said that, this is the data set to start with. Except active learning, that is something that I added, and we will talk at the end. And guys, of course, it works. I will not show you a demo right now of how it works. But first, said that it works, of course, it is very limited because 5 sentences to describe a person, I guess that you agree with me, are not enough. And so I started to imagine an architecture that was able to manage much more content about the person. You would say, what is the problem? Add more content to personality. No, guys, that can be done because, for example, models like BERT or these kind of models have a limited space. In this case, we are talking about 512 tokens. Tokens, I remember you that it doesn't mean always one token, one word, but more or less you can imagine that relationship. And so if you introduce much more sentences, of course, you will reach the limit very, very soon. And so the model doesn't work. And after, that is not less important, as a trick, the more content you add, so the more you are close to the limit of 512, the worse the performance are. So you have to try to keep the content the smallest possible. And so based on that, I studied an architecture like that. So I say, what happened if I introduce an AI, a first level AI, like Microsoft Lewis, that classifies basically the question, and then based on the label, I can select the sentences related to that label of my personality. In this way, using this technique, I'm able to manage 5 personalities by the number of personalities that I created. In this case, for example, career, food, hobby, family, traveling, and whatever you want. So once I extracted those sentences, this is the input together with the history of the conversation of the model that I showed before. And so I started created a data set with my team, and here you can here there is an example. For example, here there are my own personal data with some sentences that describes me and my life about food, hobbies, and again personal data and so on. On the left, sorry, you can find the version of Microsoft Lewis with some labels that the team created that could be useful for describing a personality. So you can add also hot topics, like, for example, sexuality or religion. That doesn't mean that there is a not chat, but just to manage some biases, because if you classify very well that content, it means that is not passed to OpenAI, where you don't have the control. It is much easier to detect this kind of content with Microsoft Lewis than with transformer-based content model. Sorry. So it is also like I have a shield, so to protect myself. Well, something important is one parameter when you train your model, that is personality permutation. By default is 1, and it is my option. What it means? It means that while training, the code basically turn around the sentences in a way like this described on the left, and in this way, basically, the higher is the value. I realized that the more generic is the model. It means that if you, for example, have 100 characters, everybody with their own personality, if you leave personality 1, the order of the sentences is a very important partner to understand about who we are talking about. So it's like a way to identify Sebastiano, to identify Paul, John, or Mary. Okay, and that could be useful because you could add, as we did, some dialogues associated to each character in order to reply the way they speak, their speaking style. What you could say is that, for example, okay, what we can do is to add an ID inside the data in order to identify very, very well each character inside our dataset. That works because I did it. But anyway, in this way, you lose the zero one-shot capability of this model. In fact, if you train very, very well this model, and tomorrow you had a character with just a list of sentences that describes that character or that people, basically you don't need to train, because it works, because the model learned how to be inspired by the sentences that I sent to him. If you add an ID to identify that people, you lose this feature, because of course you need to train with this new ID. Anyway, Microsoft Lewis was great, but was not the final solution, because of course tools like Lewis categorize just sentences, not dialogues. And that is a limitation, because let's imagine that you have a conversation like that. So it is our own choice. Doesn't mean that is good. It's just a label. But we decided that dogs are all pet inside the category family. Okay. So do you have a dog? Could be classified really easily like a family. And then I will be able to extract my 5 sentences that describes me about the family. Maybe there is one of them that talks about my dog or not, and I will reply accordingly. But what happens if the conversation develops in such a way? Do you have a dog? Yes. His name? Alfred. So what could classify Lewis if I try to classify just Alfred or just yes? Of course, nothing. And then I had to find another solution. The solution was to use the same project to do the job of Lewis, training it to classify dialogues and not sentences. What I did is shown here. So I used the same labels used in Microsoft Lewis, and them were used like the final sentences. So, and I don't need the personality in this case because I have just to classify the dialogue. And on the right, you can find the data set that I created for that classifier, and compared to the left to the data set that I used for the dialogue managing. Okay, and you can find the difference, because in candidates you don't have, of course, the reply, but you have the label that you want to use. And then I did also another test that it worked. I trained these models in a multilingual. So today works in English, Italian, French, and Spanish. And I needed the language detector, but I realized that it is expensive in terms of space and computation, because I needed another GPU just to run that model, and I wanted to pay a service that each sentence called that service paying for that. Even cheaper it could be. So I tried to add another label to the first one, that is of course the language, and guys, it works. So good for us, because with one model we did 2 jobs. So in this way we were able to solve, and I will show you. Okay, so here is our internal tool, and of course this is the digital version of me, my digital twin. Here are, for example, the sentences of me. This is what describes my family. I have 2 brothers, where I come from, I'm married, what I like about food. This is the managing also insults, and personal data, physical look, and traveling. Here there are some travels that I did. So let's try. Okay, in this case, the salutation was classified as a personal data, just our choice. And what are you doing? Okay. I remember that not always is possible to see the screen. I hope that you can read very well. Anyway, this answer was inspired by that sentence. So again, I don't have the full control of that content, because the final decision it's up to the model, okay? But anyway, this is a way to strongly drive the content of my reply. And here, for example, I don't know, so I could say, are you married? Stuff like that. Yes, and so on. Of course, if I change and also another character, for example, Alexandru is another. Hi. Who are you? It is the same model, guys. Okay, is the same AI that is able to manage more than 100 characters at the same time with this technique. Okay, here there are a lot of information coming from that. What do you do for a living, for example? Yeah. Okay, of course, the answer is inspired again with the sentences of his own character. If I ask the same thing to me in English, hi, what do you do for a living? As you can see, the same model, different character, different answer, because it was inspired by this content. So the architecture works very, very well. But I guess that is already enough, but we did more. Okay. Because I introduced what I called the active conditioning. So what it means, we introduced that speech saying that we are focused on business, not to play. So in a business, of course, I want to earn. It's normal. Earning often comes with selling products. Then we introduced some solutions like active conditioning, and the next one, that is active profiling, that is another AI using the same model that does something else that combined together can do something very, very interesting. So, I mean, we said that you don't have the control over ChatGPT, and this is another tool that we can use to control the flow of our conversation, like we were with Microsoft Lewis, because we said that we are not able to control all the dialogue flow using ChatGPT, use OpenAI, because it's out of control. Always remember that. But maybe in some situation we miss the capability to strongly control the flow of the conversation. Here we found a way to do that a must. So I read the code, and basically what I did was to hack the algorithm, or I did some modifies. So here is the schema that I realized how it works, that is used as a real input to the model. Here we have the sentences in the first stage, and then speaker 2, speaker 1. Here is developed the history, and then there is the padding. So using some tags. What I did is to introduce a new tag to some specific rows. That is basically a way to say, okay, answer whatever you want, of course, accordingly to the conversation, but also at the end, ask something specific or talk about specific things. Here looks like I understand that you could say, okay, it's very simple, but I spent almost a month to find the correct architecture where to place the act tag. It is not as easy as maybe you can imagine. And this is the most powerful architecture that it works finally. So here the idea is exactly that. Ask about studies, and the AI, after the answer that he anyway gave, ask also about studies. And this is a comparison. So the same dialogue starting from the left. Same dialogues, I deleted the previous answer, adding ask about studies, and you can see the answer. So I tried to do the same thing with OpenAI. We can talk about maybe it was my mistake that I was not able to find the correct prompt, but me, other people, guys, spent a lot of time finding what could have been a good prompt, a good prompt, but we were not able to do it. So we realized that this active conditioning was so far is not able to. It's not possible to do it with OpenAI. Instead, it works with our architecture. In fact, here a Bichang answer, and then what are you studying? And then this is the real me, of course, testing, reply, I want to become something invented, of course. So we already have something that today, based on my experience, of course, we can do with our tool and not with OpenAI. So we did also something else. That was the introduction of another AI using the same model that basically profiles the user. We are not talking about entity extraction, guys. Don't make this mistake. It's something different because we created a lot of labels, of course, but using a triple. Inspired to RDF triples in order to create a knowledge graph of that user. Okay, so here is the dataset, how I modified the dataset to train this model for Kobe. Kobe stands for knowledge engine and so on. So it is focused on finding some structured information of you in real time. Okay. So here, for example, based on that dialogue, you can find that his name is Peter, gender male, and lives in Italy. Why is not so easy, as you can imagine, guys? Again, don't make the mistake that is so easy. It's not easy at all, because when talking about dialogues, everything changes. It's not classified as sentence. In a dialogue, I want to classify just one of the people that are interacting. In this case, for example, the user that is chatting with my digital twin and not myself. Or, for example, only all the lines or only even lines. In this case, I want to classify just the first, the third, and the fifth line. Still keeping the context of the whole conversation. Because if you use a normal entity extractor engine, even custom, and I say, and your digital twin says that is a doctor or is a teacher, because it is the profile, trust me, what will be added, what will be extracted from the content will be a label that will be used as wrong profiling. Okay. So also to do that, what I did is to use personality to highlight that the key sentences to focus on are that one, or the first, the third, and the fifth, for example. This is another technique that I tested all along my path, and looks like it worked. So, how we use all that? So basically, what we did is something like that. I conversate with a digital twin, and in the real time, I'm being profiled. I'm going to be profiled. And the marketing could say, okay, once in the conversation you get, for example, it's just an example, this free information, you can use this free 100 information, I don't care what, to show an advertising, the correct advertising for you. And how we use active conditioning in this case, because of course, if it is a free conversation, maybe you start conversate about dogs, about the weather, about something that honestly, from a sales company, I'm not really interested too. And so, for example, we introduced a mechanism that if after 3 exchanges, you don't start talking about marriage, because I need to know if you are married or not in my profiling to understand what is the best solution to provide to you. With active conditioning, we send a message to the AI, okay, in real time, please force the dialogue asking about that. So everything together comes out with a solution that we believe that is really interesting, and is not something that you can do with just one model, but you have to combine several AI models, of course, in different GPUs, and not everything you can do with OpenAI. maybe you can say also, okay, I don't want to use my own model to answer. I can use also OpenAI, and to keep the first level AI to apply, you can do that, but of course you lose the active conditioning, you don't have the active profiling, and so on. Anyway, it's up to you. It depends on what you have to do and what it is your product. Well, we finished, and next step, we are working on phone calls, as I told you. We already had very, very good results. The approach is more similar. It's just a matter to create a different data set, because talking on phone calls is, we realize that is different than chatting. And I hope to release that in the next month. Well, that's all. And then thanks for attending again. If you have any questions, I'm available. You can write to me. And if I can, I will be happy to share my knowledge and to help you. Thank you.
Thank you very much, Sebastiano. That was brilliant. I loved it. We do have about 5 minutes for questions, if that's all right with you. Yeah, cool. So I can display them on the screen. So Patuko asks, if you have a twin based on data, like business consumed data, would you use this system and stick the data over Kobe, or would you get rid of the conversational aspect and use another system?
So, like this, would you use this system to stack the data over Kobe? Would you get rid of the conversations? Other system than Kobe? Yes, could be, but we prefer in this case to have the full control, because how to say, we have to talk strongly related with marketing, and they have always specific requests, and using other tools, we realize that we don't have the same performances. I would start from entity extraction engines, or a solution like Neo4j for graph building, but nothing of that worked like this solution. Again, it was my experience. I don't tell you that this is the only way, but based on the test that we did, we find out that was faster and far away more accurate to create our own solution.
Awesome, thank you. We have another question from Terry McCann. So are there any upcoming AI models that you're excited to try and improve your solution?
Yeah, but again, based on resources of common people like us, I don't know how much rich you are, but I'm talking about me. Our company is rich, but anyway is not able to afford the cost of a large language model like GPT-3 or just on site. So I guess that talking about architecture, we do not change too much. We will stick still with the GPT-2, because also performances are very, very well. What we can do is to hack the model. So to change the architecture, to change, for example, the way how we use the data inside the model. I'm not talking just about dataset, okay, but also hacking the model. But anyway, around GPT-2 always. And I have to say that the only way to improve comes from the dataset, guys, because everybody always believes that it's up to the model. The model is very, very important, of course, because, for example, I can see sometimes the difference between the medium-sized model and the smallest one, but in the most of cases, there's no difference. Because what is really important is the dataset. So the final suggestion is don't focus too much on the model, on his architecture. That is really important, of course, because else would be no difference between Lewis and a ChatGPT or OpenAI. But again, I will never be tired to tell that the dataset is the key. In fact, we have a team dedicated and focused on creating dataset. And we are working on phone calls. This is the improvement we want to reach. I hope that will be available very soon. Google failed in this field. We can just hope to do something good with new technologies.
Awesome. I think that's probably all time we have for questions. So thank you again. Really enjoyed it. Thanks.
Thank you. Thank you again. Bye.
So just a reminder of the sessions we have coming on at the moment. So a reminder that we are in the room Johnny 5. If you'd like to go to the Wally room for the talk on role of DevOps in deployment and maintenance of ML models, you'll have to change stream. And the other stream is also on the same YouTube channel. Yeah, so we'll dive into our next session. So we've got Web Machine Learning Intro to Tensorflow.js with Patty O'Callaghan. Patty, I'm going to add you to the stream. Hello.
Hi, everyone. Hello.
Hello. How are you?
I'm good. How are you?
Yes, good, thank you. Cool, I'll get us started. So just a reminder, if you have any questions during the chat, just put them in the YouTube comments and we'll get around to them hopefully at the end of the session. Am I all right to give you the floor, Patty?
Yeah, go ahead.
Awesome. So thank you very
much. Okay, give me just a second. Just to get everything set. All right, I think we're ready to go. Good morning, everyone, and thank you for joining my session. I'm super happy to be here again. I was part of this amazing event last year, and yeah, thank you for having me. My name is Patty O'Callaghan, and today I'm going to be talking about machine learning in the web and a quick intro to Tensorflow.js. So we're going to follow, you can follow along with me, a very introductory workshop and how to use Tensorflow.js and one particular pre-made model within our browsers, and hopefully you will enjoy it. And yes, let's get started. So first, I'm going to talk a little bit about myself. My name is Patty O'Callaghan. It's a very Irish name, but actually I'm from Venezuela, from South America. I live in Glasgow in Scotland. My background education is computer science and with a specialization in artificial intelligence. I have around 20 years of experience working in the tech industry. And I work as a tech lead in Charles River Laboratories. I am also a Women Tech Makers Ambassador, which is a program from a community program from Google. And I also organize Google developer groups in Glasgow. And my favorite thing to do, absolutely my favorite thing to do is I run a code club at my local school where I volunteer and I teach kids from like 10 to 16-year-olds how to code. And we do a lot of machine learning there, so it's pretty fun. And you can scan that QR code and you can find my social media, my website, so you can get in touch with me if you are interested. Okay, so let's begin. So the thing that I'm going to ask you is to go to that address, and what you're going to find there is the workshop that we are going to follow along. So there you're going to see a lot of information. So hopefully I ask Tori to share the link on the chat so you can access it and hopefully you already are there. So what you're going to find there is the workshop that we're going to follow. Again, there is a lot of information there that I'm not going to cover during the workshop, but you can revisit that and see like the basics, the basics around Tensorflow.js. I want to thank Jason Mays from Google. He provided, like, he has been producing a lot of content for around Tensorflow.js. So a big thank you for his never-ending support for all of my workshops. All right, so what are we going to make in this workshop? So essentially, we're going to use a pre-trained Tensorflow.js model that is known as Coco SSD. Draws bounding boxes around common objects that can be found in a picture frame or video frame. And this model, out of the box, it recognizes around 80 common objects. And I will share later the repo where you can see all of the objects that it can recognize. So for example, is things like person, as you can see in the picture, animals. On the bottom, you can see my friends from GDG London that were helping me to test the model for one of my workshops. So what are we going to do is that we're going to create like a smart webcam and then do something with that knowledge. All right, so the really fun thing, what I like the most about Tensorflow.js is that obviously a lot of people that maybe they are developers and they have experience as web developers and working with JavaScript, they can have access to machine learning models and that are already pre-trained, and they're really, and obviously you don't have to have this very in-depth knowledge of data science and machine learning to be able to use this. And this opens this whole area of creativity from people from all around, different professions. For example, some of the kids in my code club, they have been using Tensorflow.js to create really amazing projects, and it's just mind-blowing to see kids at that age doing this kind of solutions. So with a little bit of creativity and the knowledge that people have around web development, they can create really, really fun stuff. So this is an example using the same exact model that we're going to see today. And this is a smart webcam to detect pets. And this was done and tested in an old cell phone. So you can, program it to detect, do you want to detect a dog or a cat? And then if it's near, let's say, a bowl full of cookies, it can send an alert to you to let you know that your dog is going to eat all of your biscuits. So it's, this kind of fun things. You can make maybe a smart pet feeder or can be connected to a Raspberry Pi, and I have seen solutions like that, like it dispense the treats to the dog when the camera finds the dog in the area in the video. So of course, again, it's not dogs, it's not only that. You can recognize 80 objects with this model that we're gonna see today. Okay, so let's get started. And what I'm going to ask you to do is to go to the step 1 of the code lab. And I'm going to show you how it looks like right here. So yes, so this is what you are going to see. And all right, yeah. So again, there's a bunch of information that you can follow along. And what I want you to do is, like, don't pay too much attention right now to this. because I just want to do like follow along the steps with me. All right, let me share this again. Okay. All right. Okay, so what is that we're going to do? We're going to create a website, a web page, and we're going to be using machine learning in the browser to classify the common objects. And and we're going to draw the bounding boxes around each of the detected objects in the video stream. And we're going to learn how to load a pre-trained TensorFlow.js model. I'm going to show you as well other kind of models, pre-made models that are already they're ready to use, ready to go. We're going to learn using JavaScript, of course, how to grab the data from the webcam stream and how to classify that image frames that we're receiving and to detect the objects, and how to highlight them using the bounding boxes. Okay, so what is TensorFlow.js? So TensorFlow.js is an open source machine learning library that runs everywhere, anywhere that JavaScript can, and is from Google. And of course, it's pretty cool that it's open source, and it's also really nice that runs over JavaScript, because that allows us to run it in a bunch of different devices. And essentially what you can do is that you can run existing models that are pre-trained. They can be models prepackaged for JavaScript or converted from Python or TensorFlow Lite. You can also retrain existing models with transfer learning. I'm not going to stop to explain what transfer learning is and how it works, but I'm pretty sure maybe some of you know, but you can also find this information on the Code Lab, the website that I share with you. So if you want to learn about how transfer learning works, you can go there and read that part. Obviously, if you have any question around it, I'm more than happy to help you and answer those questions by the end of the talk, or you can reach out to me on Twitter or LinkedIn. All right, and then of course, super nice that you can write your own models in JavaScript and train the models from scratch. And again, this is one of the nicest things about TensorFlow.js, and is that it can support all of these environments. Because again, it can actually run anywhere that JavaScript can, and that means many places. So of course, on the browser side, on the client side, you can run it on the web browsers, not only those three, of course. On the server side, you can run it over Node.js. On mobile, you can use React Native or progressive web apps. On the desktop, via desktop native via Electron, and my favorite of them all, the Raspberry Pi via Node.js. So yeah, JavaScript is one of the very few languages that can run across all of these devices without having to add any additional plugins or add-ons. And I believe that just for that reason alone, doing machine learning in JavaScript is a really interesting use case. Okay, so again, let's focus on the client side superpowers of TensorFlow.js. So the first one is high privacy, and because all the sensor data that is being sent and is being analyzed, let's say from the webcam or the microphone or other sensors that might be attached to the device that we're using, none of that data is being sent to a server to do the classification. Everything is on the browser, it's on the device. So obviously that the user data stays private. So that's very important. And also the lower latency is because there is not any server involved. That means that there is not like a round trip time from the, let's say, the mobile to the server and then back again. And sorry. Then the third point will be the reach and scale of the web. And of course, it doesn't matter anyone, anywhere in the world. It doesn't matter the background. They can open a website and enjoy the benefits of using machine learning in the browser. And they don't need to be machine learning experts or computer scientists to be able to use it. And then we have and then of course, if you're using machine learning, let's say with Python or with Node.js, you really need to have some understanding of how it works on the back end, how to install. Maybe you have to install some drivers if you're using a lot of images and videos, and you have to know, you have to have a more technical knowledge to be able to interact or maybe even create these kind of solutions using pre-made models, for example. And the fourth point will be lower serving costs. And again, because we don't need a server with like very expensive GPUs and RAM and processors, we can just, get rid of all of that and just run everything on the device instead. And hosting a website is when I started as a web developer 20 years ago, hosting a website was expensive, was complicated, but right now it's fairly cheap and easy. So it can be really, it can really lower the costs of deploying these models for the use of the final user. And yeah, well, again, is if we need that's on the side of the client side, but again, we can use Node.js for the server side and for example, the Raspberry Pis. Okay, so I'm gonna talk about like the layers, but very briefly. So we have 3 layers of APIs. So the top layer would have, like, for example, the pre-trained models that are really ready to use JavaScript classes. We can load them and use them right away. Then we have the layers API, and there we can use this API to easily build and train models using like higher level building blocks. Yeah. And then we have the other one, which is the core and the ops API, and that has like the fine control of the architecture, and there's a lot of algebra calculation. Everything is happening in that layer. So let's move on. And then we have on the client side, these are like the lower level APIs. So on the client side, of course, we have the browser or the PWA applications. And then, of course, we can have, like, it can connect to the browser, and the PWA applications can connect to the backend, but it's like the backend on the client side. I'm not talking about the actual backend of the server. So it's like where these applications, like in which hardware are they running? So the first one will be obviously the CPU. Every computer has a CPU, and that is always going to be available. However, is like the slowest form of execution for most of the models. So of course, to go faster, we can use WebGL, and that allows us to have access to the like to get the acceleration from the graphic cards and we can execute the models on those. And then we also have the super wonderful WebAssembly support, and that gives us obviously faster execution on the CPU. So it's a very good performance that we can have. Then on the server side, again, we have support for Node.js, and it can support like 2 backends, which will be the TensorFlow CPU and of course the TensorFlow GPU. And it's pretty interesting that it has the same server side backends as Python. And it's funny because some people, it has like the same inference performance as Python. And some people said, like there's this discussion that TensorFlow.js might be faster during the inference performance, might be faster than the Python one because of the just-in-time compiler of JavaScript. But there's like these kind of discussions between the two groups that are sometimes it's funny to watch. Okay, so this is my favorite part. Let's talk about the pre-trained models. So I'm going to ask you to open the step number 3 of the code lab. And again, you're going to see all of these that I'm going to explain to you. So since the release of TensorFlow.js, they have been releasing the pre-made models, and they're continually working on add more models ready to be used. And there are models in a whole across a bunch of categories like vision, human body, text, sound, and others. And the good thing, again, is that you don't really need a background in machine learning to use them. Just a working knowledge of JavaScript is all that you really need to use it. So I'm going to talk a little bit about each of those. There is one for image classification. There is another one for object detection, which is the one that we're going to use today. For the human body segmentation, pose estimation, face landmark detection is being used a lot to create like filters and a bunch of funny stuff, fun stuff that people is doing. And the hand pose estimation. So for this one, for example, one of the kids in my code club, he is 14, I believe. He's a black belt in karate. So he did a website for the smallest kids on his karate group, and it was for them to practice the kata moves at home. So what it does is like he trained the model with the poses of particular kata moves for beginners, and the website what it will do is that the kid will practice the moves in front of the camera, and the website will tell the kid if the move is right or is it wrong, because it was trained with the right poses, so the kids can have like an instant feedback, and it will show like an image of how's the right way to do it. So a 14-year-old kid did that, and I thought it was amazing because, as you might know, 5 years ago, if someone would told us that a bunch of teenager kids were going to be using machine learning to do applications like that, and it was fairly easy for them, I wouldn't like. It's really surprising, and it's also very inspiring because kids, they have this great imagination, and the things that they come up, like the ideas, is so fresh. It's really nice to see what are they doing. There is another there's another project that a kid did, I think in the US, using the hand pose estimation, and it was to translate the hand signs. I don't know how to say that in English. I'm very sorry, but yeah, to sign language, to translate it and to show the words on the screen. It's pretty cool. Then we have the pre-made models for text. They're very useful. Text toxicity to detect that toxicity on a text, sentence encoding, the BERT Q&A, and detect the intent of a conversation. So again, one of the girls, 16-year-old, she did, and it was pretty cool because all of these examples, the kids, they shared that on a Google event, and it was amazing. They did a talk about it and a live presentation. So what she did was something like, it was called my smart study buddy. So using the BERT Q&A, what she would do was like grab the test that she wanted to study, pasted it in a website, in a text area, and ask questions, and it will reply. Of course, that was in, I believe it was in September. So that was before ChatGPT, and obviously now it's like different. But the main point is that this girl was able to do it, and she is in high school, so that in secondary school, that was really amazing. And then again, you can use the speech command recognition pre-made model and the KNN classifier. All right, so what are the benefits of using pre-made models? Of course, the first one is that there is no need to gather training data yourself. And you know that when you're gathering the training data, when you're training the model, that can be like the most, you can spend most of the time and most of the money doing this step, and you don't have to worry about that. That has been all done for you. So yeah, you don't need to worry about, you just grab your pre-made model and move. And obviously that allows you to start prototyping in a very fast way and with lower cost. You can do a lot of iterations, and because of course all the hard work has been done for you. And again, this is we're using state-of-the-art research because this is coming from Google, and they're doing a really amazing job. The Tensorflow.js team is doing a really amazing job, and they're obviously always on top of all the innovations and how can they bring that kind of innovation to these pre-made models. It's easier to use, as you're going to see today, and it has really good, amazing documentation. And for some models, you can do transfer learning, which of course is very helpful. It can be very helpful for depending on the custom data that we might have, or a very specific use case. We can do transfer learning to be able to use some of the pre-made models. Okay, so let's talk about Cocoa SSD. So give me just a second. I need to drink water because I'm coming out of a cold. I'm very sorry. All right, sorry about that. Okay, so what is Cocoa SSD? Again, it's a pre-trained model for object detection, and it is trained on the common objects in context data set. I believe that data set was gathered by Microsoft, and it uses the SSD architecture, single shot detection. Each frame, it goes frame by frame to identify the objects there. Okay, so let's go to the step 4 of the code lab, and let's have a look at what we have there. So I'm going to ask you to go to this URL. Hopefully that has been shared. I'm going to leave the slide open for some seconds. Okay. And you're going to see a boilerplate. So what you can do, I'm going to explain the steps, but the idea, and you can play with this later, but the idea is to understand the code, and you can grab the code that is on the code lab and paste it, following the instructions, and you're going to be able to see it working. Okay. So this is what you're going to see. Probably they have changed probably the UI, but what you have to do is click on remix your own if that button is already is still there. I believe it is. And what it's going to do is that it's going to copy that boilerplate on your own glitch area. All right. Okay, and this is the boilerplate that you should be seeing. And if you can see that, it means that you actually remixed the project correctly. Okay. So I'm gonna see if I do this. I'm gonna follow along with you. So, okay, so I'm gonna do this at the same time of you. Let me just move this to the other screen. Just a second. All right. As you were watching the one that duplicate this. Okay. All right. I think we're good. Give me just a second. I'm not in my computer, and I have 4 screens that I'm needed them a lot right now. Okay. So all right. So the next step that we're going to do is that we're going to open the step 5 of the code lab. Let me put it here. Okay. And what we're going to do, and I'm going to explain a little bit the code, right? So what we're going to do is that we are going to copy this code into index.html. And what does it have? It has a reference to the styles, a title. Then we have this section that right now is going to be invisible, and I'm going to tell you why is that. And then it will have the area or the placeholder for the camera view, right? For the video stream that we're going to be receiving from the webcam, all right? And then this is like so easy. What we're going to do is that we're going to import from this CDN the library from Tensorflow.js, and then we're going to load the Coco SSD pre-made model. This is the only 2 lines of codes that we need to include the Tensorflow.js library and the pre-made model that we're going to use. It's that simple. And then we are, after reading that, we're going to include our script, our JavaScript file, all right? So what we're going to do is that, let's copy this into the index file. So it will be basically remove everything and copy it. So right now this button is enabled, but the idea of having it disabled is because we don't want people to be clicking, like enabling the webcam before the model is loaded. So obviously, the internet connections nowadays are very fast, and these models, they're not very big in size, but it's always a good practice to wait until the model is loaded, the model is loaded, and then when that happens, then the user can enable the webcam, because otherwise it will get stuck. So right now, this is the step that we are in. Let me share the screen here. Let's see if I can. Okay. Okay, we already did that. Did this, which is copy the code over. And yeah, again, I explained to you the HTML part of it, right? We already pasted, and this is what we are seeing. And now we're going to add the style. So what we have to do is that we go to the step 6, and we can copy the style. And again, I'm going to explain to you what is it that we're doing. So I believe this is it. We have to go to the style.css file. We're going to remove everything that is in there. We're going to paste this. Of course, this is basic CSS. We're adding a font, color, the color for the heading, the display for the video, div, and then how are we going to define the section? Now this is the part that is going to be more useful. Let's copy it as well. What we are adding here is that a class to remove something from the display. That class invisible that I told you about, and some classes for the cam view and the highlighter for the bounding boxes. So as you can see right now, we added this invisible class, and what it does is like it hides, kind of hides the button, so we cannot click it. All right, and now we're gonna go to the fun part, which is creating JavaScript skeleton. So this is where all the magic happens, right? So let's go to step 7, all right? And I'm going to paste everything, and then I'm going to explain to you what everything does, okay? So first of all, we're going to copy this over here. So what is that we're doing here? Okay, we're creating these variables that reference elements in the website, right, in the web page. So video will reference the element called webcam, the other one that is called live view. We have another reference to demos and another reference to the button, all right? Then we have to check for webcam support because it might not have a webcam and then it wouldn't work, depending on the device that we're using, right? So first, we have this function to check if user media is supported. And if not, we're going to get a message that says that user media is not supported by the browser. And if it is supported, then at this button, Enable Webcam, we're going to add an event listener. That means that when you click that button, it's going to go to the function called Enable Cam. All right? So right now we have a placeholder. So let's put the code in there. Okay, and I'm going to explain to you what is that we're doing. Okay, so now here we have the function enable cam. Let's copy it and put it here. Don't worry about these issues right now. Okay, so what is it that we're doing? Okay, when that button is pressed, we're gonna get the event, and if the model is not loaded, we're going to exit the function. And if it's loaded, then we can continue. Of course, if it's not loaded, it will throw an error, all right? Then what we're doing is that if it continues, we want to remove this gray area because it means that the user can actually push the button because the model is already loaded, right? Then we can assign the constraints for the get user media function. So in JavaScript, for that function, you can select having the video and also having audio. We don't need audio. We're just going to use the video in this particular example that we're doing. So we say video true. That's the only thing that we need. And then we can activate the webcam stream. We pass the constraints and then we pass the stream. And after adding everything, when the data is loaded, we're going to call this function called predict webcam. So let's go to this one. This is the placeholder, all right, for the predict webcam. And right now we're going to do like a little trick. I'm using the one that is not. Okay, so we're going to use a little trick, and we're going to say that the model has been loaded, right? Just to be able to see if the webcam, if the stream of the webcam works. So I'm going to enable it, and here I am. So it's working. Okay, let me move this a little bit. All right, okay. So it's working. We are getting the stream from the webcam. All right. And yeah, this is what you should be seeing, but yourself. Okay. So I already explained all of these steps to you. And now we are gonna, let's jump to the next part, which is actually working with the model. All right, so that's on the step 8. So let's copy this, right? And we're going to replace it here. I wonder if that has the, yes. Okay, so we're saying that we have the model variable. And again, we have to wait for the Coco SSD model to load. And when it's loaded, then we can remove that CSS class that add that gray area over the button. All right. And next, we are going to do the classification, which is like the fun part. All right. So again, if you want to read on more specifically what is it that we're doing, you go to this page. But I'm going to copy the code, and I'm going to go through all of the instructions to explain to you what is it that we're doing. The last time I used the word instruction to refer to code, I think it was like in 1995. It's like an old way to say that. No, even before that, when I started coding when I was like, I don't know, like 9 years old. I started coding in BASIC, and we said instructions, at least in Spanish. All right, so let's go through this code. I think, yes. So first of all, we're going to have an array called children, and I'm going to explain to you what is that array, what is it about. I'm going to explain to you later. Okay, and then we finally have the predict webcam function that is going to be called after all the data is being received from the webcam stream. All right. Okay, so the model will detect the video, right? And then after that, it will start doing the predictions, all right? And what it does is that, first of all, what is it that we're going to put in the children's array? So when we're doing the predictions, and I'm going to show you when we're receiving the predictions, what we get is an array with the bounding boxes like coordinates, and we're going to get also the class name, and the class name is the name of the object, and we're also going to receive like the prediction of accuracy, like the percentage of accuracy that that object is actually a person or actually a dog. So when to draw the bounding boxes, we're going to draw them, right, and place them in the CSS. We're going to place them in the HTML, but because this is a frame by frame prediction, and we're going to keep on receiving frames from the web stream, we are going to add, let's say, the first frame we're going to add a bounding box. Then the second frame, another bounding box. And if we don't remove the previous bounding boxes, we're going to have a bunch of bounding boxes all around because every time we're receiving new frames. So what we're doing with the children array is that every bounding box that we draw, we need to put it in the children's array so we can clean it and remove it. So basically that's what we're doing with the children array, all right? So what we're saying is like, okay, let's go through all of the length of that array and remove all the children's there. So we're removing the bounding boxes, all right? And now what we're gonna do is that we're gonna loop through the predictions that we're receiving from the model, and we're going to do some stuff, all right? So I believe here we have the, let's explain this here. Okay. So we have the bounded boxes. We have, these are the numbers that we receive, the coordinates, the width, and the height, all right? And then we are also going to receive, like I said, from the predictions array, we receive the class, which is this one. We receive the score, which is what, like I said, like the percentage of accuracy, the confidence. And then we receive those numbers that I told you about the bounding boxes. We're going to receive these numbers. So we need like this point, this number, and this number to be able to draw the actual rectangle. And okay, so we can receive many predictions because we can per frame, because we can find more than one object, or maybe there's not even one object, but we can find, I don't know, 3 objects in a frame. So if that's the case, then the predictions array is going to have more than one element. Okay, so we're going to iterate in that array, and for each element, we're going to say, okay, the score. We can say, okay, I just want to draw the bounding boxes over those objects that have 66% of accuracy. Or maybe you can be more strict and you want to say, no, I'm just going to draw like the text objects that have like, I don't know, 99% of accuracy. So you can play with that. Or maybe you just like to, draw all the bounding boxes that are being detected. Okay, but in this case, we are selecting 60%, all right? So what we do is that we create, using JavaScript again, we create a P element within the HTML, and we are going to add the name of the class, and then a text, and then the percentage of confidence. So that's gonna appear on the top of the bounding box. And then we're gonna add some styling to be able to place obviously the bounding box that we are drawing, to place it in the right area of the frame, right? Okay, and after that, we're going to draw, right, like the box, but then we have to draw like the highlighter. It's like a layer that is on top to highlight that box. So we create another element. We add an attribute, which is the highlighter class, which is this one. We have another color, all right, and again with the same coordinates, of course, that we're receiving for the bounding box, because obviously it's going to be on top on the same place. And then what we do is that we append the highlighter, we append the bounding box to the live view, which is the view that has the stream. And we're pushing that code, that HTML object, we're pushing that into the children's array. Why? Because we want to remove it for the next iteration. All right. And then, okay, we are going to call again the predict webcam the predict webcam function, because we are getting a lot of different frames because it's a video. So we need to keep on calling it and calling it and calling it to continue the animation loop. And this is how it should work. We're going to see it live right now. And again, as you notice, we just used 3 lines of code for the machine learning part, which was loading the Tensorflow.js model library, loading the model, and actually calling it in the JavaScript. The rest was just drawing the boxes and doing the checks. So if I click, we copy all the code, and if I click enable webcam, it's working. Oh, all right. So as you can see, I'm not a whole person. I'm not a whole human. So it's in between 70. Maybe it's just because of the glasses. I don't know. I don't look like a human. Let's try with a bottle of water. So something is wrong with the CSS, or maybe it's the browser, because it's drawing. Can I refresh this? Yeah, something is wrong with the CSS, because it's drawing the bounding boxes where it should not be, or maybe something is wrong with the code. So it's detecting a chair, and the bottle is drawing it's drawing the bounding box really far away from the image. Yeah. So let's see. Can I detect the plant? The chair. All right. I have to check what's wrong with the position of the bounding boxes. But yeah, it's pretty easy to use, as you can see. You only need a working knowledge, again, of JavaScript and HTML and CSS, and you can start doing fun stuff. Of course, if you can, grab what you get from the predictions array, what you get from the classes, and you can do fun stuff. For example, I did a workshop where we used the teachable machine from Google, where you can train a model to detect objects as well, or detect a video. And we did something like it can recognize if you're happy or if you're sad, and then a robot on the website will say, oh, that's nice that you're happy, or this is sad that you are crying, or whatever. So you can play with what you get from the prediction and do fun stuff. Or maybe, of course, you can do actually, for example, at work, I use Tensorflow.js for suggesting taxonomies for content management system in real time, where the editors are working on posts that they need to work. So obviously it has really nice applications as well for professional applications. Yeah, so what's next? I would say have a look around, have a look at all the fun stuff that people is doing. If you follow the hashtag made with TFJS on Twitter, you will find a lot of really, really fun stuff that people is doing there. And yeah, it's really fun. So if you have any questions, again, you can reach out to me, and I'm happy to hear your questions or comments for the Q&A.
Thank you very much, Patty. I have one question from slightly earlier in the stream. If I get that up on the screen for you. So Shmuel was asking, can it in practice help disabled people and people with special needs? I know you mentioned sign language earlier.
Yes. Yes, there also for the sound recognition pre-made model. There has been really nice applications that people can have been using to control the browser. For example, I have seen people using for the hands pre-made models, like they use their hands to move through a website, and if they do this movement with the hand, it will go to the next the next page, or to interact with the website. So really cool, really amazing stuff, especially about disabled people, how they can interact with websites is really cool. I will suggest to have a look at especially this kind of solutions using Tensorflow.js. They're really, really amazing.
Awesome. I have another question just come in from Patu. So do JavaScript models have any disadvantage over the direct TensorFlow models?
Well, it really depends on what you're doing, of course, and the amount of power that you need, and what your model is going to do. It really depends on the use case. Obviously, there are a lot of different applications where a TensorFlow.js model will not work. It's not powerful enough, maybe. So it's for a very specific use case of using machine learning in web. It's ideal for that. Mm-hmm. But outside the web, or outside all these devices where you can run JavaScript, probably other kind of models are better to use. It really depends on what you want to do.
Yeah. Yeah, that's all the questions I have in the comments. So thank you very much, Patty, for that. That was brilliant.
Yeah, thank you for having me. It was really fun. and yeah, if you want to reach out to me, just let me know if you have any question. And yeah, thank you for having me.
Yeah, and thank you for sharing all those resources as well. That's great.
Brilliant. All right.
Thank you.
Thank you. Bye.
So a bit of a reminder of the schedule while we're waiting for 12 o'clock. So over on the Wally room, we have Getting Started with MLOps with Luke Menzies and Anna Maria Wykes. So this is the Johnny 5 room. So yeah, so if you want to go see that that talk, there's another stream on happening, and there's exactly the same YouTube channel. So go check that out. Cool. We have our speakers here already. I'm going to add them to the stream. Hello.
Hello.
Hello. How are you both?
I'm good. Thank you. How are you?
Yes, good. Thank you. Good. Thank you. Where are you calling from for today?
Well, that's an interesting story. I will start. I'm actually now at the Microsoft office in Amsterdam. So yeah, nice location over here. But yeah, that's not as special as my colleague Tomasso.
Yeah, so I am Tomasso, and I'm now on holiday in Switzerland. So I'm doing this from the holiday vacation. So yeah, that's quite interesting.
Oh,
luckily they also have internet here as well.
Yes.
So, I'm quite fortunate. Yeah.
Yeah, I think we first planned to do this from our own office in Rotterdam, but then turned out that plans kind of changed.
Yeah. Well, thank you very much for being here with us today. We don't start for another 3 minutes, but I will give you the chance to get your slides set up. If I stop sharing my screen.
Then I can... Then I'll start sharing my screen.
Awesome.
Yeah, I think halfway through the presentation, we will have to do a quick switch between myself and Tomasso, but we'll announce that.
Yeah. So then the only thing what I have to do is click on the present button.
Yeah.
present and then present screen and then choose. I think entire screen is best, right?
Yep. The option to present just the sides sometimes like moves the formatting around a little bit. So yeah. Cool. I will give you the stage then.
All right, let me quickly share this. Can I start or wait for?
We'll wait for 2 minutes maybe.
All right. Yeah. I think my slides should be visible by now.
I need to add them to the screen. There we go. Also, a reminder to all the attendees, if you have any questions, pop them in the YouTube comments. We have the option to, if there's time at the end, I'll read them out and they can be displayed on screen for everyone.
All right. All right. I think it's 12 o'clock exactly.
Yeah. Go on then.
Well, it's 1 o'clock in Amsterdam, but well, good afternoon, everybody, and welcome to our session on discovering the best option for deploying your models on Azure. In this session, together with my colleague Tomasso, we will present the use case to deploy models to both Azure Machine Learning and Azure Kubernetes. And we would like to give you some tips and show you how you can deploy a model on Azure. And also at the end, share our lessons learned from the projects that we do, and how you could make an informed decision on whether you should use one of these services over the other. But before we dive in, I would like to shortly introduce myself. I am Sebastiaan Oude Groeniger. Also in Dutch, this is a difficult name to pronounce. I work at Motion 10, and over at Motion 10, I'm a consultant, mostly focused on the Azure data and machine learning platform engineering side. So in my projects, I'm usually involved with setting up data and machine learning platforms on Azure. Motion 10 is an IT and consulting firm. We're also a Microsoft partner, and we focus on things like Azure integration, data analytics, machine learning, but also modern work and security. With that, I'd like to give the word to Tomasso to introduce himself.
Well, hi everybody. I'm Tomasso Groenendijk. I'm also a colleague of Sebastiaan. I'm also a technology lead at Motion 10, and then at the area of integration. But I also work as an architect for customers as well. And what I do for the customers is look at what solution they want to have and which components or services in Azure you need for that. So that's a really short introduction what I am.
Thank you. The program of today, we have a lot to cover, and we'll try to keep that as interesting as possible for everybody, of course. I'll start with a short introduction of the goal of our presentation of today, together with the introduction of the use case that we want to cover to use as part of our story. Then a little bit of theory about machine learning operations, and then moving on to a demo on how we deploy a model in Azure Machine Learning, and how we set that up. And then my colleague Tomasso will take over and go through a bit of Kubernetes introduction and also a demonstration of basically the same model if you would use that in Kubernetes to deploy the model. What are the implications? How does it look like? What do you have to take into account if you have, for instance, a deep learning model and you have some GPUs? And then we want to end this presentation with a conclusion on what our lessons learned are, and summarize basically the main differences between Azure Machine Learning and Kubernetes for deploying your models. So, goal of the presentation of today is basically, as we all know, developing a machine learning model is already hard, but deploying that model to production, to use for production purposes, for instance, is just as hard. I think we all know the phrase, but it works on my machine. Pretty famous, I think. And this presentation, we would like to give you a head start when you want to deploy a model on Azure, and what kind of things you have to worry about, think about ahead before you move on. And I think, from our side, the most practical way of giving this presentation is through a use case. It's partly based on a use case we did at a customer projects, and we want to use a little bit of simplified setup to basically do the same thing. So basically, our use case, it uses images. So those are JPEGs, and those are stored on an Azure storage account. And what we want to do is basically process those images. And with processing, in this case, we have an open source model, Nanodet, and we want to do some object detection on those images. So we might have an image of a car, and we want to do some object detection to see if we can find that car, but also we want to return the accuracy on which it thinks it is a car. So we'll do that using Azure Machine Learning, and then we store the processed images and some other metadata in a different storage account there. And basically what we want to do is also use Azure Kubernetes to achieve the same thing. And there we would like to show the major differences between using those two services. Be aware, of course, we now focus on Azure Machine Learning, Azure Kubernetes. There are, of course, also other options to deploy your and host your models, like Databricks, Azure Functions, but we would like to focus on those two services in this presentation. So machine learning operations, that's where we'd like to start. I think for a lot of people who are also already working in the machine learning space, I think this picture or anything similar to this picture is already pretty, I think you've seen this, might have seen this before. So machine learning operations, it's the practices, tools, techniques that enable organizations to develop and deploy machine learning models, and also after deployment, make sure you properly monitor them. Maybe replace them with a better model, make sure that it keeps performing in terms of your accuracy, for instance, but also in terms of latency, if you have an API that's customer facing. It tries to address those challenges that you have when you have a model which is developed, for instance, in a notebook, or maybe locally, or through whatever kind of tool that a data scientist might use. How do you then go from a model to creating an environment where you can deploy that model, and how do you then monitor that and make sure you have the right processes, people, and tools in place to monitor this this solution that you created. So what does it look like? I think broadly you could say you have 5 steps. Of course, there's always a feedback loop, and this is especially in the beginning a highly iterative process. So you start with training your model locally, exploring your data, making sure you have a model that performs. And then eventually you want to package that model, of course. So you want to make sure it's basically a reusable artifact. We'll dive a bit more into that later on in more practical terms, that you can actually deploy through to a production environment. Then you do some validating on your model. So you say, I want to check if it meets my quality standards that I have at my company, for instance. It might be testing, is it doing better than my current model? So a whole range of things that you want to do there to make sure the model is performing as you would expect. And then you would deploy the model so you could actually use it to for your predictions. And eventually, of course, you also want to monitor the model and know when to maybe replace it, or maybe nobody's using it anymore and you can just deprecate your model. So this is the whole life cycle of machine learning operations. I drew a red bar or rectangle around the deploy model part because that's really what we want to focus on today in our demonstrations. So be aware that everything that we do here, there are of course a lot more steps involved in making this work for production purposes. This is just one of the steps that's important and can take considerable time to get right as well. So without further ado, let's dive into a bit more of the technical setup that we have for Azure Machine Learning. So remember, like we mentioned, we have two storage accounts. One with just the raw images that we received that we, in this case, want to do some object detection on. And another storage account where we want to store our processed images. So that will be images with a bounding box around it, for instance, but also some metadata about the predictions itself, which we can use later in our pipeline. Within Azure Machine Learning the workspace, we use a few functionalities to make sure that that we can set this up properly. First of all, on the right side, we have data assets. So data assets are simply a reference to our storage accounts. So it's a sample images data asset and a processed images data assets. And those are both related to the different storage accounts that we have. Using this setup, using data assets makes it a whole lot easier to interact through Azure Machine Learning with your storage account, because you don't have to worry about authentication anymore, because that's done through the data assets that you have in place in your Azure Machine Learning workspace. And then on the left-hand side, we have this batched endpoint. It's a managed endpoint by Microsoft, by Azure. So that means that basically Microsoft provides you with an API, a REST endpoint to use. So all the management around that API, making sure you have an API to set up. You don't have to worry about this anymore because Microsoft does this for you. That's of course very nice, a very nice feature to start with. So you don't have to worry a whole lot about infrastructure or writing code to create an API, for instance. Those are in two forms. You have online endpoints, and online endpoints are always on. So it's definitely more used in scenarios where you would need a immediate return from your API. And you have batch endpoints, and batch endpoints are usually used in scenarios where you do some batch inferencing, so once a day, once an hour, or maybe even once a week. The batch endpoint basically has 4 ingredients that it needs. Of course, it needs your model. So if you have a model and you have it registered in your Azure Machine Learning workspace, you can use that. It needs compute, of course, and the big benefit of using batch inference is that you can use compute clusters that scale down to 0 nodes when you are done with your inferencing. So you only pay for the amount of time that you actually are doing batch inferencing. Then we have inference code, and this is actually the code that has to be written to make sure that if that endpoint is invoked, it basically loads in your model and your data and make sure that you're doing the processing in a way that you would like. So definitely some customization there. And then eventually you also need an environment. It's a Docker file usually. Tomasso will dive a bit into that later. It basically specifies your operating system and the different, in this case, for instance, Python packages that you might need to run on your compute to make sure your inference code is working properly. So basically our Azure machine learning process is as follows. We first have images uploaded to a storage account, then a batch endpoint is invoked, and then finally these results are processed to another storage location. Of course, we've also provided a short demo about this, so I'll switch from this PowerPoint to there we go. Let me zoom in a little bit. Basically, I just switched to a Azure Machine Learning Studio. So now, currently, I am in the Azure Machine Learning workspace that I have created. Well, actually, I'm using this for multiple. Basically, this sort of a playground, but here we've set up this this use case as well. So first of all, of course, we have our data, and if you go through the data tab and then look at the data assets, you can actually see that over here you'll have my sample images. And my sample images is, of course, those are just stored in a storage account. They're not actually stored within a Azure Machine Learning workspace. This is just your reference. And what you can see here is that I uploaded a few different images. And they're basically, in this case, an apple, a banana, a person. Funny story about this. This is actually not a real person, but this person is also generated with AI. Thought it would be nice to see if it can actually detect a person that does not really exist. And some planes and a train. So this is a beautiful Dutch yellow train. So that's the data that we have. We also have an environment, and an environment, without going into too much detail, is that Docker file that I've mentioned before. And here I'm basically referencing a Microsoft image, which is running on Ubuntu 18. And I also specify a few packages that I would need to use in order to make sure that I can run my inference code on that endpoint. I also have a model. So in this case, I have two models registered here. A model is nothing more than a reference to an artifact. In this case, it's an Onyx file, and I can have multiple versions, of course. Maybe I retrain my model on a daily basis or on a weekly basis. And then if I give it the same name, I would just get multiple versions of this model. And I could also use this in my endpoint to do some inferencing. Then I have compute, of course, and I'm using compute clusters. I already started the job about an hour ago or so. So this node is still active. But as you can see here, I specified that it needs to scale down after 7,200 seconds. So that's 2 hours. So after 2 hours, this cluster will scale down. And finally, I have my batch endpoint. So if you go to batch endpoints, you have two different tabs, real-time and batch endpoints. And in batch endpoints, if I click on this one, you'll see that I have given it a name, and then the machine learning workspace will give me a REST endpoint that I could call, which is just the name of my endpoint. And in this case, it's .West Europe, because this workspace is located in West Europe. or the data center West Europe. And then on the right side, we have this deployment. So here you'll find those ingredients again. So you again find my model. You'll find my scoring script that I've uploaded. I'm not going to dive into that scoring script right now because it's too much for this presentation. I have my compute and I have an environment. So I'm using version 19 of this environment. Basically, those are the most important ingredients to mention. Then, of course, this is an API that I could call, so I could integrate this with an application. I could use Postman to call this API or any other tool. But what I can also do is just from this interface, basically specify I'm going to create a job here, and it first asks me to choose a deployment. Currently, I only have one deployment, but let's say you want to test your endpoint or maybe see the differences between two different models that you have. You could also call this endpoint with a different deployment, specifying a different version of your model or just a different model altogether. So you could have that same structure, same setup with different deployments. Then I'm selecting my data source. And in this case, I'm using that sample images that I just showed you. I'll click on next and create. In this case, I don't specify my output configuration, but because that's already been added to my scoring script. So what we'll see now is that it actually is starting a run. This run, of course, needs some time to process. So in order to speed up a bit, I already started one this morning. So what you see here is I have this run. It's called Shy Rice with a randomly generated number behind it. And here, this one is actually completed. Of course, we'd like to see some output. And the output is in this storage account. So I have this storage account here with a folder called processed images. And if I then go into this images folder, I do see a lot of unique IDs. Those unique IDs, so for instance, is 5454 is related to the run that I have here. So this 5454 is here as well. So also from a storage account perspective, I can always trace back which run did this actually belong to. So making it a bit easier to detect this. So if I do then move into this one, what I find here is 6 images again and a JSON file. So let's start with those images first. As you can see here, in this case, it drew a bounding box, but it predicted an orange with almost 70% confidence. So that's definitely not a great result. This one is even funnier. So it detected my banana, which is great, but it also thought that this part was a surfboard. Very interesting. And over here, it actually did detect my train correctly. So as you could see, this model definitely needs some improvement before we could use this, but it gives you a good idea on what you can do with this. Of course, I also added a predictions .json file, and this file actually specifies for all of my inputs. So in this case, that apple, it gives me the coordinates of that bounding box, excuse me, but also the actual confidence in which it predicted that this, in this case, was an orange, and that orange had a reference of 49. So it's sort of an index. This JSON itself is now not doing anything, of course, but this could definitely be used in your next step in your pipeline to, for instance, build some monitoring on top of this, that you see like, hey, it's for the apples that I have, it's now predicting oranges, or maybe my confidence level is going down. Those could all be used to either compare models or make sure that your model is still performing. So yeah, I would always highly recommend to add those different JSON files to your endpoint, so you could use that as well for monitoring. Be aware that this is not out of the box functionality, unfortunately. So this is definitely something you'll have to code yourself in your inference code to make sure that it's being added to your predictions. So, and I think that will, for now, conclude my part of this demonstration. I'll stop sharing my screen here and move on to and give the word to my colleague Tomasso to introduce Kubernetes to you.
Yeah, so I'm going to share my screen right now. So let me start this. So is everybody able to see the screen? Yeah, I think so, or not?
Yeah, but I don't see a presentation yet.
Okay,
it's like
now is. So is that me? So let me start my my screen.
Yeah, currently not able to see. I wonder if you're presenting the wrong window.
I'm now seeing like 8 times
okay.
the window, which is very interesting.
Yeah, so let me go back. Present. Stop screen, or maybe share screen. Oh, sorry. Yeah, this is the one. Yeah, so probably now it grows better. Is everybody able to see my screen now?
Yeah, perfect.
Okay, great. Okay, so now I'm going to show you how you can do the same or sort of the same setup, but then with containers and with Kubernetes. So first, what I wanted to show you is a little bit of an introduction about what containers are and what Kubernetes is and how you can use Kubernetes for the setup. Yeah, so let's start with containers. And why do we need containers? The nice thing with containers is that it's an abstraction of the app layer. What we're now going to do is build a custom solution, and that custom solution we're going to deploy into a container. And the container is an abstraction, in this case, of an API. With the container, you can package that with also the dependencies together. And the nice thing is that you now can run multiple containers into the same machine. So normally, if you have a virtual machine, you have an abstraction of the entire OS. And when a container, you only have an abstraction of the application itself. So it's a much smaller containerization, so to speak. And what is Docker? So we're going to use Docker for containerization. So there are a lot of choices for your container, how you set it up. For example, Microsoft also has this solution for containerization. But when you look at Docker, Docker is, well, the de facto standard, so to speak. So now everybody almost uses Docker for their containerization. So with Docker, it's an open source platform for building, shipping, and running those applications into containers. And when you look at, for example, Kubernetes also uses Docker as well. Kubernetes is the de facto orchestrator, so to speak, for containerization. So it's a platform for running your containers, but also for managing for management as well. So, for example, if you want to use multiple containers together, and they have to speak to each other, so to speak. This is great. This is a great platform. It's also self-healing, so that means that when one container breaks down, or maybe the entire node breaks down, everything is automatically restarted and replaced. And so it's a really powerful environment, so to speak. But that's the advantage of Kubernetes, but there's also a drawback, of course. And what you see here is also complex. So when you look from a high-level overview, you have a master node. So the master node manages the environment, and you also have worker nodes. And the worker nodes, on the worker nodes are the containers running, and the containers run in a pod. So a pod contains, most of the time one container, but a pod can also contain multiple containers as well. But when you look, for example, at the master node, you have a lot of components that work together. So, for example, you have the API server. So, it wants to fire up a request to the server. You can do it with the API server. With the scheduler, you can schedule the workloads when they're going to run on the worker nodes. Well, the etcd is a database where you manage the state. So you see that there are a lot of components that work to each other or have to work together. And when you deploy this yourself, you also have to configure all those components. So when you do this on an on-prem environment, it can be quite complex. And the nice thing about Kubernetes on Azure is that a lot of things are now managed for you on Azure. So Azure manages, for example, the master node. So all those things what you have to do with the master node is now configured by Azure itself. So under the hood, you have the customer VMs, but also those VMs are managed by Azure as well. So you only have to deploy for, so to speak, the pods. And of course, it's 100% upstream Kubernetes. So that means that everything what is running in Azure is 100% Kubernetes. And there are some other advantages, for example. So when you have to patch, for example, Kubernetes, this is under the hood. Everything is done for you. And also with the scaling down and scaling up, normally what you have to do is you have to drain those nodes. That means that you have to remove all the pods. And then when you have scaled it up, and then you have to install everything back again. And all those things are now done by Azure as well. So it's a really powerful environment, and it's really easy to install as well, because normally you have to install it with quite some code or script, and now with some simple commands you can deploy your environment. So what you also need when you are running a solution on Kubernetes, you have to have a container registry. And a container registry is a private registry where you can deploy your containers into Azure. So for example, if Kubernetes needs a container image because it has to scale up or you have to deploy your container, it gets it from the container registry. And the nice thing with the container registry in Azure is that you also have all the Azure advantages, so to speak. So you have, for example, geo-replication. So that means that you can have running your container registry in multiple regions. And you also have for example, the Azure CLI tools. So you also have the normal tools that you normally already use when you are running your services in Azure. So you have a lot of advantages because it's in Azure. You also have container registries open. You also have open source container registries as well. So you can choose if you want to run Kubernetes on Azure. You don't need Azure Container Registry. Yeah, but it really works well together. Yeah, that's a great advantage. And what you see here is all the services that you can choose from when you're running Kubernetes. So you can see that it can become quite well, hard is maybe not a good word, but it's it's a little bit complex, or you have a steep learning curve. Maybe that's a better word for it. So what you see on top are all the open source tools that you can choose from when you're running Kubernetes. So for example, for development, you can create Helm scripts. For DevOps, you can choose from Jenkins, or you can choose between Terraform or Brigade. So there are a lot of tools out there. And for monitoring, Prometheus is, for example, quite often used in combination with Grafana. Yeah, so what you can see here is that there are a lot of choices. But the advantage is when you're running Kubernetes in Azure, is that you can also use the Azure services as well. So, for example, when you want to deploy your environment, you can choose or you can use DevOps. And when for development, you can also use Visual Studio Code. For networking, you can place your Kubernetes in an Azure virtual network. And for storage, you can use Azure Storage. So there are a lot of Azure services that you can combine and choose and use with Kubernetes. Yeah, and that makes it really powerful when you're deploying your Kubernetes environment into Azure. Yeah, and I'm also going to show you a demo. And with them in Azure, with when you wanted to use Kubernetes in Azure, or your model, your deep learning model in Azure Kubernetes, you have to do a lot of things yourself. So what Sebastiaan has showed you is that you have, when you use machine learning, you get a lot of out of the box. And now what you have to do is first you have to set up your Kubernetes environment. So that's, that can become quite complex if you are not familiar with Kubernetes. So there is a steep learning curve. So what I would recommend is not, if you only have one model and you want to play around with only one model, well, Kubernetes can be a little bit of overkill because you also need to create a custom solution to run that model. So when you want to use that model, well, you have to create a custom solution, and the custom solution in this tip in the demo what I've created is an API. So we're going to call an API, and then that API is going to use that model. But also you have to deploy that API also to Kubernetes as well. And then we're going to look at the activities that are performed by the model. So first, the setup. So this is the setup that we have created for the demo. You can also, well, this is not mandatory, this setup, because what we have done is created an external load balancer, and that load balancer, with the load balancer, you can call the pod. So in the pod is the image or the container running, but to be able to call that API that's running in that pod, you have to make it visible, so to speak, for the outside. And we have done that with an external load balancer, but that's not mandatory. You can also create a load balancer in Kubernetes as well. And also what Sebastiaan has showed you is the images. So the images are running into blob storage on a storage account, but we want to use that storage account from inside Kubernetes. So the easiest things to do for a developer is to to mount that storage as if it was a volume that is running inside Kubernetes. So that's also something that you have to configure as well when you want to use images and want to use the model that's running into a storage account. So the setup. So normally when you want to have, or when you're using a lot of images, or you want to do a lot of processing, we would recommend is that you have a separate worker pod, and the worker pod is running into a separate node. And that's, for example, because normally when you're doing a lot of processing, you also need a lot of GPU to compute. And that GPU and those virtual machines that running underneath, they can be quite expensive. So that worker pod is, you don't want to run that all the time. So that's why we recommend is that you have a separate worker node that's running on a separate virtual machine or node, so to speak. And then you have the API. So somebody calls the API, and then under the hood, the API is calling the worker pod, for example, with a message queue, and that's running in Redis, for example. So this is not mandatory, this setup, but it's recommended. But in our demo, we're only having an API. For the sake of simplicity, so to speak. And of course, what you also want to do is, or have to do, is you have to deploy your API, because on your laptop or on your local environments, you are programming the API. And then with Azure DevOps, we have deployed the API into the Kubernetes, into the pod. And because it's like a two-phase rocket. So first you have to deploy that API to Azure Container Registry, and then it's pulled from Kubernetes. So this is the setup that we have used. So let's take a look at the Azure environment. So let me go to Kubernetes. So this is the Kubernetes environment in Azure. So first you have to deploy Kubernetes. And then you have to configure the Kubernetes. So the first thing what you have to do is to configure the node pools. So the node pools, you have the separate pools. So for example, the agent pool, on the agent pool, you can run the API, and that agent pool is always running. And then on the GPU pool, then you can have the worker node installed on, and that GPU pool has another virtual machines that have much more memory and also the CPU. And the nice thing in Azure is that you can also really scale. It's really easy to scale. That is also what I explained. So here, for example, we only have one node, but it can burst into 3 nodes. And you can also scale that yourself. So that makes it really nice. So let's go back to the environment. So that's the first thing for what you have to set up, and also what you have to set up is, for example, also networking. So there are a lot of things what you have to do, but for us it's also mandatory to mount the storage. So because we want to use the images, and we also want to use the models that are on blob storage. So now we have to configure or to mount them into Kubernetes. That's also something what you have to do. So these are the persistent volumes, and you can create the claims to the volumes. And when you look in the workloads, so the workloads are, for example, the API, in this case, that we have deployed into Kubernetes. And when I click on the API, I can also see here the volumes as well. So here, for example, I have the volumes. So here I have the source. So these are, that contains the source images, and with the outputs here we're going to see the images that are processed by the model. So that's also something what we want to see. And then what we want to do, so for example, I maybe what also wanted to show you, I don't know if you can see it here. Or here we can also see the container image. So here you can see the image that is running from the container registry. So that is also what we can do. And when you click on it, you can also delete it. And when you delete it, it instantly gets the same image from the container registry back again. Well, let's call that API. So when you call the API, so here you see Swagger, and Swagger defines how you can use the API. So in this case, we're going to call the API, and we see that we have an input folder. So we want to have multiple images we want to choose from, and these are exactly the same images as Sebastian used in his demo. And this is the model that we're going to use. So this is the model, and you can choose from different models. So in this case, we're going to use this model. And now we're going to call the API. So, and in the background the images are running, and because we only have a few images and we don't have the background worker process, so we already have a result. And the nice thing, because now we have a custom solution, so we can choose from how we want to run this. We don't have a complex GUI to choose from, but now we have like a functional description. So the nice thing is now we can see, for example, it generates a unique name, and now we can look on the to get this name. So let's go back to Azure, and let's go to the storage accounts. And what we see here are the processed images, and we have to look at the name. So we have the multiple images, and what was the result that we just got is the modernistic result. So let's have a look of. So here we already have that unique name, and these are exactly the same. So probably we use the same model as Sebastian. So let's for example see at the train. Or let's go back. Or download it. And here you see the exactly the same result. So it has a 61%. So that's a great result. So this is my demo. Sebastian, I think it's now back to you.
Thank you, Tomasso. Let me quickly share my screen again for the last slides to go through the conclusions of our session and our lessons learned. So basically, we started off with saying, okay, you can deploy your models in Azure in multiple ways. We chose to do Azure Machine Learning and Azure Kubernetes. And what platform would you choose for your machine learning models? Well, as always, it depends. It depends on the team that you have, the skills that you have in your team. Like Tomasso mentioned, Kubernetes is very powerful. It has a lot of flexibility, but there's a big learning curve there. So that definitely is a factor in choosing between Kubernetes and Azure Machine Learning. Keep in mind that if you use Kubernetes, if you just have that one use case for one simple model, or maybe even a complex model, but just one use case, I would not recommend using Kubernetes because it's a lot harder to set up. If you already have Kubernetes in place, you have people who have knowledge about this, and you have someone who can really well manage your Kubernetes environment, then it gives you more freedom and flexibility as well. So that might be the interesting way to go. Azure Machine Learning is definitely easier to start with. It also, out of the box, gives you some options to easily scale up and down your clusters. Where, like Tomasso mentioned, if you really need GPUs for your deep learning models, for instance, you really have to be careful in Kubernetes to make sure that you set this process up in such a way that the GPU is only running for the time that you actually need it. And that's a much more complex than in Azure Machine Learning, where you can more easily say, I have this endpoint, it's running on a GPU compute, but if it's finished, it will just easily scale down. And I set it to 2 hours, but you could also set it to 1 minute and then let it scale down as well. So definitely more easier options there. So if we look at a few topics here, for instance, that API endpoint in Azure Machine Learning, it's basically managed by Azure. For Azure Kubernetes, we had to develop our API ourselves. We used Fast API, a Python framework for building APIs for it. You still need to do that, although it might not be that difficult. You still need the skills and expertise to do this. High availability is easy managed by Azure. In Kubernetes, it's more do it yourself, but also flexibility and migration are, I think, the two different subjects that where you could say like Azure Kubernetes has its benefits because it's more flexible and it's also easier to migrate if you want that to, for instance, a different cloud provider. Whereas Azure Machine Learning, you're of course more stuck with the platform capabilities, and it's harder to transfer your solution to a different cloud provider if you would need that, of course. So all in all, it really depends. I think if you start with deploying a machine learning model for the first time, I would recommend Azure Machine Learning. It's easier to start with, and there's good documentation and support, and it's just easier to get up and running quickly versus using Azure Kubernetes. So that's I think that concludes our session for today. We would like to thank you very much for your attention, and yeah, if you have any questions, yeah, we're happy to hear them.
Awesome. Thank you very much for that, both. I have 3 questions in the comments. I will get the first one up on the screen. So do you know if there's any option to launch the Azure service via local environment? Is there a plan to make the new Azure ML Studio or other services work like the free environment Classic did?
Good question. As far as I'm concerned, there are no plans for that. I do know there is an option to debug your managed endpoints locally using Azure Machine Learning. So that is an option. It is in the documentation of Microsoft if you want to look that up. But I'm not sure what the person means with launch. So if you're talking about debugging locally, yes, that's possible, but that's pretty much the only thing you can do locally.
Yeah, maybe what you can do with Kubernetes. So when you compare it to Kubernetes, you can run Kubernetes also on your local environment. Yeah. And nowadays, what Azure is now working on is also with Azure Arc. So Azure Arc is a service that you can monitor your, a lot of services, but also Kubernetes. And then from Azure Arc, it looks like if everything is running in Azure, but under the hood, everything is running on-prem. So that makes Azure Arc really powerful, because now, from Azure Arc, it looks like, hey, I'm running in Azure, so that's also an option that you can choose from.
Yeah, to add to that, debugging in Kubernetes is a bit easier because for Azure Machine Learning, if you change something, you have to upload it, go to your endpoint again, run it again, wait for the cluster maybe to start up again. So that may takes a bit more time.
Yeah. Awesome. We've also got another question from Patu. What Azure services would you recommend to use for data mining on Azure SQL DB?
What Azure service would you recommend use for data mining on an Azure SQL DB? Good question. So you have data in your Azure SQL DB, and you would like to do some data mining. Depends on what you mean with data mining, I think. I would go back to making sure you have the data in a data lake and maybe use a Spark cluster and Synapse Databricks to explore that data and do some data mining. But it's a difficult question given the context that we have here.
Yeah, but maybe the difference is maybe, Sebastian, you can choose from Databricks is also a little bit more complex when you compare it to Synapse.
Yeah, definitely. Yeah.
So that's also something what you have to choose from if you're really familiar with Databricks and do all the things, the Python code yourself.
Maybe for a next session, Tomasso.
Yeah. Yeah, exactly.
Awesome. One final question. So I hear from Mir, how easy would it be to use Node.js to implement what you've just demonstrated in Python on Azure Machine Learning Workspace?
Oh, I think it's possible, but might be more difficult because definitely Azure Machine Learning is heavily focused on Python. So that inferencing script, it really expects a Python script with two specific functions, that init and run function. So you have to kind of work around that. So would it be easy? Probably not. Would it be possible? Probably, yeah. But if you use that, maybe go through the Kubernetes route. Maybe that's easier than Azure Machine Learning Workspace if you want to use Node.js.
Yeah. So with Kubernetes, you're really flexible because it's containerized. So you can create a custom container and, for example, use, well, probably you can also use C#, for example, as well. And so that's
Great. That's it for questions. So thank you again for joining.
Yes, thank you very much.
Yeah, thank you for having us. So
yes, thank you, and have a nice day.
Thank you.
All right. Bye-bye.
Right. And cool. 5 minutes till our next session. So just a reminder for the schedule today. So we are in the Johnny 5 stream at the moment. We also have another stream focused on more MLOpsy topics, and that's Wally. So if you'd like to join that stream for Azure ML, Onyx, and OpenVino, the stream is also available on YouTube. So just you can switch over now. Yeah, so we've got about 4 minutes until the next one, but all our speakers are here. So I think I might add them and introduce you. So you have Gavi, Zuzana, and Kunal. And today talking to us about maximizing the impact of machine learning in the financial sector. How are you all?
Very well, thanks, sorry.
Cool.
How are you doing?
Yes, good. Enjoying all the sessions so far.
Good.
Nice. Well, I will give you the chance to set up your slides then, I think.
All right. So for this talk, we'll just be sharing one slide pretty much. We'll have 2 sessions as well, but yeah, given the previous talk and sharing screens, I think that's a good idea. I'll just share my screen.
I mean, you can do it. I think this time I just need to be a little bit quicker on switching over the screen.
No, I'll just share my Cool. So we've got 3 minutes. I'm going to present my screen.
Thanks, Gavi.
Share screen, isn't it?
Yeah.
And its entire screen as well, right? How does that look?
Awesome. Looks really good. Yeah.
I'll give people 3 minutes in case they're having a quick break, and then we're ready to go at 1 o'clock.
Yeah, sounds good.
Zuzana and Kunal, did you manage to catch any of the talks today, or?
Is this
Just the last one.
okay?
Had a couple of calls with customers this morning, so
Yeah.
well, we can always go back to the stream and
Yeah.
watch it on YouTube. So
Yeah.
I suppose.
I guess Zuzana, you've been busy as well.
Exactly. Still catching up after leave.
Cool. So just a reminder before we start, if anyone has any questions during the talk, please use the YouTube comments. It's pretty cool because I'm able to get them up on the screen afterwards if we've got time. So any comments or questions, just drop them in the comments. Cool. We'll give it one more minute.
All right, it's 1 p.m. Let's crack on.
Oh, nice. Yeah. All right. I'll drop off then.
We're not giving people a minute.
All right. Go on. Take it.
All right. Welcome, everyone. Welcome to our talk today, where we'll be talking about maximizing the impact of machine learning in the financial sector. Hope you've had a good, hope you've managed to catch some of the talks we've had today. There's been some great talks today, but yeah, we're going to crack on today. So just before, let me get the hang of this. Where am I clicking? That's it. So just before we dive into our presentation, just wanted to introduce ourselves. I'll start with myself. I'm Gavita Regunath. I'm a principal data scientist with a company called Advancing Analytics. If you don't know anything about Advancing Analytics, we are a UK-based consultancy that pretty much specialize in anything to do with data engineering, data science, and machine learning. For those of you who are aware of Advancing Analytics, you might recognize the little sticker I've got on the slide, which says "Hello Spark fans." That's our YouTube video, which has got over hundreds of video content, particularly around Azure and Databricks and Spark as well. So if you wanted to find out a bit more information, then you can head across to our YouTube channel. One of my favorite things about Advancing Analytics is the podcast called Totally Skewed. I personally look forward to episodes that are coming along. It's a really cool podcast, and it's all about data. Apart from work, I'm also an ambassador for Women in Data Science, part of the Women in Data group in the UK, and I'm an AI Microsoft MVP. Today, though, I'm sharing this slot with two of our friends from Microsoft. Really excited to be doing this with them. So I'll let them introduce themselves.
Thank you, Gavi, and that's really impressive, by the way. So as for myself, I'm Zuzana, Loup, and I'm a Microsoft data and AI specialist. I've been around with Microsoft for the past 5 years, and currently I'm working with financial services and insurance organizations. So I'm hoping that they will be able to share some really useful insight into the industry and the opportunity that really lies in there for you. And in my role, I work really closely with Kunal here, so I'm really glad that he's joining us today. So Kunal, over to you.
Yeah, nice to meet everyone. I'm Kunal. I'm a cloud solution architect working for Microsoft. I work on data and AI side of things, so anything to do with data, machine learning, AI would fall under my remit. Again, I work with UK customers across finance, insurance, travel, and retail. And I've got about 6+ years of experience working in the cloud across different cloud platforms. And I've been with Microsoft for a little over 8 months. And nice to be here.
All right, so this talk, like I said previously, I'm not sure whether you caught it because I think we were talking about it just before the 1 p.m. slot, but I will be doing the first part of the talk and then pretty much aligned with the saving the best for last. Zuzana and Kunal will come in towards the latter bit of the presentation just to talk a bit about use cases in financial services. So this slide, let's just talk about the future of financial services, right? Now, as a consultancy where we help a lot of customers trying to get started on the machine learning journey, we've seen an increase in machine learning adoption through the years. But if you go back to 2019, right, where you've got survey reports published by the Bank of England and the Financial Conduct Authority, there was already evidence back then that there's lots of companies that work within the financial services in the UK were already using machine learning. Now, they've got a second report that was published late last year in October 2022, a really interesting report because it shows how the trend of machine learning has just been increasing since 2019. I think when you read the reports, for me, it was quite an eye-opener really to see more than, I think it was over 70% of financial services companies within the UK are already using machine learning, right? And the trend looks to be the same for the next couple of years. The survey has shown that it's going to be increased about 3.5% to 4.5%. So it's clear, right? Machine learning is here to stay. You can gain a lot of value from using machine learning. And these are two of my favorite reports that I share in presentations, right? If you were to search online or do a bit of self-research, there'll be more than this as what I've shown or sharing with everybody today. But it's clear, right? So Gartner predicts the business value created by AI and ML will reach up to $5 trillion by 2025. That's a huge number, a pretty impressive number as well. And if you look at the other report that was published by Accenture, it's 2019 now, so I expect that figure to have increased. But where it shows 84% of CEOs say AI and ML are a strategic priority for their organizations today. So there's lots of ambition around AI, but if you look into it into a bit more detail, the reality is quite different. So here on this slide, I've got the data and AI maturity curve. Now, if you work in AI and machine learning, you probably see a similar flavor of the data and AI maturity curve, but there tends to be 4 to 5 stages, right? I like this particular graph or plot because it's quite visual. So let's start with the right-hand side of the curve, where it's all about companies being very reactive, okay? Where companies are analyzing large amounts of data, doing some cleaning, generating some reports to find out what really happened. So they don't really have an AI strategy in terms of making automated decisions. But companies are trying to progress, right? Companies and tech leaders are trying to move to the right-hand side of the curve. So as you move towards the right-hand side of the curve, you then tend to go into predictive modeling. Predictive modeling falls under more of a proactive region where you're using models to predict what's happened. So you're not being reactive, you're being a bit more proactive. And if you move on, it's about being more strategic, right? It's doing prescriptive analytics. Now, prescriptive analytics goes beyond predictive modeling, where companies or businesses are now trying to predict the future outcomes and trying to figure out how should companies respond. And then as you move towards the right-hand side, you've got companies that have got machine learning or even AI fully embedded in their organization, where machine learning models are making these decisions automatically for them. This is where companies tend to gain that competitive advantage. So it's pretty clear that there is a data and AI maturity curve, and tech leaders at the moment are still racing towards the right-hand side of the curve. So as I said, as a consultancy, right, we have worked with a lot of companies, with a lot of financial services out there. And when we started, we wrote this blog a couple of years ago where we saw up to 5 to 6 common use cases that we would tend to implement in machine learning, right? So let's take, for example, fraud models, where companies are analyzing vast amounts of data to try and detect patterns and to try and understand when a fraud would happen in transactional data, for example, and prevent it. And you've got many of these kind of use cases. Credit decision, for example, where you're using machine learning model to predict creditworthiness far more efficiently than traditional methods. And there are lots of these different kinds of use cases that probably, if you're already working in the financial industry, have a flavor of a machine learning model that covers one of these 5 use cases that I'm showing on the screen. However, typically, when we start our journey helping financial industry implement machine learning, it's just not the 5 use cases that you've seen on the previous slides, right? We can easily list up to 50 use cases that can actually help an organization or a company. I've only gone up to 36 here because unfortunately I'd have run out of space. But the difficulty isn't listing a machine learning use case. The difficulty with most organizations is about identifying and prioritizing machine learning use cases that's aligned to companies' strategic goals. Aligned to companies' strategic goals. That is the difficulty. So before moving on actually to something that we've created in Advancing Analytics, this was another report that I wanted to share with everyone. This is a report that was published by Gartner back in 2020, where they've shown how a lot of companies who are starting their journey on machine learning and trying to introduce machine learning, the first challenge that a lot of companies face is trying to identify that valuable use case, right? That use case that can give them the quickest time to value. If you solve that challenge, then of course there are other challenges that companies face. But really, what we're talking about here today is identifying and prioritizing this use case. Once you get past that, you've got other challenges. For example, Gartner is showing here you've got skills shortages. Have you got the necessary skills to use AI or ML techniques? Whether you've got sufficient amount of data to address the selected machine learning use case that you wish to address, the technology and the organization. But for the purpose of this talk today, what I'd like to share with you is a framework that we've developed in Advancing Analytics to help companies identify impactful machine learning use cases. And throughout the framework, there's been a single goal that we've always kept in mind. And the goal of the framework is to identify the most impactful, measurable business use cases that are achievable in a limited time frame. So let's have a look at this framework. This framework consists of 5 stages. Now, depending on the size of organization, it can take anywhere between 3 to 5 days. It's a pretty full-on process. It's full-on days, full-on workshop processes that starts with just kind of analyze, right? When I say analyze, what I mean by that is about understanding the vision of the business. What are the challenges that the business are facing, and are there any opportunities that can be quickly written down? We then move on to the define, which I find the most engaging workshop, because this is where we sit down with stakeholders across organizations. We try and understand what they have as goals, what are their objectives, and where is a company heading from their point of view. Then we go on to ideate stage, which is also an exciting stage if you're a data scientist. And here's about trying to figure out if you've got a problem, how can you generate innovative and creative business-specific machine learning use cases? And once you do these 3 steps, you then get on to assess. This assess stage, we've developed in Advancing Analytics specific canvases to really draw out requirements from stakeholders. So we'll go through this as well. And once we finish the assess stage, then it's about prioritizing, right? Because from the slide that we saw previously, it's very, very easy to come up with 50-odd use cases. But the importance in here is that when we're helping organizations is to be able to prioritize And by that, I'm meaning ranking machine learning use cases by commercial benefits and feasibility. So given the time we have for this talk, what I really wanted to go through is I've highlighted 3 sections within our framework, and I'll take you through the define, the assess, and the prioritize, okay? So let's have a look at the define workshops that we tend to carry out. This process, what it involves is engaging with your C-suite executives. And this could be your CEOs, your CDOs, your CTOs, and CIOs. It's not limited to your C-suites as well. We engage with the heads of departments and the business stakeholders. And you might be wondering why, but the C-suites executives, they tend to be responsible for setting the overall direction and vision of a company. And when you sit down in a room with them, they tend to have very different goals and objectives compared to your heads of departments and business stakeholders. But when you're trying to figure out your machine learning use cases, it's very important to consider what visions they have and what their long-term plans are for a company. Then you've got heads of departments where they understand for a particular department they're heading up what it takes to make them successful. So getting their outlook as well is very important. And you've got your business stakeholders, right, where their knowledge are deeper. They understand what it takes or what things could impact their area of interest or expertise. So it's very important to sit and engage with all these different stakeholders and gain their perspective. So once we do that, our ideas are flowing, right, in the rooms, in the workshops. We tend to have lots of different ideas. But then how do we collate all those ideas and formulate a machine learning use case? And this is where we use our ML Canvas, and we've used it for years. So the ML Canvas is essentially a framework, right? It's a framework to help organizations evaluate potential machine learning use cases. The machine learning canvas that you're seeing on the screen, we've got 9 little boxes. And what it allows us to do is allows us to be structured in the way we ask several questions to try and assess what kind of machine learning use case would be the best to solve the business problem. So let's go through a couple of examples, right? So if we start up, for example, with model propositions, the kind of questions that we would try and ask is, how could we apply machine learning to solve this problem, as an example? Typically, there's more than one approaches, and we'll try and identify all those approaches, analyze them, and figure it out. Moving on to decision outcomes, this is quite an important question. This is quite time-consuming as well. It's about trying to, what we're trying to predict in a problem, and why are we doing this? This box, although being very small, it does take a lot of time, and it gets people thinking about exactly what are we here, what we're trying to do here. Then we go on to the likes of decision inputs, right? How are people making the decision currently? What are the features that we need to be considering for the machine learning use case? And all these kind of different questions that you see on this machine learning canvases are questions that we would sit down with stakeholders, typically would take a day, and fill this canvas out. Okay. So what we've just been through is a machine learning canvas. When you talk about, or when you're looking and focusing on financial services, there's also an element of ethical consideration and making sure the model that we develop has got responsibility, is responsible. So we've got another canvas that we look at what kind of data sets are there? Do they need to be anonymized, for example? Who are the stakeholders that are going to be involved? Would it be harmful to a particular demographic of people? All those things we would also try and understand. And moving on from ethics and responsibility, we have the MLOps canvas, because with every model that we come up with, or every potential machine learning use case that we come up with for an organization, the end goal is to operationalize machine learning. So understanding what's required from very early on helps us build out the whole pipeline process in our heads. So all these three canvases, right, allows us as consultants to focus on the end product before we write a single line of code. So we tend to do all those three canvases for every potential machine learning use case, and typically we'll have more than 4 use cases per business problem. But then it comes to a problem: how do we prioritize the use case? What can we do? And what we would do is collate all those use cases in a machine learning backlog, and then we tend to use a matrix as to what you see on the slide here, right? So if you look at the matrix, we've got 4 sections. You've got your quick win section, where that would all your use cases that have got low complexity or cost, but provides a really high benefit or business value, will be grouped within your quick wins. Then you've got your big bets, and these are your machine learning use cases that will cost quite a lot to be implemented, but also provides really high business value. And then moving on, you've got your box number 3, which is your think about it box, where the complexity of implementing your machine learning use case is low, but the benefit is not great either. So you tend to just think about it. And then you've got your thankless task, where your complexity is extremely high and it offers very, very little benefit or business value. So those are the kind of things how we would prioritize machine learning use cases. Okay, but I understand it's been very conceptual from what I've been speaking. So what I've really done here is created an example, and this shows a snippet of a machine learning backlog that we would typically carry out for a business or organization. So here, what this table shows is 5 use cases that we have would have probably collated from doing all the machine learning canvases. We would have put it on a machine learning backlog, and what we would have done then is gone through complexity and business value. And for example, if you look at the complexity column, that can be further kind of divided into how risky is a particular model going to be? What's the data quality? How complex is the model lifecycle? And this information would have already been assessed in your machine learning lifecycle. So it's about getting those requirements and then listing it on a table that looks something like this. And if you look at the business value, you then tend to understand what's the impact. So for this line here, you've got fraud detection. What's the impact of implementing fraud detection models? And it'll probably help the organization to make better decisions. Is it part of the organization goals? If it's a yes, it will probably score far higher. And what's the estimated return on investment? So this is just an estimate as what we would do along the canvassing and workshop processes to gain those information to help us develop this machine learning backlog. And when we do this, what we can do is we use a scoring method to score how complex each of the use cases and what value it provides. So we do this for all use cases, and then what happens is we plot it. Okay, we plot it in the matrix that you saw earlier. So for example, the fraud detection model, it's actually scored to be a big bad. So we will place it in that box where it's a big bad, and we won't, if we've got quick wins, it makes sense to implement the quick wins. And if you look at credit scoring, because of how it's been scored, it appears in the quick win box. And we would do this for all the use case that we have that's on the table. So I think there's one more. And yeah, so you've got a couple of use cases that fall within the quick wins. One's use case within your big bats and another one in your think about it. And when you start off this process, you probably would start thinking, I'm just going to be implementing a fraud detection model. But when you go through this process from end to end, you then realize, it becomes very clear that are probably easier machine learning models to implement that will give you that quick time to value, a quick return on investment. Okay, just to kind of summarize then, in terms of the framework that we have, we start with 5 processes, right? 5 steps. We start with analyze, we go through the define stage where we're engaging with stakeholders, we come up with methods in terms of how we solve a particular business problem, and then we move on to assess and prioritize. So hopefully you've seen what we would go through typically with an organization who's starting on a journey, and that framework will be in our minds. We'll be using it to identify the most impactful, measurable business use case. So that pretty much sums up my section. And over to Zuzana and Kunal.
Thanks, Gavi. So if we can have the next slide. On top of what Gavi covered, I would like to highlight what we have learned from you, clients, customers, the tech users, when it comes to your journey with machine learning. Kunal and I work with customers who are at different stages of their maturity journey, but the key themes really get repeated over and over again, and Gavi would have touched on them because they do need to be a part of that journey. The first one is truly bringing that C-suite on the AI journey with you. There is an incredible impact that certain use cases can deliver for your organizations, and that means that the people on the top need to be kept in the loop. And for organizations that are just getting started with machine learning, this means that you can get the right sponsorship, the access to the right stakeholders, and the access to the budget, right? And the sponsorship means that you can run these new innovation-focused projects as a key technology initiative, rather than a side shadow IT project where you may struggle to get the right resources aligned. So I think, making sure that you've got the right people involved in the conversations early on is important. And it can go the other way, right? We can't have the execs saying, look, we need to do AI. We need to find out where to focus, which is where Gavi's framework really comes in handy. And then secondly, it's been highlighted again, and this is essentially the first place where organizations start is, how do we align with our business strategy, and how do we find out how to align with the business strategy, right? It comes down to what is important to your business at the moment, what is important to the executives, to the heads of departments. And that's why it's important to bring them on the journey with you. Aligning to priorities across creating a competitive advantage, competitive edge, customer retention, innovation, churn. It's all about focusing on those high impact solutions. Then I'd say a common theme that we often see is analysis paralysis. And we'd say, you can do a lot of work, a lot of groundwork to make sure you choose that initial use case wisely. But a proof of concept is a proof of concept for a reason. We try to remind organizations. You either prove there is value in your solution early on, or you can fail fast and iterate from there. So I'd say that's an important point to make, because sometimes we do face organizations where they find it really difficult to get started because they get stuck in analyzing all the possible solutions and directions they could choose. Then I would say investing into your skills continuously is so key. As we all know, the pace of innovation in this space just does not stop, and new technology is being introduced all the time, especially in the AI machine learning space. And there are a lot of materials you can use online. Many of them are available for free. There's the Microsoft Learn resources, etc., if you require. Or we also see a lot of organizations who are higher up on the maturity scale and they require more tailored courses. So again, do invest into your training where you require. Even us as Microsoft, we have dedicated learning days just to make sure we can keep up on all the releases. And lastly, and this may actually be one of the most important points, but advocate for your team. Share your successes with your proof of concepts, with your pilots. Share them internally, or if it's appropriate, externally as well. Work with your marketing teams, with your PR teams. This will really help you grow your own talent in the organization and attract new talented individuals. In today's world, I think we would all agree that people want to work for organizations that, work on exciting, meaningful projects that truly make a difference. So why not become an organization like that? Really position yourselves in the market as an innovative business, especially in these market conditions where the war for talent is really apparent and quite tough in the data and machine learning space in general. And those would be the common themes that we really see across the market. So I hope that those resonate with you, that you can think that you're not alone in the situation. And what I'd love to do next is share a use case with you together with Kunal. And when we were thinking about what use cases to go through, we thought that determining the customer lifetime and churn would be quite interesting to cover. So, Gavi, if we can go to the next slide, please, just to bring everybody on the same page so we know what we're talking about. Customer lifetime value is the total amount of money a customer is expected to spend with your organization on your product during the lifetime of that average business relationship. And customer churn or attrition is the number of paying customers who do not become repeat customers. And of course, everybody's trying to increase the customer lifetime value these days and reduce the churn, of course, right? And Kunal, I think we actually have some interesting statistics on this topic, don't we, Gavi? If we can go.
We do in fact have a couple of interesting statistics. The first one actually is from a company called CallMiner, which basically highlighted the fact that in US companies basically lose about $136.8 billion worth of revenue every year because of avoidable customer switching. So imagine if you've got the focus on your customers, if you have the right kind of machine learning models to predict, what are the customers who could possibly churn, and really focus in providing them the best services and products that you can offer, you can potentially, save on a lot of those revenues. And there's another interesting statistics from Harvard Business Review, which talks about the fact that, increasing customer retention by even as low as 5% can, increase your profits by up to 95% and as low as even 25%. So we all know, customer acquisition costs are real for many businesses. So if you have customers and if you can kind of understand their behavior, if you can understand, what improvements can we drive to the products and services and try your best to retain them, that's a win for the business, and that's also a win for the customer.
Thanks, Kunal. And we've spoken about the use case, but what would the architecture actually look like in this scenario?
Yeah, so we've got a very high-level overview of an architecture for a machine learning use case implementation in Azure. This architecture talks about, how do you design your architecture to fulfill something like a customer lifetime value, and how do you predict churn. So I'm not going to go into too much detail, but just I want to make it give an overview of how easy things can be when you do it in Azure and use some of the managed services. And we talked about the fact that, trying things out in the cloud with all these services is so easy. So you can try and, really experiment with stuff. So if you look at the left side of the architecture, imagine you've got all the data sources which are housing the customer data. That customer data could be, customer demographics. You may have data regarding the customer subscription, in the sense, what are the kind of customers who are, using your products and services. You may have data sources which talk about what is the feedback like from your different customers. And really all that data could be sitting in different data sources. So it's really about, bringing all that data into Azure using something like Data Factory. So Azure Data Factory is a service which really helps with the ingestion of data. And for folks who are just starting out, it's very easy to pick up because it's a very GUI kind of an experience. It is a very low code, no code kind of a service where you've got like a studio kind of an experience. You can bring different activities together. So you could bring an activity to say copy data and say, move my data from this source to this destination, provide the minimal sort of settings, and the service does that for you. So really getting started is really easy. And then you can really build a kind of a pipeline within Azure Data Factory to say, if this particular process or activity succeeds, go do this. If it fails, go do this. So the idea is you've got ADF to really bring all of those data sources into the cloud. And in this case, we're bringing them into Azure data lake storage. So think of Azure Data Lake Storage as an implementation really on top of blob storage, designed specifically for big data and machine learning use cases. So it's really the layer where you can dump all kinds of files. Could be JSON files, CSVs, Parquets, ORC, really just any relevant data, you can bring it into the lake. And then on top of that, we've got an Azure Databricks service. So using Azure, so just to give you an overview, right, for folks who may not be aware, Databricks is a service in the Azure portfolio, which basically provides you with a managed Spark cluster. And I'm sure folks here will be aware that Spark is generally the preferred tool when it comes to big data, machine learning, and it's a massively parallel processing engine, does all the processing in memory. So Azure Databricks provides you that environment along with a Databricks runtime, which basically just adds more nice to have features on top of Spark, and it's a managed service, and what that means, it makes your life a bit more easier to work with these tools. So essentially, in the Databricks side of things, we've got the first step, which is which is called data processing, right? And in the data processing, essentially what we're doing is we've got all of the data which landed into the data lake, and now we're just trying to process it, clean it, make sure the quality of the data is superior. Because as we all know, the quality of a machine learning model is only as good as its data. So we really want to make sure that we're cleaning all of our data in the data processing step. Then we've got something which is known as feature engineering. So feature is basically all the data points that we have in our data set. And based on these data points is how we're going to make our predictions. In this case, we're going to make a prediction to say, whether this customer is going to churn or not, yes or no. So based on this, feature engineering comes into the picture where we're really looking at those data points and seeing, what are the kind of data points which will add value to our model. Is there anything that needs to be removed? Do we need to create more features? For example, if we've got different data sets and with customers using different products, we could create another feature to say, what is the total revenue that we are getting from one of our customers? So things like that we will be doing in feature engineering. And then we move on to the model training aspect of machine learning, where really we have the data set, historic data set, to say, this is the statistics or data points we had for this customer. And given these situations, did the customer churn, or does the customer still, we have this customer still using our services? So using all of that historic data is where we can really, build our machine learning model. In something like this, we could be doing, a supervised learning model specifically for classification to say, is the answer yes or no? Meaning, is the customer going to churn or no? So we design on that model, train it, and in Databricks, you can use what's known as MLflow. MLflow, again, is really powerful library, which helps you with the managing all the life cycle around machine learning. So if you're going to run different experiments, if you're going to be tuning the hyperparameters, if you're going to be using different algorithms, MLflow really makes your life easier to be able to track all of those, to say, when you use X model, when you use this was what the, let's say, root mean square error looked like, or the accuracy looked like. So that can really make your life easier in terms of tracking what you've been experimenting with. And then, when you're happy enough with the model that you have, then it's really time to productionize it. And in that case is where you would typically register the model first. So to register the model, you can register it in Azure Machine Learning, which is, again, another machine learning service within the Azure portfolio. You'd register the model, and then you have the option to deploy that model. Again, when it comes to deployment, you've got a lot of options. The first one being just Azure Container Instance, the other one being Azure Kubernetes Service. And then we also have managed endpoints, in which case you don't really need to worry about spinning up the infrastructure that's going to manage your endpoint or the model, you can really rely on Azure to spin up that environment for you, manage it for you. So we're seeing more and more customers use that. So with this, we've productionized the model. It's up and running. We've got an endpoint that we can call, or we can call it using an SDK. And this is where we start driving benefits from that model. So we can now run what's known as inferencing. So we've got a bunch of data about our current customers who are with us, and with that, we're trying to predict, are they going to churn in the next year or so? Yes or no? And all the insights that we're drawing from this, the inference data as well as the customer data, in this case, we're trying to drop that into something like an Azure SQL database. And this Azure SQL database is something that you can connect to the likes of Power BI, so you can really visualize it. And most of the times you would be sharing this data with senior stakeholders or folks within the business who wouldn't want to go into a database to get this information. So you can really, have very visual graphs to analyze the data, make sure they can play around with the actual data in a very visual way. And that's where, Power BI can be a really powerful tool. And we've got Azure Analysis Services in the mix as well. So if you're doing any sort of complicated modeling, again, and you want to cache a lot of that data and improve the performance for your visualization, you can use Azure Analysis Service. Or if you're using something like Power BI Premium, you might as well do the modeling there. So this really just captures what a life cycle of a machine learning model could look like. But again, in the Azure portfolio, we've got so many different services, and sometimes it just comes down to what your preference is, what the knowledge is within the business. So I hope this is helpful.
On that topic, what about citizen data scientists that may not be able to code fully? Are there any services they could consider as an alternative as well to help them out?
Yeah, glad that you brought that up, Zuzana. So in Databricks, it's more of a code-based experience. You have a notebook, and within the notebook, you can write a PySpark kind of a code to really implement those model trainings. But we do have other options as well for citizen data scientists who may not be very comfortable writing a lot of code, right? So even within Databricks, we have something known as AutoML, which is again a library which helps you do a lot of coding in less number of lines of code. So instead of having hundreds of lines of code, within a matter of few lines, tens of lines of codes, you can basically write the same thing. And as a library, if you want to solve a classification problem, the library can go in and use different algorithms, see what's the accuracy like for those algorithms, and then you can pick the one that you like. So that really makes it easier. And then we talked about Azure machine learning. Even in Azure machine learning, we've got automated ML. So again, the same kind of functionality is available in a very GUI kind of a way. We've also got a designer functionality in Azure. So for folks who are just starting out, who want to play around with machine learning, again, it's like a canvas experience. You bring in different activities to do different kinds of data processing, feature engineering, and modeling. And once you're happy enough with the result, you can productionize it. So a lot of different options there for our customers, Zuzana.
And hopefully not a tricky question, but how easy is to get started?
Well, it depends, right? So typically, as you can imagine, if you were to do this in an on-premise, you typically want to have the right kind of infrastructure. That would mean sometimes even having the right kind of machines or hardware, which is equipped for a good amount, which provides a good level of CPU and GPU power, right? But within a cloud provider like Azure, you don't really have to worry about it. So you can just spin up the machines which are powerful enough that you would like for data preparing and model training. And in terms of how long it can take, well, you could deploy something in a matter of hours, or it could take weeks depending on where you are in your maturity curve with these services. But as you said, getting started is really easy with the cloud, and these tools and services really make it easier for you.
Thank you. Okay, well, Gavi, can we go to the next steps now?
Absolutely.
Thank you.
Yeah.
Right, so I suppose, the big thing is if you would like to have a chat with us, carry on any of the conversations, get in touch with us. You can reach out to Advanced Analytics via their contact page, or reach out to any of us directly via LinkedIn, and we'd be happy to carry on the conversation. We did speak a lot about training and learning. If you're not sure where to start, there's a really nice set of resources on the Learning Pathways website where you can go and select specific roles. So be it machine learning engineer, data analytics engineer, and it will have loads of really useful links to the right training. And I believe, Gavi, your website also has some really useful training links as well. Plus, again, I would really recommend just following yourselves on Advanced Analytics on YouTube. The videos are great. I myself have a lot of customers who are big fans. And lastly, Kunal, I believe you are going to touch on the architectures as well.
Yes, there's a whole large library of architectures available to you. And in fact, the architecture that we just discussed about in the last slide, it's one of the architectures from the library. So for all of the major use cases, you've got architecture diagrams that you can use for reference, and obviously change services to suit your needs better.
Yeah, and I've also popped some links if you're interested to have a look at the report that's been published by the Bank of England and Financial Conduct Authority. It just gives you a bit of a flavor, right, in terms of the typical use cases that are being implemented within the UK in the financial services. So 2 really good surveys, and those are the. And I think that's it, right? The last slide is a thank you slide. So yeah, thank you for listening. If you've got any questions, more than happy to take them.
Thank you very much, all three. We haven't got any questions currently in the chat, but we've got, we do. Let me just get that one up on the screen. Why in the architecture he chooses Azure SQL for the Power BI ingest, and how long would it take for that scheme from data ingest to data visualization with a simple ETL environment?
Thanks for the question, Pato. So as I said, this was a reference architecture from our website. And again, you can think of it like Lego blocks, really. Depending on your use case, you can just use a different combination of services to use the same thing. So if you want to do predictions, the result that you're getting from the inference, you might as well drop them into something like a Azure Data Lake and connect your Power BI directly from a data lake. So that's also one of the possibilities. Again, with all of these things, it really depends in terms of what exactly you're trying to achieve. If you've got specific, time frames, time limits that you're working with in terms of the responses. So yeah.
Thank you. I'll wait a few more moments for some more questions to come in. But thank you very much. I was most surprised about the customer churn statistics. That's like a huge number of increase. Pretty cool. Yep, no more comments. But again, thank you all three. That was really interesting.
You're very welcome. All right, cool.
Thank you.
Thank you. So I will put a reminder for the schedule on the screen, and then we will wait a few moments for our next speaker to show up. Hello, everyone. Welcome back to the Global AI Bootcamp. We're just coming up to the next session now. So just before we get started, there's the schedule on the screen. We are currently in the Johnny 5 room stream at the moment. We also have another stream going on at the moment, which is the Wally stream, based around some more MLOps based topics. And so that is the 2 o'clock session is how to build responsible AI model in Azure ML Studio with Sabani Matey. And this is the Johnny 5 room where we'll be hearing from Liji Thomas about Azure Speech AI, give your users an app a voice. I am going to introduce you to Liji now, just add her to stream. Hello.
Hello.
Am I right saying Liji? Is that the right?
You are absolutely right, Tori.
Perfect.
Nice to meet you.
Lovely to meet you as well. Cool. So we'll give it a minute and we'll try and start on 2 o'clock on the dot. So hopefully that'll give you some chance if I remove my slide to get your slides up.
Okay. I'll go ahead and share my screen.
Fantastic. And I will add that. There we go. Perfect. Okay. Anyway, how are you?
I'm doing well, thank you, Tori. How are you?
Yes, good day. Good day so far. It's been a lot of good sessions.
Yeah. So it's 8 a.m. my time where I'm joining.
Wow.
So it's a rainy, dark, rainy, cloudy day for me.
Where are you joining from?
I'm joining from Central US.
Yep.
Yeah. So it's a Friday, so that's good. So
yeah, but it is early. So
it is early. Yeah. I mean, they're kind enough to schedule it in a way that I could just wake up and I could do it.
Yeah.
So it's good.
Oh, well, thank you. Thank you so much for joining us. It is 2 o'clock, so I will excuse myself and let you introduce your session.
All right. Thank you.
Thank you again.
Sure. Hello, everyone joining Global AI Bootcamp London. Thank you for taking the time to join this session. We will be talking about Azure Speech AI. And before we get started, a quick introduction about myself. As Tori said, Liji Thomas. I'm a manager with data and AI with Valorum Reply. We're based out of Central US. I'm an MVP in AI. And those are my social media credentials if you'd like to stay connected after this. So with that, we get started on the topic of the day, which is Azure Speech AI. So before we go into the speech AI, take a step back and talk a little bit about AI and the proliferation of the technology in this space and why we are seeing a lot of interest and a lot of advancements in this space. And we talk about the Microsoft offerings in this space, and we talk to speech AI. So, across the globe, there is less doubt anymore on the business benefits of AI. Organizations and business leaders are quite convinced about the business benefits of AI across the board, across industries, verticals, and any business function. But some of the common challenges when it comes to building AI solutions includes the fact that these organizations do not have the right resources in place in terms of skill sets to add AI capabilities to existing applications or to new applications. So, of course, there's always the challenge of data and data science skills. And then how can we use existing skills and then layer AI on top of these applications, the existing applications? So 51% of organizations believe that organization leaders believe that they do not have the right AI capabilities to be able to add AI to LOBs. That said, that's where the benefits of cloud AI services come. Now, cloud AI services is a very broad bucket of AI services, which includes AI services that are hosted in the cloud. So these AI services can help with a lot of current AI development challenges. It helps with deployment challenges, and there are specific advantages of the fact so scalability, security, reliability, these are all pre-built and configured AI services that are hosted hosted in the cloud. And of course, there's the added benefits of AI service adoption that that every business or every organization can take benefit from. So Microsoft has been investing in the space for the last couple of decades right now, particularly through the Microsoft Research Center. This is one of the stories that I speak very passionately about in almost all of my presentations. If you've seen this previously, if you've attended my presentations previously, you'd relate to this. But it's a fantastic story to sort of say, the history of where these AI services come from and how they came to be and how we get to benefit from this. So years ago, Microsoft AI, before AI was even a hype or a thing, started investing in AI. Microsoft, through their Microsoft Research Centers across the globe, started investing in these high advanced algorithms to the point that some of these were even able to achieve human parity. So some of these algorithms like speech recognition, the one we're going to talk about today, machine translation, reading comprehension, conversational Q&A, and image captioning has achieved human parity. What that means is the algorithms or the machines can do as good a job at these tasks as a human can. A machine can caption an image as good as a human can caption it. So given that precedence, Microsoft went ahead and started dogfooding these technologies into their own applications. So now we are familiar with a lot of these AI capabilities in these applications, but for a long time, it was so seamless and so intuitive that we probably did not realize that we were dealing with a lot of AI inside these applications. Like Teams, for example, is a classic example. There's a lot of AI-driven features within Teams, and so is within Outlook and within PowerPoint. And I used a couple of them for preparing this slide myself. So we use AI on a daily basis, even within the Microsoft suite of applications, probably not even realizing it as much. So under the hood, these services are actually powered by cloud AI services. And to take it one step further, what Microsoft did is they packaged all this, bundled all of this goodness, and they released it to the developer community so that you and I can use these AI services to build custom applications for our organizations and our customers. So this is where Azure Cognitive Services come into play. So Azure Cognitive Services is Microsoft's flavor of cloud AI services. These are a collection of customizable and pre-built AI models. And this is probably the fastest route for any business to integrate AI into new or existing applications. So if you want to build a Wall-E today, probably it's possible even with a few lines of code. It's the kind of emotional intelligence and opinion mining and all of these that you can even add into this. So it is possible to build intelligent applications using Azure Cognitive Services. In the AI portfolio stack of Microsoft, as I just wanted to show you the tech stack there. If you see right from the bottom, we start with machine learning, and there's a machine learning platform which is used to build custom AI models. And then a certain abstraction of that is what is available in the form of cognitive AI services, the part that we are talking about right now. So this includes vision, speech, language, decision, and as of late, open AI as well. And then there are further abstractions up the layer where you have scenario-based or applied AI services, which are very business task-specific AI services. For example, bot services used to build conversational AI applications. And then you still see AI services in Power Platform in the form of AI Builder and other areas, and slowly into the D365 applications as well. So now you know sort of where the cognitive services sit in the AI portfolio stack. And then of all of these, we're going to discuss and going to deep dive into the speech area today. So if you want to give your apps a human side, you have APIs to bring AI into your applications, specifically vision, speech, decision, language. And I said as of late, OpenAI, which is now in GA, and you can use that as well. So for the rest of the session, we will be looking closely into Speech API, and we'll see what the capabilities of Speech API and what is the advantages or what are the features that it provides us, and how can we use this into our applications. So speech service. Using speech service, as it's evident from the name itself, you can develop quickly very high quality voice enabled apps. So it can be speech to text, text to speech. It includes speech translation. You can use custom keywords, and we talk about what that is. There is intent recognition, speaker recognition, or diarization as they call it. And we will look at each of these in detail. But to get us started with, I thought we'll start with a demo, and then we'll come back and do the feature discussion. So we're going to flip things a little bit here, and we make this a little interesting. So sometime last year, Microsoft released a portal which is called the Microsoft Speech Studio, which I think is an amazing product to for users to come in and to just be able to play around with the speech capabilities. So Speech Studio does not require you to write code. It's a no code situation. You come in and just play around with the services and understand the capabilities of the speech AI services. And you have similar studios for language. You have Language Studio. This is specifically for speech. So this is what I would recommend as an easy go-to place for you if you're getting started on this, to understand better, to explore the capabilities of the speech APIs. Let's try some of these, and it's easier to do this and to see this in action than me to go through the deck. So a couple of these. So let's start from the top. You have, as I look through these, we have speech capabilities by scenario. So let's say captioning with speech to text. If I have to try that and I click that, I see that there are already sample videos. I can upload my own videos and see that as well. But you should be able to see real-time captioning of these videos that are in here. I did share my audio, so I'm hoping you would be able to hear as well as see this.
When it comes to the neural TTS, in order to get a good voice, it's better to have good data.
To achieve that, we build a universal TTS model based on 3,000 hours of data.
We actually accumulated tons of.
So I'm sorry to interrupt it right there, but then you see the real-time captioning that is happening with those videos, including just by uploading a sample clip. So if you're requiring to have, if you have a use case that requires you to add a captioning, that is possible. Offline captioning is also possible. Now, within this scenario that we are talking with, just within this page, if you go down, you will see the developer resources that are available, even in the form of code. You can code in C# or any language of your choice. So one of the beauties of this whole paradigm is that you build on your own terms. So you can come with any skill sets that you have in terms of programming language, and then you can pick and choose which language to be able to code in. So you have your code available for the resources. You have, if you want to use this end to end, what you would need to do is, if you have an Azure subscription, or you can create a new Azure subscription for free, you get a trial Azure subscription for a couple of credits, and then you can create a speech resource in there. You select the speech resource and you just follow the same quick start in order to use this in your particular application. So the code is there, the quick start, the steps are there, and you get to see how this is done. And as you do this in code, you would have other settings that you can adjust if you need to, depending on your specific use case, to specify specific situations. So you go back and let's try something else. So post-call transcription and analytics. This is a very common use case, I'd say. Imagine you have a call center where you've got thousands and thousands of logs of customer calls. And two scenarios that are required there is, one is to analyze the sentences, and the second is the summarization. So the first part, if I have to play this is consider this a sample audio of a call that has occurred, and you will see here how the sentences are being analyzed. And one feature that you might appreciate is if I turn on this particular filter here, hide PII, you'll see that the person analyzing the sentences will not be able to see the personally identifiable information. So none of these will be available to the person who's analyzing the sentences. So let's take a look at that.
Good afternoon. This is Sam. Thank you for calling Contoso. How may I help?
Hi there, my name is Mary. I'm currently living in Los Angeles, but I'm planning to move to Las Vegas, and I would like to apply for a loan.
Okay, I see you're currently living in California. Let me make sure I understand you correctly. You'd like to apply for a loan, even though you'll be moving soon. Is that right?
Yes, exactly. So I'm planning to relocate soon, but I would like to apply for the loan first so that I can purchase a new home once I move there.
And are you planning to sell your current home?
Yes, I will be listing.
Okay, so you get the idea. And for the same thing, you can also do a call summary. Sometimes you have hundreds and thousands of calls and you just need a summary of that call. And this is how a call summary can be created. Likewise, as we discussed in the case of captioning, again, if you go down, you have the code that you can refer to and the resources and how to get started with that. So that's another example of how we could use speech in specific scenarios. And as you go down, you will see specific scenarios where you can use speech. One of the most common ones that we are aware of is real-time speech to text. You can upload your audio here. You can even speak to it, and you will see how this is happening. If I may try this for a second here. Hi, I am presenting at Global AI Bootcamp London 2023. And you see how the text was just created there. An audio file is also created. You can download the audio file and check it out yourself. You see the JSON response behind the screen of how the JSON is created. The same case as previously, you will be able to have access to resources if you need to try this out. So you have sample code in GitHub, you have the documentation, everything within here. And please note that these are also available for deployment in the cloud and on containers as you need. And we'll talk about that a bit as to what those scenarios might be. Custom speech. So for custom speech, these come into scenarios where you need to bring in your own data and you have specific vocabulary or industry specific terminologies, and you need to create a very customized speech to text model. And it's totally possible to do that using this. Same thing goes for pronunciation assessment as well. Specifically in educational scenarios, if you need to give feedback for pronunciation, this is a good way to maybe even practice speeches and coaching. And it comes back with saying, you have samples to try out here. You can even enter your own script, and it gives you real-time assessment of how that pronunciation is. For example,
we had a great time taking a long walk in the morning.
So if you notice, there was an insertion there, and there was an omission. There was one omission and one insertion that was caught in that one sentence that was spoken. So you get the idea. So that's how pronunciation assessment, which is a fairly new feature in this, but I think is very applicable depending on the scenario that you want to use it for. Voice gallery. This has got quite a few voices out of the box, voices that you can try, and then you can use it depending on the use case that you'd like. And you have specific assistant voices, customer service voices, cheerful, excited. So voices like that. And then once you select a resource, so let's say I select a resource, and I'm going to select a resource. So you have to then go to Azure and then configure that resource to be able to continue the story from there. But then you have a wide variety of voices to select from, depending on the language, depending on the gender, the speaking styles that you want to use, and so on and so forth. So a total of 25 voices here. And you can use these in your applications as need be. The next one we see is, so similarly, now if none of those suited your purpose and you want to create a custom voice of your own with a one-of-a-kind kind of voice, that's also possible by using this feature. And then audio content creation, custom keyword, custom commands. Consider this the way that you would wake up Alexa or Siri. And I hope she hasn't waken up now. So that's how you would use custom keywords or custom command features. So Speech Studio is a good go-to place for you to start exploring some of these API features that we're going to go back to the slide and now going to discuss. So as you saw in the demo, speech to text is one of the most primary features that we have access to. It provides for high quality transcription. You get very accurate audio to text transcriptions as you saw in the demo. So these are production quality, again, as I said, because these have been tried and tested and it's out there in so many applications that we are using on a daily basis. And it allows for transcription from not just the microphone, but also from audio files or blob storage, including speaker diarization, like who said what, when, where, how, etc. As you saw in the call center example there. Also, a part of speech to text is other features like customizable models. And we just saw that we can create industry specific, organization specific speech models if need be. We can also have the deployment flexibility, like some of these cases, for example, let's say a manufacturing case or warehouse scenario where you have a lot of background noise or where you have latency issues or network issues, say bandwidth issues, and you do not always have the luxury of being connected to the cloud, or let's say you're on a cruise ship for whatever reason, and then you need to be able to run these models. It is possible to run these in the cloud and as much on the edge or in containers as well. So that's how you can build speech applications that are optimized based on where you want to deploy these models. So just like we have speech to text, we have text to speech as well. So text to speech is used to, again, you can use these capabilities if you want to provide a unique voice to your application, to your features. So as we saw in that voice gallery, there are a plethora of voices that you can choose from. You can even go ahead and create your own voice, your custom voice if you would like. So you have very fine-grained control over the pronunciation, the rate, the pitch, the pauses, everything. So it's very nuanced, I would say. And to take it further, we do have the capability of speech translation. Now, typically when we did, I think we must have missed to show you the speech translation feature there. But when we do speech translation, what we've typically seen even in search engines is you have to give a source language and a target language, and the speech gets translated. We also have the capability for automatic language detections. So if you do not specify the source language as well, there is a capability for auto language detection, speech to text, where it identifies the language at the beginning and then translates it accordingly. And of course, there is, needless to say, support for hundreds of languages in this feature. And then custom keyword, as we did discussed, right? So when we start speaking, it is able, if we configure custom keywords or custom commands, it will identify those custom keywords with specific features that need to be run. And it's followed, as you can see in the architecture, into the same pipeline as we would send the audio itself. But it is, if we configure a custom keyword, the keyword verification feature kicks into play. Intent recognition. This is a feature that is typically used in conversational AI solutions. Let's say you tell a chatbot or an assistant, book 3 tickets to London, right? So you and I can say that in so many different ways. I could say, I'd like 3 tickets to London. I'm going to London next week. I'd like to have 3 tickets booked, and so on and so forth. But it is important for a an assistant or a chatbot to understand the intention of the user so you can map that down to the correct response. So understanding the intent behind a set of utterances is a very impactful feature, which comes out of the box with speech. So speech API is connected behind the scenes with LUIS, or language understanding service. So this provides it the unique capability to extract intents and understand what the user wants directly out of our speech API itself. So that is an added advantage for the speech APIs. And last but not least, we have the capability for speaker recognition, and you must have seen this even in Teams or even in the speech studio that we just showed right now. We can identify not just convert the voice to text or text to voice. We identify who said what, when, where, etc. So that the speaker identification is an implicit part of the equation here. So with that, we come to the end of the discussion on all the features of Speech API. What started as probably a very simple speech to text and text to speech, but you see there is much more to the Speech API and the AI service than the classic speech to text and text to speech, which we are all very familiar with. So there are capabilities for translation, for transcription, for speak diarization, for ability to code in your own languages, in any programming language that you are familiar with, deploy it in cloud, deploy it in containers or on the edge, and so on and so forth. And it'd be great to see applications, that bring this together, be able to see how real life use cases can put a couple of these at least together and see how these kind of works and how these can be impactful. So in my organization, we built a small application which I'd like to demo right now. And this is an application that we call Name Dropper. And no spoilers on that, and I'll let you decide why. So before we get on to the demo, and I show you a short video of what that looks like and how we used the speech capabilities for that, I've probably spend a couple of seconds on the problem statement or the challenge that and I'm sure all organizations across the globe are very familiar with. So in your personal lives or in your professional lives, especially as much as we talk about diversity and inclusion and everything, our name, as unique as it is, should not ever be a problem or a challenge for anyone. So learning to say someone's name is a huge sign of respect and compassion. And from one side, and from the other side, we feel like no one should have the need to accept an incorrect pronunciation of their name for whatever reason that may be. And so stemming from that why is where we got to understand, and this is a far-fledged or universal issue, I would say, that we've seen, and probably a lot of us have seen in our personal and professional lives as well. And it was interesting as we did the research on this, we found a lot of good examples for this, but I'll share a quick video on some of these. Maybe some of these you are familiar with, this, you've seen this before, but you get the idea of what the problem statement is. So a quick video on the problem statement here.
My next guest is Dr. Jimmy Brungus. He's a nutritionist.
It's actually Dr. Johnny Bowden.
Dr. Johnny Brungus.
Iñárritu.
I have absolutely no clue how to pronounce this.
It's so nice to meet you. I'm a huge fan.
Thank you.
Yeah.
I'm a huge fan of you.
Thank you.
Yeah.
And it's Hassan Minhaj. Yes.
No. Well, my name is Hassan Minhaj.
Oh. The first part of it looks like Aguilera.
And Andreas Athen. Easy for you to say.
Please welcome the wickedly talented one and only Adele Dazim.
All right. So The proposed solution that we had is, as we would say in the case of any AI application, is never just the AI application. It is a combination of the human and AI, so you and AI together. Some of the existing solutions that we've seen for this is, for example, in applications like LinkedIn and other places where you're encouraged to upload a small audio file of the recording of your name so that others can hear how to best pronounce your name, and which is the most ideal thing to do. And we definitely did start there. But again, to the best of our experience, we trying to make the user experience as intuitive and as intelligent as possible, and trying to reduce the friction for the end user to be able to produce that voice file, that audio file. So we are trying to combine the power of neural voices, some of the artificial voices that you've seen in the speech studio as well as use text-to-speech capability. So we see how we can try and get the names right the first time as much as possible. Right? So this is a joint effort by the humans and the AI together, where we would need to review these audio files and stuff. But let's say you don't have an audio file. What percentage of people really upload audio files and make that available? So let's say if you don't have an audio file, what is then the next best alternative or a plan B? So here's our take on the Name Dropper app. So the tech that we used for this, again, as you say, is Microsoft's Azure Text-to-Speech service. We used, which as by now you'd know that supports over 140 languages. There are so many neural voices, and it's based on years and decades of research work, really. And hosted from cloud, it has all the security, compliance, and it's built up, ground up using responsible AI principles. So a quick video on the Name Dropper app. This is what the app looks like. This is the homepage. So you need to sign in to use the Name Dropper app. And this is just an internal app today. So let's say I want to look for a peer, and I would search for the name of a peer. And let's say let's search for my own name. So if I go Liji Thomas, and it tells
Liji Elizabeth Thomas.
So that was an audio recording that I had created and I had uploaded, and I'll show you where we can do that as well.
Heaven Mabry.
So that's another audio recording that we that Heaven had uploaded. So similarly, other folks. So let's say Aditya did not have his audio recording. So I'd like to still hear how to best pronounce his name. I choose English India, and I choose a male voice.
Aditya KV.
So that's the AI's recommendation of pronouncing that particular voice. And I can try for others as well. So I get to choose the location and the neural voice.
Arun Jose Matthew.
And just for the record, we will try and see how that same is pronounced.
Arun Jose Matthew.
And you must have noticed the difference between the how it's pronounced based on the locales. And we always add a note saying that this is just the recommendation from the AI and it's not formally approved. But if you go to your own page, we have a
Burton
place
Parker,
where we can play the file and we can see it. And we can also have where you can say it.
Burton Parker.
So if I'm happy with the AI's pronunciation, I would just save it to my profile and be done with it. But for any reason, if I want to upload my own voice and I'm not happy with the way AI is saying it, I always have the option to record the audio in a separate tool and to upload that as an MP3 file. And that's now going to be tied to my profile, which means anytime any of my peers look for me of my name, that's what they're going to hear.
Burton Parker.
So that's an example of a custom audio file that was created, that was recorded, and that was uploaded. So we give a combination of two features. Primarily, the first plan of action is always, the user uploaded audio file, which is the recommended format. But if a user does not have an uploaded audio file, what may be the next course of action is the recommendation that AI is providing. So I hope that was interesting. And that brings us full circle to our discussion for the day. And you saw a couple of examples of, how to be able to use Azure's cognitive service for speech. And we saw how to use it across the speech APIs, and we saw the advantages, the features of the speech APIs, and specifically how we were able to use Speech Studio to explore a lot of them as well. But before we complete it, I always add this slide to my talks, which speaks to responsible AI. So these services, the cloud AI services that we discussed today, all of them, this vision, speech, language, decision-making, OpenAI, and specifically the speech AI as well, was developed ground up using responsible AI principles. If you go to the Microsoft Documents site, you will see transparency notes on using each of these services. It tells you the biases, the limitations, how a developer should be using it, and what you need to know while you're using these services. But as developers who consume these APIs, I think we also have an equally big role in making sure that we build this ground up, these applications, using responsible AI principles of fairness, reliability, safety, privacy, security, inclusivity, and accountability. So we're building the future out of the decisions that we make today using our lines of code. So a quick note on responsible AI. That said, these are a couple of references that I have. And first was the Forrester study that we had discussed in the first couple of slides, the statistics that we presented. And if you're new to Azure Cognitive Services, there is a whole link on Azure Cognitive Services and Azure Cognitive Service for Speech, specifically in Speech Studio. I can share this deck on my LinkedIn account or elsewhere if you'd like to take benefit from this. And with that, thank you. I appreciate the time and attention today. And thank you, Global AI London, for having me. And I'm open to taking questions or your comments. And I think we have a lot of time here.
Thank you. Thank you very much. We don't have any questions in the comments at the moment, but I have a couple myself. First of all, the name dropper tool was really cool. Is that something that people can use?
Not outside the organization at this point. Like I said, this was a quick prototype that we developed, and at this point, we're using it only within the organization.
Cool. My second question is, are there any alternatives to Azure AI for speech that you know of, and sort of why is Azure AI a better option?
Great question. So when we started discussions of cloud AI services, so cloud AI services is what is generally used, is a general term that's used in the industry to bucket any sort of AI services that are hosted in the cloud. And that alludes to services from any of these giants in the ecosystem. That includes Microsoft and AWS and GCP. Azure Cognitive Services, Microsoft's offering in this space. That said, AWS has their own services, and then so do the others as well. I have not had in-depth experience with the others, but I'm given to understand that there are similar capabilities in the other stacks as well. One of the things that stand out to me, and the ones which is why I called out in the deck as well, is the fact that for Microsoft's AI services, the Azure Cognitive Services, the fact that they can take pride in the point that they have used these services at large within their own products. And this is for everyone like you and me to see. What you see is what you get. So you trust it more, and you know that this works, and you are inspired to use this in the applications going forward. That I think is very unique for any of the Azure Cognitive Services, Speech AI included. The fact that they have been using this tried and tested models, and they continue to infuse these services into their own applications, into Word, into PowerPoint, as I said. If you pull up PowerPoint to make a new deck and you see design ideas on the right-hand side, that is powered by AI services. If you take an Excel sheet and you do fill, or you do any of the others, you see insights in an Excel sheet, that is AI service. Outlook, the cluttering, the classification of inbox and clutter. So every single application, it's just that I think the best technology is invisible technology. It is as beautiful as it is invisible. We don't really appreciate it as much because we're not aware that it is really AI. But if you think about it, these are the very AI capabilities that they've used, that is released to us, boxed and bundled and gift wrapped, and in a very consumable fashion. So we just have to call APIs to put these years of research into our application, which I think is a fantastic option for us today.
Thank you. We have a question. So this is from Gavi. She says, there was a fantastic presentation. What other cases that are upcoming or popular other than what you've shown? Use cases?
Yeah, I think one of the most popular use cases is virtual assistants, voice-based virtual assistants, for a couple of reasons. One, people like to go hands-free, and as much as text is an obvious choice, and we started from there, and we see that there is an advanced proliferation of a lot of use cases where people like to be hands-free, and we see that with Alexa and Siri on a daily basis. When we drive a car, you'd like to be able to interact with it using voice, and you use your phone, you'd like to be able to interact with it using voice. So the extension of any application using voice is a solid capability. So I think virtual assistants, making it to voice-based virtual assistants, is a huge area that a lot of organizations and a lot of businesses are exploring, especially with, even when ChatGPT was released, I saw a lot of use cases where people were trying to make it, text is great, but then can you interact with ChatGPT using voice? And they used Azure Speech AI to convert the speech to text, and then use that text to input it into ChatGPT, and the output from ChatGPT converted back from text to speech and comes back to you as a voice. I mean, a very simple example, but you see how the additional layer of sophistication of voice makes any application or any use case a tad bit more impactful than it was previously. So if you want to extend that to any use case anywhere, like in any industry, let's say manufacturing, or let's say you are in a warehouse, and employees in a warehouse, like they've always, their hands are busy, like they've got enough going on already. A hands-free experience is what they would prefer to have. So yeah, I think from customer service to healthcare to warehousing to any particular area, voice is an added advantage. It also brings to the fact of accessibility, inclusion, making sure that you make your apps a little more accessible by the introduction of voice into the picture.
Awesome. Thank you very much. I have another question from Gavi as well. So how does speech AI enable multimodal communication, such as combining speech recognition with other text, like text or CV gesture recognition?
That's a great question. I think we touched the text part slightly, I think. So that really comes out of the box with speech to text and then text to speech. CV and gesture recognition is a good example. I have not really thought a lot about that, and trying to recollect if I've seen any use cases where we've seen a combination of CV or gesture recognition with voice per se. Probably an example, I'm not sure if this is the perfect example, is when you use sign language. So if I could be saying this using voice, the speech to text, instead of converting speech to text, I could still convert that into gestures and convert that into sign language gestures, and then make that an output of the voice to the gesture. So I'm sure there must be, fairly other good examples of that, but I'll get back to you on that, Gavin.
Wow, that's all we've got for questions. So thank you again, Liji. That was really exciting to see. I love the name dropper tool. It's something that I can definitely see myself using.
Awesome. Thank you, Tori.
Thank you very much.
For your questions. Thank you, and have a good rest of your conference. Thank you. Bye-bye.
Thanks, everyone. I will put the schedule up on the screen. We are at 3 o'clock, well, 2:45, which means we have our next session is going to be Getting Insight from Everything Using IoT to Make Decisions by Andrew Blance. We also, and that's from the Johnny 5 room, which is what we're in. We have a Wally track as well. And there we have an introduction to machine learning in Power BI with Leon Gordon there. So I will leave this slide up on the screen for the next 15 minutes and wait for our next speaker to arrive. Hello, everyone. Welcome back to Global AI Bootcamp London. So just a couple of things before we start our next session. A reminder that we're in the Johnny 5 room track, and if you'd like to go to the Wally track, that's also hosted on our YouTube channel, streaming at the moment. Over there, it will be an introduction to machine learning in Power BI with Leon Gordon. Like I said, this is the Johnny 5 track, and we have getting insight from anything using IoT to make decisions with Andrew Blance, who I have here with me now. Let me just add. Hello.
Hello. How are you?
Good, thank you. How are you?
I've been pretty well. I've enjoyed the day. I've seen some pretty good speakers. It's very exciting.
Yeah, there's been some good speakers on at the moment. It's almost 3, so before I let you get started with your session, just a reminder to everyone, if you've got any questions during the session, if you drop them into the comments, I will be able to bring them up on screen at the end of the session for Andrew to answer.
Can't promise I'll be able to answer them, but I'll try my best. I think my bio I sent you said I also like doing the park run and quite like Star Trek, so I could also take questions about Star Trek or park run. Yeah.
Okay. Yeah. So any questions on those topics, please drop them below. So I will leave you to get started then. Is that okay?
Yes.
Oh, yeah. Let's sort the slides out, actually.
Yeah. So does that, can yeah, okay.
Yeah. Got that up.
That from the beginning. So can you see my slides?
Perfect. Yep, I can.
Perfect. Exactly.
All right. Well, I'll let you get started. Thank you very much.
Okay. So getting insight from things is quite difficult. Getting the data you need to make that insight and make decisions is very difficult as well. And sometimes these problems are based on things like the volume of data or the quality you have. And those things can sometimes, you can fix those sometimes. You can gather more data, hopefully, or you can change the questions you're asking in your survey or use ETL pipelines to clean everything up. But sometimes the problem is actually bigger. It's this data just simply doesn't exist. You need to get something else, another whole new process, a whole new piece of hardware to go and gather that data. So that's what this talk is about. This talk is called Getting Insight from Anything. It's a little clickbaity, I know, using IoT to make decisions. And it's about work we've been doing at the place I work called Watersons to do exactly that, get IoT devices to gather data and make decisions based off the back of it. This talk, what I hope you get from it, I'm not looking to teach you the precise lines of code I've written. I want to guide you, hopefully, through choices we've made on hardware selection, on software selections, about the process itself of designing a system to gather data. So I'll introduce hardware and then I'll introduce the actual software stack we're using and diagrams to do with that. So I work at a company called Watersons. We are a tech consultancy firm up here in the northeast of England. We do all sorts of stuff. There is a data team, there is bespoke software, there is a cyber security bit, there is managed services, there's lots and lots of things. I sit within the data team there as a data scientist, and I also do a lot of work on what we call innovation projects. So that is efforts to run projects that are outside of our usual things. Stuff about robot dogs or sensors, and what I'm talking to you about today. Outside of that, and I always plug this whenever I get a chance, I run a really good podcast about really silly business ideas. So you can check that out. It's called Brains on the Outside. Aside from all my data stuff being at work, outside of work, I am the co-host of the Northeast Databricks Meetup Group. We meet once every 2 months in the Catalyst building in Newcastle. Our next speaker is Holly Smith, who works at Databricks, and she's going to talk to us about some really exciting things about scaling Delta tables. So if you're about, you should definitely come and have a listen. We got about 80 people last time, and we got a lot of pizzas, so it's going to be lots of fun. So my talk itself, as I said, we are not precise lines of code. We're going to go over software diagrams and everything like that. This is a journey for us at Watersons, and this sort of IoT device management stuff is new for us, as I imagine it might be for a lot of people in the audience right now, where me and Watersons and you in the audience, we probably do a lot of data analysis and handling, data science work, but the actual hardware stuff's a bit different. So this talk is going to encompass not just all our relative successes, but our missteps along the way. It is really a journey of how we've got to where we are today. So sometimes I'll introduce little concepts that we dropped because it was actually the wrong decision to make at the time, or because we found a better way of doing it later on. But I'll start with some context about why we're doing this at all. Now, when I wrote this slide up and I had it, I kind of thought this is such a data consultant thing to show somebody, this sort of maturity curve. And I've actually seen other ones today. I think Gavi had one on her slide as well. But consultants love doing these. This is a data maturity curve. The idea is that, sorry, it's very strangely, my neighbor has started to learn the bagpipes today. And like 2 hours ago, terrible timing, but I can just hear bagpipe music through the wall. So apologies if you hear that as well. If I get distracted, you'll know what it is. It's the bagpipes. So this, though, is a data maturity curve. It tracks how far a company or a process is like advanced in maturity in data techniques. So on one end, down on nothing, this might be very old company who have no data to work with, or more likely a company that has a lot of data and isn't using it very well. As you get more advanced, you might start doing ad hoc analysis and Excel spreadsheets to get answers you need. These won't be very repeatable. Everyone will be doing something different. There'll be no single source of truth. It'll just be an absolute mess. As you progress, you could work to unifying this and have BI dashboards like Power BI to share among your company, do self-service work where people can do analysis they need, drawing from some single central source of truth. And from there, you do predictive analysis. You could use this great clean data to make actual predictions. So maybe that is how much money am I going to make next year? Or what color car should I start producing? I don't know, all sorts of stuff. And then finally, once this culture of using data and making predictions is in your company, you could actually now automate processes. You could use this data to drive your business making decisions. Now, this is excellent. And everywhere you read, companies talk about how much AI they're using and how great the data is. But the reality is most companies are really, really far down this scale. Most companies are doing ad hoc analysis or have some BI with the vision of using AI in the future. So as a consultancy, whether it's Watersons or Advanced Analytics or hosts, a lot of our work, I imagine, is about making companies progress through this very long and difficult process sometimes of getting more advanced uses of data. And really, you have to have a really good base before you can do AI work, as I'm sure we all know. Actually getting good quality data coming in consistently is difficult, and you need that to make good decisions. However, we can maybe ask, is there very small amounts of time, very, very specific areas we could skip this curve and go from ad hoc analysis right up to decision making? Very targeted approaches, if we understand the risks and understand where we're coming from, or we can skip out little bits, prove value of going on this journey without having to go on the whole journey first. So I'll give you some examples. A factory, for instance. If you work in manufacturing right now, you open manufacturing trade things, or you go to conferences, all you hear is AI, Industry 4.0, the metaverse, all these very, very exciting things that are the future of the industry. But then you go back to your factory and you think, well, I don't have any of that. I don't have an AI control my factory, and I don't have a fancy blockchain saw cutting up all my wood. I have my old saw, and I have very little data processes in place. And you think, well, how could I get there? Because my old saw, it works fine. I can't just get rid of it. And the brand new Bluetooth Wi-Fi 5G saw costs £25 million. I can't just ditch my old saw and get this new one. But it would be really great to get the advantages of this new saw, or new car production plant, or new painting system, or new wood chipper. These things they gather data now, the modern ones, and they allow you to do things like predictive maintenance. So you could replace it before it breaks, or optimizing your factory floor. This is what getting that data means to you practically, but that jump to actually buying a new saw or retrofitting your whole factory is way too expensive. So this is when we came across this concept of shoestring IoT, where instead of having to buy this really high-end new piece of kit costing tens of millions, could we do it something much cheaper, much more targeted? Could we buy already created and production-ready IoT devices, stuff like accelerometers or humidity sensors, and attach those onto machinery? So instead of having to buy a new saw, you buy very targeted IoT things, and hopefully you get some amount of the same benefit. So you could use an accelerometer to measure the vibrations of a saw, and that's a really good indicator of when it's going to break. And that's what set us on this journey of trying to make IoT devices. So here, I put a maturity curve. I love journeys. I love sliding scales and balances and weights and all sorts of things to measure two things against each other. And I have lots of that in the talk. So this is the second one. These factories are things like this. They're stuck between a rock and a hard place. These are my emojis to signify that. So here in this example, the factory want to become more advanced and do Industry 4.0 work. On one hand, you have these market pressures, like increasing production efficiencies, and your customers' expectations of how things are being produced are changing, and they expect you to be working this modern way. However, it's extremely expensive. It's prohibitively expensive. As I said, we're on a journey here, and we pivoted away from this factory stuff to work on what's actually the project we're working on right now, which is social housing. Social housing companies rent housing stock to people for them to live in. They have a huge problem, and you've probably seen it in the news, about black mold growth in houses. It's really, really, well, it's really bad. It's led to a lot of tragedies recently in the UK and probably throughout the world. They need a method of cutting this down. They're facing extreme regulatory pressure that's going to come up. They're facing market pressure because people don't want to go in these houses if they're going to go moldy and they're going to get actually ill. And also, social housing works slightly different to regular renting, where a social housing landlord also has a moral and ethical obligation over their tenants. They have a duty of care to look after them. So there's a lot of interest in that sector of making a method of understanding if anywhere in the house is moldy, and then being able to automatically control the heating. And that controlled heating, the social housing companies would then pay for. So there's a few things in there, some subtleties. That means there's no real off the shelf product right now for them. That's fantastic though. But on the other side, they're stuck in this rock and hard place situation where it's too expensive just to really invest a lot of money in. So they need a low cost way of doing this. So my next maturity curve is on IoT devices. We have this problem. Can we detect and automatically stop black mold from happening in social housing companies? We have now a new maturity curve in front of us. It's not perfect, but I think it does kind of serve a point. An IoT device maturity curve. On one end, we have devices that a lot of us are used to and probably have actually worked with in the past. So stuff like Arduinos, very small, low cost, low energy computing. And as we move up, we get to edge computing devices. This is an AdLink neon camera in the middle. An AdLink neon camera is effectively a really, really high resolution camera with a GPU sellotaped to the side of it. It allows you to do AI insight and running computer vision models without the need to connect to the internet. So this is extremely useful in places where there's poor signal, or you don't actually want to have to transfer 4K or any resolution image consistently up to Azure and have those large cloud costs. Then right on the other end, further, there is this dog. This is Spot. Spot is a puppy made by Boston Dynamics. It is an edge computing device, I believe, but that's probably underselling it. It walks around, has LiDAR sensors, can do all this fancy stuff. So at Waterston's, my work at Waterston's involves running projects with this sort of tech, trying to get robot dogs or edge computing cameras or IoT. So now we have somewhere in here is a hardware solution for us to our problem. And choosing one is now this new balance. It's about the core of running an innovative and risky project, something that's brand new for us and for our clients, and just actually quite novel, a new product. So on one hand, you have an appetite for risk. How risky are you willing to get? And that also maybe depends on the project itself. This is a big problem they face, and they're pretty willing to take bigger steps than normal to fix it. On the other hand, is the riskiness of the project itself, like proving this concept of can we develop a sensor, is risky. So we need to look at ways of de-riskifying this. And this is our project about de-risking development of low-cost, non-intrusive sensor systems to help the social housing sector reduce the risk of black mold in their houses. And this will use a combination of Azure software stack and some hardware that we'll have to develop. Now, Waterston's do lots of things, but we were a software company primarily. We don't typically produce hardware. So this was a journey for us as well. I spent weeks with a soldering iron in the office trying to connect and make Arduinos and Raspberry Pis work. On one hand, they're so simple. They're really easy to use. And on another hand, as with many things, once you get into the weeds, into the minutiae of it, it becomes extremely complicated. So we worked for a while with Arduinos and breadboards to make a system where you'd have a 3G SIM card on it that could send data to Azure, and sensors like this one on the right. I think that's a humidity sensor. Now that worked kind of. It's actually really hard to make a secure connection to Azure on an Arduino, and you'll go read the docs and they'll promise you it's possible, but I'm telling you from experience, it's actually super hard. It's actually super hard. So we eventually got something working, and what it's showed us, what it made us realize, is the huge gap between a dev device like an Arduino and on the other end, a production-ready device, a device you would actually put in somebody's house. Because once you've strapped an Arduino to a breadboard and a bunch of wires coming out of it, it looks like you've made some kind of improvised explosive, and it's not a good look. No one's going to want it in their house. So there's an element of trying to professionalize this, trying to productionize this. And we quickly realized, like, on this journey from going from what we had as a proof of concept to production would be way too enormous for us to handle. Our actual solution came from here. This is an artistic impression of the Institute of Safe Autonomy in New York. We are currently applying for funding to make hardware and run this project properly. So Institute of Safe Autonomy would handle the hardware stack, and we'd handle the software stack. We're currently in these Innovate UK funding rounds to try and make this off the ground. But that is still a work in progress. So I'll talk about this, which is something we currently have a whole bunch of in our office and which our proof of concepts are being built on. These are Monet sensors. These are devices that can gather data effectively. The gateway in the middle, the little box in the middle, has a 3G SIM card in it, so it can connect to Azure and send data from it. That gateway then wirelessly connects to other sensors that are nearby it. So you might have a wireless humidity sensor with a battery in it, which wirelessly connects to this gateway, which then connects to Azure with the 3G SIM card. So this is great for a lot of reasons. It's not the hardware solution we'll settle on. The Institute of Safe Autonomy will work with that. But for our use cases in the office, it's pretty good. So these little sensors, the humidity sensor and the CO2 sensor, they have a lifespan of years. They can last ages without being to be charged. And that's extremely good because you can imagine you don't want, if it was in your house, this device, you wouldn't want someone having to come in the whole time and change batteries. It'd be extremely disruptive. Also, it's extremely expensive to send a person out to somebody's house. All cost saving, if you were interested in that, for doing a lot of the automation tasks that sensors can do are completely annihilated as soon as a person has a command change the batteries. So this is a medium cost way of gathering data over the long term. So we have a bunch of these. So this is the hardware we're going to choose for our prototype. Now, as I said, in the future going forward, Institute of Safe Autonomy is going to handle the hardware. And right now we have this Monet devices sitting in our office for us to use as we investigate the software stack. As I said, we have a data team and a bespoke software team at Waterstones. So this is kind of something that we can try our hand at. Though, as I said, we're on a journey. Making IoT streaming platforms isn't something that we've done before. So we initially came up with two choices, to either go purely in the Azure stack or use Databricks. Now, that's not exactly a perfect choice because there's a crossover here, but I'll explain exactly what I mean now. So I'll first introduce you to Databricks. Databricks is a big data analytics cloud platform. You can do engineering, science, analytics, ETL, lots of stuff in it. It's extremely powerful and is meant for like exabyte scale problems. We use this a lot at Waterstones. This is our main tool now. This graphic is borrowed from the Databricks website. They classify it as a simple tool. So this means you can use basically any language you want. If you're an R developer or a SQL developer or a Python developer, you can all share this same piece of tech. It's open. Databricks really prides themselves on using open source software and open sourcing the developments they make to the engines and coding languages and frameworks that they use. It's also cloud-based. It's, as I said at the top, you interact with it mainly through your browser. It's also extremely scalable, whether you want a tiny little system for just some playing around with, or an enormous cluster of GPUs, it can scale to meet your requirements. Databricks can sit inside Azure. It can also sit inside AWS, which is why I kind of mentioned that it's not a perfect comparison between the two. But what interested us about Databricks is a feature they have called Delta Live Tables. Delta Live Tables is Databricks' way of handling streaming data, whether that's in batch or just continuously coming in. Now, in this diagram, in the system diagram I've drawn, I have IoT Hub and Power BI. For all you need to know for now is IoT Hub is a device management platform for IoT devices Azure runs, and Power BI is, as I'm sure we're all aware, Microsoft's BI solution. Delta Live here is here for processing the data. Delta Live tables are really fantastic in a lot of ways. You can write a Jupyter Notebook style script in SQL or Python telling you what you're going to do with the data and how you're going to analyze it. You then just point it at a storage source that the streaming data will be landed in. So the data lands in this storage solution. The Delta Live table and all the notebooks are pointed at it, and it'll just analyze data as it comes in, and then you can just drop it out into some sort of BI solution you want. So it's really good. It's quite intuitive. You can write it in Python as you normally would. It's really fantastic for, again, scaling up or down, and it's really great at handling batch or continuous. If it's your cluster running Databricks is on the whole time, it'll be continuously analyzing that data and it'll be in real time. If you turn your VM off, then it doesn't obviously analyze it in real time, but it'll save the data that's messed up and then analyze it in as a batch when you turn the cluster back on. I've been mentioning clusters a lot, and that should give you a clue to maybe why we didn't choose this method. Having a cluster run 24 hours a day was quite expensive for our prototypes. It's also, we are more used to other parts of the Azure stack. So we decided to reassess and build something that looks like this. This is our current attempt at making a streaming platform, a streaming solution. So we have it sort of split into three parts. On one, we have our streaming data input, we have our generic event handling, and then we have our actual BI method of viewing this data. So this was kind of designed in collaboration with data and our software team, where we kind of both initially started with different looking diagrams, and we met somewhere in the middle, actually, where they brought a bit of our insight and they brought a bit of what they thought was good system design. So kind of philosophy here was that if you're at the pointy end, the actual Power BI, you shouldn't have to care about the device management section of it. So we have this sort of buffer zone, this generic event handling zone that data gets passed through. So devs who are interacting with it don't have to go all the way down to device level, especially if we're getting other data sources in, if we're calling APIs for weather or just other business data that might be around the organization, mixing that all in. We want to have one place it can all live. So I'm going to walk through this now for the most of the rest of the talk. IoT Hub is Azure's device management platform for IoT devices. Microsoft have a very literal way of naming things, which makes it useful. It's way better than Amazon, which calls things like SageMaker, which is a great name, but it's not super literal with what it does. IoT Hub is a hub for IoT devices. I'm trying to avoid getting super technical. I'm trying to avoid showing you a bunch of code and instead giving you an overview of the platform and our thoughts about why we've chosen the things we have. So I'll give introductions to things and I can talk about the exact code we use offline later on. If people are interested, you can message me. So IoT Hub is where you would register a device. So we have these monitored humidity sensors gathering data in our office. They then get passed to the hub, which sends it up to Azure. The device and the data will land here in IoT Hub. We see on the left-hand side of the screen, there's a device management section. So under devices, there's actually all the devices that are registered here. So we have the ability to go in and change firmware and settings from there. In IoT Edge, we have a place to save the edge computing camera and the dog that I showed you earlier. Here, I can actually embed entire new operating systems, like entire new versions of Linux on the things. And further down, we see this thing, hub settings. You see message routing and built-in endpoints, which hints at the important thing here, which is that IoT Hub handles a lot of different styles of data. Device data coming in doesn't just have to be humidity levels. It could be actual health of the device, safety warnings, all sorts of like background information about the device itself that isn't the data loading together. So IoT Hub can ingest all this data and send it somewhere else. It can route it somewhere else. The final thing I'll point out with IoT Hub is this daily message quota of almost 500,000. Microsoft costing is sometimes extremely generous and sometimes it's extremely opaque, but this is one time where it's pretty open and pretty generous, where you get 500,000, basically you get 400,000 free messages a day. So that's quite a lot of updates from your sensor. After that, I think you're paying the big bucks. So data lands here. Devices are registered here. Data lands here. Now we need to bring about a process to actually show it to the end user. First, though, there's a lot of cleaning up that has to happen. You know, our diagram will diverge quite a lot from diagrams that Microsoft present, because sometimes when you're, when you're reading through documentation, sometimes it's for best case scenarios. It's for test data. It's not for data you see out there, crunchy, scary data you see in the real world. It's never the data you gather is never going to instantly fit through pandas. It's never instantly going to go through TensorFlow. You're going to have to spend hours massaging it into something that does work. So much of this is engineering and ETL pipeline stuff. So our solution differs a lot from Microsoft's proposed solutions simply because the data we have is that scary real world good stuff data, not perfect data. So the function is here to clean it up. A function is serverless. I'm going to get this right. I think it's serverless compute. So This is, you write some code. I write mine in Python. You write a function, and it will just run. You don't have to do any infrastructure work. It'll run serverlessly. And again, sort of firm this up a bit. The code is here not to give a play-by-play of what I did, but just to give you some understanding of what I mean and the capabilities of a function. So here at line 8, I ran a Python function that inputs something called an input stream. And I'll play that in a second. The idea is I can write my normal Python function that I want to apply to the data that's coming in. So in from IoT Hub comes one humidity event. And that might include stuff like date, time, humidity, percentages, temperatures, all sorts of stuff. And I'll take that and I'll do some transformations to it. The input stream is a reference to the fact that the function is sitting watching something. It's sitting and currently watching a storage solution. So when data drops in there, this will trigger this function and begin this cleaning up process. You can also make it watch IoT Hub. So when something drops in the IoT Hub, it'll trigger this function. And that's a really great thing about staying really deep within the Azure stack, because everything clips together really nicely like this. When I said that our data was real world messy data, what I meant was it's quite interesting because these devices can disconnect from the internet. You know, the cell tower might drop out and you might not have 3G signal for an hour. You might need to replace a battery, or maybe some security key time elapses and you get a new one and it can't connect to Azure for a while. In that time, it's going to start gathering more and more data up in the device and saving it. And instead of passing one nice clean string or a list, it's going to pass up some really horrible nested JSON dictionary within a list, within a dictionary, within a tuple, really nested in a horrible way. So this function basically unpicks that actually. It's just safeguarding us against, is it one event or is it 40 events all bunched up, and it's picking it apart. And that's when they get passed to Event Hub. Event Hub, I don't have much to say about it here, but Event Hub is effectively IoT Hub without device management. So it's meant to handle live data coming in. So this could either be stuff from IoT Hub, or it could be API results. You could be pulling APIs a lot. And we wanted everything in here eventually, because yeah, it's great knowing the humidity of the house, but eventually you're going to want to mix this with other business data. Who lives there? How long have they been there? How many houses are on this estate? What's the weather like? Is there a main road near it? I don't know. It could be anything. You're going to want to mix it all and have one central place to store it, or have everything passing through. So now that we have all this data coming through one place and cleaned up, we can begin trying to get some kind of insight from it. So here we're going to use another hyperliterally named product, Streaming Analytics. Streaming Analytics is exactly what it says in the tin. It is Azure's streaming analytic platform. Here it takes in data that's streaming in, time series data of some kind. I can perform, I don't want to say basic, but standard time series analytics on it. So in our case, we're looking for averages of humidity. You could think about how many times the door opened, or just in this given window, like time window, how much stuff has happened. So this line of code here, again, I won't go into exactly the minutia, but the idea is this code is passing a window over all the data that's coming in and averaging it out, understanding what's happening in this time window. Now, Streaming Analytics uses a modified version of SQL. So here it looks very SQL-esque, but there's certain things here that isn't part of SQL, like hopping window. That's not a SQL thing. You wouldn't find that in SQL. Interestingly as well, you can augment this language writing JavaScript functions. So there's this tab here that says functions 2, and you see datetime to int and list split. These are functions we've actually written, which now can be called like you were writing SQL, like hopping window there. What's, again, really nice about this is that I can just plug in to other resources inside Azure. It's automatically aware, if you're inside the same resource group, what else exists there. So we see here we have 2 inputs, blob input. This is watching a blob, or that has the potential to watch a storage solution and understand when someone drops in, you can begin the streaming analytics job on it. Another one we have is Scissors Temperature. Scissors is the name of a meeting room in our Durham office. That sign next to it is an IoT hub instance. So I can actually just point this at IoT hub and perform analysis directly on top of it. So this is exactly where we differ from current solutions Microsoft propose, where our data is nested in a weird way. It requires quite a lot of analysis on it, actually, and cleaning it up to make it usable. Streaming analytics, the language just isn't written in such a way, or I refrain from saying powerful enough, but it doesn't, we can't do what we need to the data with one streaming analytics instance. We went on a big search to figure out how could we just use streaming analytics. Let's avoid event hubs and functions. And the best solution we found, like any good programmer, you go to the oracle of all programming knowledge, which is Stack Overflow, and you write a really good question, and 4 people insult you, and then finally you get one really good answer. And that answer was, what you're going to have to do is do half the analysis on one streaming analytics job, dump that data into storage, start up a whole new streaming analytics resource, boot that up to do the second half of your analytics. And we decided that wasn't very feasible, as streaming analytics is significantly more expensive than using a function. So it just wasn't really fit for what we wanted to do. So that's why we have functions. It's like a cost-saving procedure. Now, what have we done so far? We have got data into IoT Hub. We have cleaned it up using an Azure function. We've got into Event Hub where it can be joined together with other event data styles or API calling things. It's gone through streaming analytics, and now we know what is the average humidity in this house over the last hour. And finally, we can view it in Power BI. So I don't have an exact live dashboard to show you, but I will briefly talk to you about what I found quite interesting in Power BI. I'm not a Power BI developer. I know very few Power BI related facts. The one thing I always say, I say the whole time in every talk, my one interesting Power BI fact, Power BI is a model-based BI tool, as opposed to being a visualization-based BI tool. Johnny Winter, who's a very good YouTube channel, said that once, and I parrot it the whole time. I think what it means, though, is that it's really good at making relations between data and really being able to make these really great plots because it understands how data is linked together. A lot of the process is about modeling data rather than visualizing it. And you get the nice visualizations because you've made that nice model up front, further upstream. Power BI, to my... Power BI typically is always Power BI desktop or things that are built in that. Viewing historical data, which you've had to model to make it like that. So this might be sales. It might be, here we have a lot of sales information. We have key influencers. These plots as well are quite advanced. There's lots going on in them, lots of splitting and crunching in different ways to make it that. So this is usually how we see board reports or things like that. This is how usually you get insight from things. However, there's another option, which is Power BI dashboards, which are online based. These are designed to handle live data coming in. So this is for streaming data, basically. And the two are slightly separate from each other. So we see here, right off the top, that actually the Power BI dashboard is much more simple looking. We're not really handling these more complex plots. We don't have this key influencer plot or this unit by country or sales size plot. The general trends, and they're just single integers or floats, so temperatures or radiation levels. This isn't my dashboard. I'm not looking at radiation levels or anything. But here we're able to pipe the output of streaming analytics into a Power BI live data set, and that can be read by our Power BI dashboard. So you could have something that was, hey, this is this level of humidity. And that is kind of our structure of doing this. This is our plan to bring it all together. So we've built things like this to take data from IoT Hub, save it somewhere, use a function to clean it up, combine it with other data sources, either from the business or from outside. So yeah, weather is the obvious one. mixed it together in an event hub to have a generic home for this data, so that people don't need to go further downstream to get it. We can then use this in streaming analytics to understand, hey, what is the trends in this data I've been gathering, and show that up in a Power BI dashboard. And because we've been saving all this data, we also have this other option for using historical data sets in Power BI and joining that in with other data sets the business might have to show interesting information. I've not talked very much about the AI machine learning part, partly because this is an ongoing process. We're on a journey. We don't have things live currently in social housing. So that's a future part, but we have two options for that when that day shows up. Option one, again, literary title, time series analysis. Everyone probably could guess what this does. Time series analysis is a platform to do time series analysis. Almost all I need to say. You point it at a data set, a live data set, or directly into IoT Hub, and it will perform regular analysis techniques on top of that. I haven't had much experience using it, but I'm prepared to have to write a lot of Azure functions to clean up my data before it hits time series analysis. But I think this is a really good example of something we've seen a lot of today, which is Microsoft putting in a huge amount of effort to simplify and make using machine learning models way, way simpler. It was Patty's talk earlier that talked about 5 years ago, it's hard to imagine how easy it would be to run computer vision projects. How much work Microsoft doing custom vision to make this super simple. And the same here as time series analysis. Years ago, 3, 4, 5 years ago, running these, especially computer vision, was a very code intensive process. And now it's all being simplified. So I'm excited to try this out more. Historical data and decisions and more in-depth machine learning stuff can be done within Azure Machine Learning. This is what we use alongside Databricks at Waterstones as our primary way to run machine learning and analytics projects. Azure Machine Learning is a platform to run your machine learning project. You can write Python code in notebooks or use Visual Studio Code. You can assign and use VMs and compute that you get from there. So you can use cloud-based resources. You can track model versioning and also data versioning. So you can really have a really good grip on what exactly the state of your model was in every single day during training. You can track experiments and do all the sort of ML ops style processes you want from within this tool. It's also really good for auto ML stuff, so low code, no code solutions. It's a bit of everything. So once we have this historical data set, we'll be using this to make different styles of analysis on top of it. So that's it. That's what we've done. We have found this problem, which is black mold prevention in social housing, and we have tried to team up with research institutes to make hardware as we develop a software stack to hopefully really help them out. So that's all I have time for today. If you can contact me on Twitter, someone has to go down with the ship. It's a terrible app, but I still have it. And that's me for today. Thank you.
Thank you. Thank you very much. We have tons of comments, questions. Can I?
Exciting, I think. Hopefully they're all nice. Are they about
That's good news.
Are they about Star Trek?
Yeah. So I got the first one from Gavi. Love the presentation, especially maturity curve. Just wondered if you have been able to use, if you would have been able to use IoT Central instead of IoT Hub.
That's a great question. The maturity curve, yeah, I knew if there was another consultant here, they'd show one. We love showing them. So I'll be honest with you. I've not heard of IoT Central. Is this an Azure product? I know that, as with lots of things in Azure, the rapid iteration and name changes, so they could be quite similar actually. IoT Hub just seems to be the default choice for IoT device management on Azure. There used to be other programs as well. I believe there was one called like Edge, something like that, but they've all now been folded into IoT Hub. If IoT Central is a device management platform that can message data, then yeah, definitely you could reuse that. We thought a lot about our software. Some people in software were determined to run our own MQTT server stuff, which was quickly, I decided let's just stick with an IoT hub. But yeah, there's plenty of options. I'm actually, to be honest, I'm not quite familiar with IoT Central.
Awesome. I have one from Alex B. Great presentation so far. How does IoT data differ from other more traditional types of data, and what challenges does this present?
So I guess typically I would say it depends the resolution that you want to report on, right? Lots of people say they want live data, and in the end, they don't really want live data. But having this live streaming data coming in 24/7 potentially does present its own challenge of how are you going to analyze that if you're reporting in real time as well. So this is where lots of tools like functions which are triggered by the actual dropping into storage or IoT hub, that's very useful. So like streaming analytics, which is designed from the ground up to handle this sort of data, takes a lot of heavy lifting away. And again, Azure is great for clipping things together. So I guess it's a different style of problem from having this non-live data, which might sit and you do analysis on it once a day or something, triggered by some ADF process. But it's definitely that having it coming in real time, I know what to do with it quickly. It's a challenge.
Yeah. We have Terry here setting you up for what I think might be a plug.
Oh, Terry. Great. Are there any good user groups? Terry, it's almost as if you knew there's a fantastic user group in Newcastle, folks, Databricks. Oh my God! If you're in the Northeast in next month, April 20th, we have a great speaker, Holly Smith. In 2 months after that, in June, I believe, though it's not being announced, that Gavi and Luke will be there as well to give a talk. So lots of exciting things happening.
Great. One final one from Gavi herself. So with the example RE measuring mold, how would you go about managing data governance and compliance? Is it relevant, thinking about the FSI, where that will be important factors to consider?
Yeah, so this is actually, there's a lot to this, really. So measuring mold is, now we get into is humidity a proxy for a person being in the room, which makes it much more difficult. That's personal information. Data, the way things are shaping up, I think, is that if there is regulation, it will be to clamp down on mold, and there'll have to be initiatives to stop that. So there's this thing here of there is a push to do projects like this. Institute of Safe Autonomy, who are in the hardware space, is right in their name, safe autonomy. They have lots of researchers interested in actually this exact question. What does it mean to put hardware in somebody's home? How could they react to that? This is also a big push for the residents in social housing. They're bought into projects like this. So this is definitely something that's being considered a lot. Because I know myself, like if someone came to me with a strange little box, I would be pretty apprehensive. So this is definitely something we're considering.
Great. That is our last question on the YouTube comments. So yeah, thank you again, Andrew. That was really interesting.
Thank you for having me.
Our pleasure. Cool. Am I all right to drop you now? It feels really rude.
Right.
Thank you again. Bye. And cool. So our schedule again, we have one final main session coming up at 4 o'clock. So on this stream in Johnny 5, it will be explaining Oracle's techniques to communicate machine learning model results with Pau Sempere. But over on the Wally stream, we have building intelligent enterprise-grade help desk bots using conversational AI with Prashant Boyer. So if you want to move over to the Wally stream, that's also being hosted on the same YouTube channel, so you can just jump over when you can. So we will be back in about 15 minutes with our next speaker. Hello everyone again to our final session of the Global AI Bootcamp on the Johnny 5 track. So before I introduce our next speaker, just some reminders. So we are on the Johnny 5 track. We have 2 tracks going on at the moment. So on the Wally track, we have a session called Building Intelligent Enterprise-Grade Help Desk Bots Using Conversational AI with Prashant Boyer. So if you'd like to join that session, feel free to skip tracks. So the Wally track will also be hosted on the same YouTube channel that we're posting this one on. And our session, so our final session, is explaining Oracle's techniques to communicate machine learning model results with Pau Sempere. And I have him here with me. Hello.
Hello, Tori. How are you doing?
Oh, good, thank you. How are you doing?
Doing fine. Actually, here I am representing Global AI Bootcamp. Can you see this? They gave me this nice shirt here. I am at the Madrid chapter, so I just delivered the session here, as I mentioned to you. So, yeah, I'm ready to share everything with the London chapter. It's a pleasure to be here. Global AI Bootcamp has been an amazing event all these years. So, 1 year more here is always a pleasure and a humbling experience because the level of the sessions is always astonishing. So, yeah, great to be here.
Yeah. What session did you present in Madrid?
I did. Well, it's called the Machine Learning Plumbers, and it's just a joke because it was about data pipelines. So yeah, pipelines, plumbers, all revolves around the same thing, and about the importance of treating and creating pipelines. So we feed our models with not just correct data, but you can reuse these pipelines, you can deploy them, you can share them, so you reduce the rate of error because copy and pasting is always prone to errors, especially if you work in a big team. So the bigger the team, the more tendent you are to commit these errors. So how to create good practices in your teams and using scikit-learn pipelines, and giving some other examples using a bit of ChatGPT because that's what you do nowadays in AI. So yeah, a bit of everything. So yeah, it's been recorded in Spanish. So at some point they will release it in Spanish for those who speak or who are curious enough to hear me blabbering gibberish in Spanish. They'll have material to watch me. So yeah, it's been a fun one.
Great. Yeah, that sounds really good. Great. So we've got about 2 minutes before the start of your session. So it might be worth checking to see if your slides can load. I just removed mine.
Let me share my screen.
Great. And for all our viewers, if you have any questions during the session, please post them on in the YouTube comments. At the end of the session, there'll be a bit of a Q&A, and you'll get your chance to ask questions to Pau and have them on the screen. So please use YouTube comments. There we go.
Okay, can you see them correctly, right?
Yep, I can see.
Sure.
Our first comment, Terry says that quality shirts.
Sorry, quality what? I lost you.
Quality shirt, like your shirt.
Oh yeah, it is. It is a quality shirt. Yes, they've been asking us about the sizes a lot because we tend to say, "Oh no, I'm a large one," and then you're not. You're an X large. Yeah, they've been bothering us about that a lot. But yeah, it's a very cool one. I'm wearing it with pride. So yeah, it is a very good one.
Awesome. So it is 4 o'clock. So I will give you the floor. Thank you very much.
Thank you, Tori. Okay, so welcome everyone to this last session of the Global AI Bootcamp. It's a pleasure to be here. My name is Pau Sempere. I'm the head of AI at iPerformance. We are a fintech company. We create financial solutions based on machine learning models and data analysis. And I am also a Microsoft AI MVP. It's been 3 years in a row already. My friends at Microsoft think that I well deserve this. So who am I to disagree with them? And today, we are going to talk about how to communicate the results of our machine learning models, because we are used, myself in this case, and many of us who work in this industry, in the technical side, we are very used to talk about metrics and about models and about algorithms and about data processing techniques and about platforms, architectures, lots of stuff that are not that interesting to anyone else than us. So in this session, we are trying to review a few techniques that have helped me in the past in the projects. I worked at a consultancy company previously before joining iPerformance. So I had many clients, and now I have clients as well, inner clients and other, let's say, foreign clients or customers who are buying our services and products. And it's very cool that you use machine learning. It's very cool that you use AI, but you have to make machine learning understandable. You have to explain exactly, or not exactly, but at least approximately what you mean with a result of a machine learning model, and make people understand how they can use that to create something useful and something valuable for their day-to-day business. So we are going around a few techniques. There are many more. I mean, too many to even count them, or not to say to make them fit in this 50 minutes that we have together. So let's roll, and let's try to cover a few of them. And of course, as Tori mentioned, use the YouTube comments to ask anything, and we'll try to answer or to comment any point of view that you have at the end of the session, right? So first things first, we are going to talk about how to prepare the floor, the soil, let's say, to plant the right seeds to make our projects grow and grow healthy. How to establish the a good foundation, so we are in line with our customers. So when we communicate the results, we are sure that these results are being heard and are being understood, right? And that starts from the very beginning, even before we are writing the first line of code, or we are building and getting this first row of data from our database or our CSV file or whatever. That begins even before that. Then we're going to talk about how to communicate results, and then we're going to talk about explaining the why. So interpreting the model, why the model is saying that, why the model is saying a particular prediction is predicting a particular value or a particular class. If we are talking about a classifier, we are going to talk about how important is that, and how to try to and how to, let's say, rephrase the classical tools that we machine learning practitioners have in our day-to-day basis, right? So let's start with the right seeds, right? So as I said, a big part of what defines the end user communication at the very end, I mean, at the very end of the machine learning output, let's say, the predictions themselves, or the predictions, or the product that uses these predictions, because, you know, machine learning models are meant to be used. So if they are not used, they are useless, and they are probably going to be discarded, and the project will fail, and probably you'll get kicked out of your company, and it's a disaster. So you want your model to be used. And even before the project starts, we have to think about what makes our project viable. And I know it's going to be just 3 points. You can say that there are many factors that are involved in this. It's true, but we're going to cover a few of them. Right. So first, data. Do we have data? Do we have the right amount of data, the right kind of data? Is the data accessible? Can we use that data? Because we don't have. Do we have privacy problems? Do we have, let's say, GDPR problems? Do we have privacy issues with the company that is providing the data, and so on? Right. So all that has to be taken into account before we even think about starting the project. One of the experiences that I had, I mentioned that I did consultancy for a long time. One of the projects that I was involved in was at a book editing company, and I just on the coffee machine, I just made a commentary about how Netflix created House of Cards. So I talked with them about Netflix analyzing data from their viewers, from their habits, and trying to create the perfect TV show. So they analyzed that people liked TV shows where Kevin Spacey was in, and then political drama in the United States, and then they liked when certain plots happened, and because these TV shows were viewed more than the others. And something that was very particular of that example was that they realized that people binge watched the TV show, so they waited till every single episode was online, and then they just crushed them, watching 7, 8, 9, well, maybe 9 episodes is too much, but you know what I mean, right? So 3, 4 episodes in a row, and then just gulping them like if it was water, because they wanted to continue the plot and the problems and the resolutions of the plot. They wanted them to be consumed together, right? So that's what made Netflix publish the first season of House of Cards all together at the same time, and it was a big success. First of all, because the TV show is very good, but then because what they learned from the data analysis. So I was explaining this to this customer, and they told me, okay, so that's very interesting, but can we create the perfect book? Because it is a product that is compounded of many things. Who's writing the book? What's the topic of the book? What kind of materials are we using to build that book? What kind of paper? What kind of covers? The length of the book? How many words? What kind of words? All that, right? And I said, well, yeah, you might do that, but do you have any sort of let's say survey about what your customers think about your products? Do you have any information about what parts, any analytics of what parts of your books are made these books really successful or not really successful? And they told me, nope, that's not what we have. We have other kinds of data, but not that kind of data. And not just not that kind of data, but they didn't have any kind of data around that. So we couldn't even infer or translate from one type of data to something that could lead us to that project. So at the very beginning, even before we even considered starting that project, we said, no, we cannot, we should not start this project, because if we start something that is not well-founded with data, with the right amount and the right kind of data, then we are doomed. Then we are heading to disaster. So we didn't start the project. We did some other projects that were very successful because we had not as ambitious, let's say, but we had data and we added value to the business process. So that was much better, right? So first of all, data. Do we have the data? If we don't, then rethink about your idea. Then, which stakeholders do I have? Who is responsible for this? Who am I going to communicate, right? So, because it's not the same thing to create a model that we will be sharing with the IT department. Let's say predictive maintenance for their servers. Let's say. That's one kind of project, and we can speak one language, and we think I'm going to be repeating that a lot about the language we use. That if we think of other project, like let's say a financial forecasting project, our stakeholders will be the treasury department or the financial department or the CFO or all these people who are in charge of finance. So these guys speak a completely different language than the IT guys, right? So we have to think about this to start thinking about the usage that these people are going to make of the models, and what kind of communication can we establish from the very beginning, what kind of communication we are going to have to with them. And then something that I like to call a project contract. This is not the contract that you sign to be paid at the end of the project, but rather it's something as easy to put in the table, but very hard to answer, which is, when are we done with the project? So you need a model, right? You need a model that fulfills this business purpose, or that solves this business problem, or that automates this task, or whatever. But how good is good enough? Because a model can be iterated forever, because no model is perfect. So we could be going over and over again from feature engineering to model assembling to model architecture to, I don't know, data acquisition, model results presentation, simulations, validations, backtesting, whatever the case would be for your business needs, right? So we need to establish from the right beginning how good is good enough, because otherwise, imagine that your project is it's valued at, I don't know, let's put a number, let's 100K pounds, right? And that's for 6 months, 3 months, whatever, a year, depends on the case. What if we are at the 3-month mark, if we are to be done at that time, and they don't want to pay us because the model is not good enough, right? If we have that clear from the very beginning, then we can say, okay, when we achieve this performance, or that performance could be a statistical metric, or it could be a business metric, right? It should be a business metric, in fact. But anyway, it could be it should be a metric, or a combination of them. Then we are done, because that would cause probably many problems when we are trying to be paid, basically, right? To say that we are done with the project. So when everyone has clear expectations of what can we expect from this model, and what kind of business solution can we expect from this model, your life will be way easier, right? So these three very wide, very abstract points, but all these cover a very important part of what it's really important to define from the very beginning. So questions that need to be answered: what is our business problem? A deep understanding of the business problem. What are we solving? Who is going to use the results? As I mentioned, who are my stakeholders? Who are my interlocutors? Then how often do we need the results? That's important, because that affects the technical design. How many times can we retrain every month, or every day, or every year? What's the amount of data we have? What's the infrastructure we have? Can we afford to retrain every day with the amount of data and the infrastructure we have, or we can afford? Do we have on-prem compute? Do we have cloud compute? What's the scenario? Again, the contract. How good is good enough? And then with this, how good is good enough, as I mentioned, we can start, and we should start, translating from technical metrics to business metrics, because then we are talking their language. We need to talk the business language, because our stakeholders can vary, as I mentioned. If we are talking to IT, like represented with this technical brain here, we can talk about accuracy, MAA, RMCE, F1 score, R squared, or R squared adjusted, or MAPE, any other metric that you want. But let's be honest, almost no one cares in the spectrum, in the range of the amount of the people that we can interact with in a business scenario. Nobody cares about F1 score or R squared. We do. We data scientists do, but the kings the kings and queens of these, who are the stakeholders, are going to talk about return of investment, cost, benefit, rotation, failure rate, SLA, or any other business metric that you want, right? They talk they speak that language. We speak the other language. We need to be sure that we create messages and narratives, and we create storytelling, and we communicate results for everyone in the middle, from the most technical on your left to your most businessy users at your right? So we need to create messages for everyone, for all of them, because we will need all of them to create a successful project. Okay, so when we communicate results in the process, we should be asking ourselves when we have everything defined, as I mentioned, that when we have the right sales in place, then in the meantime, when we are communicating the results, we should focus on answering this first and very wide, very broad question: are we solving the problem, or are we not? And moreover, are we solving the problem better than we used to? Because some projects, they are not, that contract that I mentioned, they are not, let's say, aimed or focused on solving the problem in the best possible way. They are focused in, let's say, solving the problem, but just better than we used to do, and maybe faster than we used to do, or in an automated fashion. With that could be one of the metrics that we use to create that project contract, and that's good enough, right? Because we cannot achieve perfect. No model is perfect. We'll talk about that in a while, right? So having all these questions answered is extremely important. Okay, so once we have all these in place, and once we have ensured we are sure that all these things are set, then let's see a few examples of how to communicate results, right? But let's be a bit technical now. We've been very businessy. Now let's be a bit technical. So imagine that we have a churn case, which is a very classical case, and we are predicting which users will leave our subscription. Let's imagine that we are a telco, or we are Netflix, or Amazon, or one of these big companies or small companies who have a subscription business model. And then when we are communicating the benefits or the cost, or when we are thinking of business, we have and how business is going to be impacted in a good way by our models, because that's the key to communicate to business. We have to think about not just what the model really solves or directly solves, let's say, but the benefits that are derived, that come together with the solution. So in our case, the generation of targeted retention campaigns. So it's not just that we say that our customers are going to leave or not in a time range, in a time horizon, but what creates that is the chance for our marketing teams or our customer retention teams, or whoever the case, whoever is in charge in this case, we are giving them the chance to create targeted retention campaigns, and that hopefully will lead to an improved customer retention rate. And not just that, but the cheaper, a cheaper cost, or a better balance between balance and benefit and cost, because since our marketing campaigns are targeted, they are laser focused on the customers that they should be. We are not just spamming customers with retention campaigns, but rather going very specific. We're being very specific about who we are asking to stay in our company, with messages, with discounts, with whatever is our technique there, right? But here again, think about that. Think about how are we presenting that to business. Depending on the problem, depends on what company are we at. Even with the same problem, with the churn problem that we are presenting here, we can be, depending on the company, we can be answering different things, right? Because our company is more focused on cost. Our company is more focused. It's not that the cost is not that important, but it's more focused on the actual retention. So the retention rate is very important. We don't care how much we spend here. So it depends a lot, right? So think about what are the key points, the pain points in your business, in your business users, your stakeholders, and then try to focus the communication of the results of your problem, of your model, to fulfill that problem. Again, are we solving the problem? And specifically, are we solving the problem better than we were solving the problem in the past, right? So it has a cost, right? It's not just the benefits, but it has costs, and we have to be aware of them. So, for example, a few of them, every retention operation has a cost. So every campaign, we have to pay the people who design the campaign. We have to send the emails. We have to, I don't know, put an advert on TV or on a billboard or whatever, right? But it has a cost. And then it has the development phase. We have to develop the model. And it has a cost of infrastructure. Again, are we using on-prem? Are we using Azure or any other cloud provider? So again, it has costs involved, and we have to take them into account, because when we speak of benefits, costs, derived benefits, automation, time savings, all these sounds appealing if the equation is good, right? And if our results are good enough, that is an appealing message to our customers, to our stakeholders rather, and will be seducing them to buy the project, right? We can use, again, metrics, accuracy, precision, recall, F1 score, balanced accuracy, whatever, right? The curves, all these can be used, right? But this is just statistical, it's for us. We can use visual metrics. Then for example, the confusion matrix. In the confusion matrix, a good thing that we have here is that it's visual, and it's the more visual we get, the easier it is to customers to understand that, right? So here we are using labels, state and exited, that are that are represent what actually happens. We are not using 0 and 1. We are not using A and B. We are not using X and Y. We are using actual business words. So that's better. We are not in the best scenario, but still, it's a step ahead in communication, right? But then visual metrics are not just what we need, because with the ROC curve, well, even for data scientists, this is probably a bit complicated to understand. But not to say when you are talking to a customer or to a stakeholder, right? We'll need to change this to something like, instead of saying true positive rate against false positive rate, when our positive label is 1, so that's the exited people. So no, that's too complicated. What we could do is to translate this, which here is presented in a data sciencey way, to something like, for every in our total universe of customers, if we target the first X customers, we'll capture the 75% of the ones who will leave, and that would be enough to increase our retention rate in Z, or the percentage we measure, right? That's something completely different that can be extrapolated from metrics like this. But again, it's not what we need all the time, because then we can go to visual metrics like the precision recall ratio and the graphic. And ideally, if the AP metric is 1, we are in a perfect ratio between precision and recall, pondering and weighting the different kinds of errors that we can have. So false positives and false negatives, depending if you are looking at precision and recall, and so on and so forth. But again, too complicated. Let's talk about business here. But it is not as maybe it should not be as complicated as this. Let's see how can we present these results a bit more in an easier way, right? I have a Power BI report here, and because we are talking about a classifier, we actually have a single range. Binary classifiers are not just showing 0 or 1. Or multi-classifiers are not showing 0, 1, 2, 3, 4, rather than, or cat, dog, spider, whatever, they show scores, actually, right? So we can understand in our churn model, we can understand how successful we are when we are predicting, we are emitting signals in the 0 to 2 to 0.4, so closer to 0, since our labels are 0 for the ones who stayed and 1 for the ones who left. Since we have that encode, then we can analyze how successful we are, and we see clearly that if we go here from this range and to here, and to this range to here, since green is better because we are analyzing how successful in terms of accuracy we are when we predict in these ranges. First of all, we see that there's a lot more predictions here, and that's right. That's cool, because we are there's many more customers who are staying rather than the ones who are leaving, because otherwise, if we had more users that are leaving, then our problem would be radically different. But then we are very more successful when we are very sure. So we are close to 1 or close to 0, but we are not very successful when we are not very sure. So that means that the model is not learning from these cases, and it's not able to precisely separate the two classes, so the ones who leave and the ones who stay. Even with that, we have a good accuracy. That's because the label is very imbalanced. But again, this is something that well, it's very data scientist-y, and if I tell you, probably you're understanding because you like analytics and you like classifiers. But if I'm talking the same speech but to a business user, could we do something like this? Could we just turn this visual to a sunburst visual, and then saying, okay, let's see, because I have two levels here. First of all, I'm using actual business labels, the ones who were predicted to be exited and the ones who were predicted to be stayed, against the ones who actually exited, who are the ones who we liked to detect, right? So we had 86% of accuracy, and that sounded good. But in fact, if we see this particular segment, which is the one that we want to analyze, we'll see that our model is not that good. Our model is not that precise, because we are predicting state for almost half of the ones who actually exited. That's not the kind of model we want to have, right? And let's see from that specific one, that specific area, who are the ones that are hurting our model. So these ones that are actually exited and that we predicted to stay, because this is Power BI and we are using cross highlighting, then we can see that we have to focus on this area of the signal. That's something else. We are changing. It's not perfect, but we are changing the way the way that we explain the results. And even better, if we explain that we can have a better threshold, because we can separate the classes depending on the signal rather than just the label 0 and 1. I created an analysis to see if we change the threshold, where do we have the best accuracy in our model. So it's not 0.5, which is 86.6, as I mentioned. Here you have it. But rather, it is our best accuracy. It is situated at 0.6, where we have 87.20% of accuracy. That is from a statistical point of view, but again, nobody cares. But if we talk about cost and benefit, and we analyze for the ones that we take action on, that we take retention action on, and we are right, then we are getting a benefit. It's a very simple rule. I know it's a very simple formula, but I created a DAX formula that tries to encapsulate that with profit, and it's saying, okay, every single time I'm right about a person leaving, then I'm going to be able to retain that person, and then that costs me a bit, but my benefit is whatever the number is, right? Let's add it here. And if I take the action, if I say it's going to leave, and I take the action and that's wrong because it was about to stay either way, then I'm just losing the money I invested in my retention measure, right? So putting this into profit, this profit measure in the secondary axis, and since it depends on these what if parameters that I have here. Of course, now it's nothing. It's 0 because benefit 0 and cost 0. But if I say that we have no cost at all, and rather we have £8 of benefit every time we are right, it says that the best threshold, it's not 0.6 as we said, but rather 0.05, because the solution is to attack them all, to try to retain everyone, because I have no cost. But that's not true. But rather I have here a cost of 3 per action, let's say. And if my cost is 3 per action, my best threshold it's at 0.38, because here is the one that balances the amount of successes that I had in my test dataset, but minimizing the amount of errors, so minimizing the cost. Right? This is an analysis that it's completely different from a data science analysis, but it is way more appealing for a business user to understand and to explain that we are optimizing the model to be as profitable as possible. Right? It's very small difference in the creation of the metrics, in the creation of the graph, but way more appealing to a business user to understand it. Right? Okay. Let's see how we can keep on improving the communication. So what happens in a regression model, in a regression problem? For example, we are going to predict the hourly energy demands of Panama, right? Well, it's not here, but I'm advancing and I'm saying that it is about Panama, right? So the derived benefits of this, a few of them, could be the power grid load estimations. We are able to estimate how much energy are we going to consume at a certain day, at a certain hour. Therefore, we are going to lower the not the changes but the chances. That's a typo from on my side. Let's fix it. It's something that really bothers me. So chances. Okay, so lower chances of oversaturation and blackouts, because we know how much energy are we will need, so we can plan in advance so we don't have any oversaturations and any blackouts. So therefore, again, higher satisfaction values and lower maintenance costs, because we know we can advance the maintenances and the let's say the amount of transformers. I don't know. I know nothing about our energy regression, right? But there are actions that we can take to lower the maintenance cost, because we are moving into a predictive system rather than just wait until the system fails, or overestimating the demands and spending a lot of money for a demand that will never happen, right? And again, whatever, right? Whatever fits your business case. Let's keep in mind that regression models that have time, like this one, have special characteristics. From the technical side, we have time-based validation, so we have to follow the time axis, the chronological axis, to validate the model. Otherwise, it would be data leaking, because we will be using future data to predict past data, which makes no sense. The feature engineering part has to take into account the time axis. So again, we don't leak ourselves, we don't data leak ourselves. We can think about periodic retraining, and it has an interrogation mark here, because depends on again, as I mentioned, depends on the data we have, the infrastructure. We can afford retrain every X periods of time, every day, every hour, every week, depends. But we have to think about that. And specifically to the session, again, as we were discussing about the technical side, when we are communicating that these efforts, this time related results, we have to communicate thinking about time, and I'll explain that in a while. The statistical metrics, as we discussed for the classification model, can be MAA, RMCE, RMSLE. If we are talking about we want to use the logarithm, R squared, R squared adjusted, MAPE, whatever, right? These are the ones that we data scientists would use. But regarding business, it'd be way more appealing and way more impactful if we are asking them, how do you consider positive and negative error? So is it the same to be over the estimation to be over the actual value or under the actual value? So it is the same to overestimate or to underestimate. What happens? Think about the case that we are talking about. Think about the energy demand. It is not the same whatsoever to predict over the actual demand or to predict under the actual demand. If we predict under the actual demand, probably we'll have a blackout. And the consequences of that, the maintenance, the repairs, the chaos in the streets, I don't know. But if we overestimate, we won't have these blackouts, we won't have these maintenance problems, but we'll probably will fall into an overspending of resources when they are not needed. But that's an error which is, from my point of view, again, we have to discuss this with business, but from my point of view, that problem is way smaller, it is not as grave as it is to be underestimating. But then that can translate back to the technical sides, because we can evaluate our models with a custom metric, which is not RMCE or MAE or whatever, all these that I mentioned, but rather we can penalize the predictions that are under the actual value and penalize less, let's say, weight less the errors that happened when we overestimate. For example, that will lead to a model that usually will overestimate, but that's the kind of model we want, and that's the kind of model that business wants, and that's because that's the kind of model that solves the actual business problem, which is the actual goal of machine learning, right? Okay, so how to communicate these results? Well, our beloved George Box said once that all models are wrong, but some are useful. This is a very well-known quote, and we are going to deal with the uncertainty, because we know that our models are wrong, but we have to make them useful. But to use the models, for them to be useful, we have to deal with the uncertainty and the reliability of the model. So we have to analyze the error that our model commits, and then we can do that with error ranges. So how much how big is our error, let's say, in a specific period of time, or just use a band that uses percentages. So plus 10%, minus 10%, or so on and so forth, right? It depends on what fits our needs. But we have to think about errors. We can analyze, in that regard, for the error ranges version, we can analyze the residuals. So the differences between what we predicted and what's the ground truth, the actual thing, that happened. In this case, the hourly demand of energy in Panama. So the residual analysis can not consider time if we are not dealing with time. But in our case, we are considering time. So we have to think about this residual analysis along the time axis. I'll show you a metric in Power BI now to illustrate that. On top of that, and it's not the same thing, but it's something that complements the whole thing. We can go into conformal predictions. We can analyze the residuals and create a function of some sort. Let's not talk about the details, if it's a Bayesian or a density function or a Bayesian system. But the actual goal is to create a probability of error around a point prediction. So we predict that we're going to need 800 megawatts per hour at a certain point. But then we analyze our errors, and then we say, okay, based on our errors, how wrong were we when we said, what's the probability of being wrong in a certain range when we said 800, right? And then we can plot that graphically along the time axis. And that's something very useful because we can understand how reliable is our model. And if it's reliable, then we are building trust with customers, and the model will be used and therefore will be useful. Right? If they're not using the model will be forgotten, and we will be working somewhere else, but not there. Okay, let's communicate regression results. Okay, let's check yet another Power BI report, and then we are going to see here the series of all the time series, and it looks like we have a few outliers here and there, and well, we can see it's a lot of time because we have like 5 years or so, and then we are reducing this axis, and well, it has a very weird shape, right? It doesn't look like a time series that could be modeled. Think about that. If you know about Power BI, what's this I here? It is subsampling because it has too many data points, and Power BI is not able to show that. So what we're going to do is we're going to reduce the axis, and then now it's showing the actual shape, right? Because it doesn't need to subsample again. This is the actual time series, right? We could be using the forecast capabilities of this, but rather we are using Python and machine learning models. And I am going to show you a bit of Python. It's just we encode, so on and so forth, and we tune, and we have a result, right? Which is, let me close this, which is, let's say, close enough, right? And it takes into account when we have sometimes overestimates, usually underestimates, but it knows that around here, for example, we had a smaller demand, and here we had a bigger demand. That is because we are using dates and time and hours to model this, and we are using also exogenous variables, which are these ones that I'm showing you here, that I'm not sure what they mean, and that's a bad practice because I should know. Well, I know what they are, but let's suppose that let's pretend I don't know what they are, and that will be a bad practice because remember the seeds part, the planting the right seeds part, we should be as close as a business expert as we can to ensure that we understand the data and we know what we're talking about, and we can featureize that in a better way, right? But it is not the case. We have holiday ID, and I have decomposed the month, week, and date, and day, and I have school, month, week, day of the week, and hour here, as you can see, and I have encoded them with a target encoder, so it tries to retrieve information from the label, from the actual demand, and it uses that to encode these different categorical values, right? So we have used Python. We know about scikit-learn pipelines. We have tuned our model. It is a light GBM regressor, so it's a boosted regression tree model, one of the best ones. So you can use XGBoost if you want, CatBoost, or any other kind of regression if you like. In this case, because of the kind of data, you can use a linear regression. It would work well enough as well. Not as well as these ones, but it would be enough. So a way less complex model. Then we can retrain and repredict every single 48 hours, and we have a lower MSE, so that's better. We had 120, now we have 111. So retraining shows promising results. So we can remind yourselves about how often can we retrain. So this simulation shows that retraining every X hours improves model's performance. And remember that we have to use a time series split because we have, or any kind of splitter that follows the temporal axis, because we need to avoid data linking ourselves from the future to the past, right? So this is our model and works well enough, right? But then we know that we can read from this, and we know this is the predictions. Let me delete the error bar, or at least show it, right? Because here we are. So predictions here. Okay, so I am adding that error range that I mentioned, right? So I am adding 10% up, 10% down for you see that the column is sum of predictions. We have enabled the error bars. This is a very, very important feature in Power BI for line plots. This is extremely important. Not as used as I'd like to see, but it is very important. We can create upper bounds and lower bounds. If we know for some sort of dark magic that our model is 10% wrong up and down its predictions, then we can use this. But let's call it heuristics, which is a cool way to say, well, I think so. But let's think about something more scientific. So could we, rather than this, remember this kind of prediction and this kind of prediction? Okay, so these are the same predictions, but rather when we go to error bars for here for the sum of predictions, we are using a field. What we are doing is creating an error analysis. So this is nothing else than good old running totals on the total error, which is a column that I did in Power Query. I created the absolute error between the predictions and the ground truth, and then we are using that error to create a running totals measure. So that means that error will be changing across time. So here you see that here we have one kind of error, see, and this is almost nothing and almost nothing, and then here we have bigger errors, and here we have bigger bands, and here we have bigger bands because we are more wrong. Here we have a very big band here, right? That's bigger than this because we are analyzing how wrong is our model with regards of time. We are going over the time axis. We are representing business because business has time. In this case, the hourly energy demands have time. And if our model would be, let's say, getting better or worse, our error analysis should reflect that because business should know that, right? So dealing with uncertainty and communicating uncertainty is extremely important when dealing with this kind of not just models but projects and the communication of their results, right? Okay, so this is regarding regression, but then we have the last step, not just the results but the whys. Why is the model saying what it's saying, predicting what it's predicting, right? So model interpretability is a very hot topic nowadays, and it is very important for many reasons, but three examples are model debugging and feature improvement. So for data scientists to understand why our model is wrong or right, to analyze feature importance and feature interpretability, it's very important here. Legal requirements, depending on the area that the business you're working at. If you're working at healthcare or finance or banking, or all these sectors are very heavily regulated, so you'll need to be sure that you can explain why your model has given a loan or not, that, or why your model has said that there's an illness in that MRI. Something very important. And what touches more with the spirit of this talk, of this session, is to create engagement with the stakeholders, because if the stakeholders understand, or at least think they understand the model, they will trust the model, and therefore they will be more engaged and they will be more related to the model, so they will participate more, and more feedback is better models, and better models are better paid models usually, right? So that's what actually is important to us. Okay, so let's interpret the model very, very quick. We have 5 minutes left. And not this, but this. Okay, here, sorry, in the regression model, I can interpret with SHAP, construct a summary plot. Well, to explain a summary plot, for those who know, it's not trivial, but let's say that hour is the most important feature for us. And day of the week is important as well. Holiday ID it is, and then a few more features that I'm not really sure what they are. We should be translating this to business terms. This is like BI, right? This is another way to create analytics. So we should use terms that actually mean something to business. But now we haven't done it, right? For the sake of the demo, that's good enough. And we can understand feature importances. So the model by itself says that the most important feature is week and day and hour in the top 3. This does not align with what SHAP says. Well, it could be due to many reasons, but it's not the time nor the session to explain that. We can create waterfall plots, which are cool. So the amount, because we are talking about we are at night, and this means Christmas, because this is the 31st of December. Then we say that because it's night at Christmas, at New Year's Eve, then we have a way lower consumption of energy. But this is hard to understand, right? What they did, and what we should do to create better engagement and way more, let's say, easy to ingest explanations, is to get this data into a tabular form. You can export this. SHAP values are, you can manipulate them, and you can create data frames with them, right? So I created a couple of CSVs with the outputs of this model, or what we created this with the library, but then we exported all this, and then we are going to create a Power BI report out of that. So when we have this, we can create something like the waterfall plot, right? I just gotten this into a Power BI report, but we can even ask day by day and hour by hour, why are we saying what we are saying? And even we can say, okay, this day for these hours, these were my importances. And then we can even, this is in the other report, we can even create a more appealing report crossing business items that can be in our data warehouses, our data lakes, or our databases, whatever, and then say, okay, for these predictions, I can see visually, and this is a very useful tool for a business user. For this particular point in time where I was wrong that many megawatts, why my model was saying what it was saying in general for all the dates. So for this particular point in time, hour was the most important feature. And why? Then we can engage with customers with this. This is a very powerful communication tool, because it gets together error analysis and feature importance and factor importance and key drivers of the business. Because if our variables are aligned with business, so they have meaningful names, our business knows them because we have engaged them into the development of them. So all that creates engagement and better communication. But we're still lacking. We are it's time to finish, but we are still lacking a little thing that I haven't done, which is create meaningful names. I've been repeating that you need meaningful names. You need meaningful names. Yes, let's do that. But I have no idea what these metrics mean. Okay, let's ask ChatGPT. See, I had to talk about ChatGPT, right? So what I did is I loaded the CSV for just one day. I could do that for the whole set of SHAP values. I haven't because I hadn't time and because it's way more complicated to manipulate. But after a couple of pivots and then pivots, what I got was this. So I just created the CSV object here, right? I just created this, and I created a prompt saying the following values in CSV format, blah, blah, blah. And then I ask ChatGPT, I can drop this and I can delete this. And I just ask ChatGPT 3.5 Turbo, which is the last one that just released a couple of days ago. And I'm calling run all. And if we are lucky, and see, the king of and the god of demos is good to us, we will be, our prompt says, explain for fairly advanced user, explain the meaning of each feature, raw data values and impact. So I'm asking ChatGPT to explain that prediction for me, giving it a bit of context. I know it's not a chat, but we could create a chat on top of our predictions. So we could add even a more businessy layer to our machine learning models and create that, right? See, you have seen this. So it's 30 seconds. And let's go to a text editor and let's see view word wrap. And you can see that it has generated a report. I don't know how wrong or how good this is, but it has given us data about what weather stations in Tocumen and Davis and San Miguel. We have to review this, okay? It's not perfect, but it has given us data about these measures that I had no idea what they were. So QVM to DAV, this is specific humidity in the Davis station. That's what machine learning model says, that the ChatGPT model says. The school one, the month, the holiday, all this is a very cool way, very productive way to automate our reports and our business layers. But what I did was I went to the data dictionary and let's check. So it was right at the station at Tocumen. I didn't know that. Right? Trust me, this is I didn't know that after I did the ChatGPT demo, right? Well, I did that not with ChatGPT, but with DaVinci 003 a couple of weeks ago. But then I learned about the release, and I did that. So Santiago, and it was not Davis, but David city. So it was a bit wrong in this. But the holiday one, the school one, the Tocumen ones, the relative humidity, the precipitation, all that, it got it right. So yet again, another step to get closer to business users, provided by the most cool and hyped machine learning model of our era, let's say. Okay, we are done and almost in time, just 4 minutes over our schedule. So I'll be answering questions for 6 minutes.
Yep, that was good timing. That was. We have a few questions.
Sure.
So I have from Terry McCann. Great session. How do you communicate what a model is intended for so it's not misused by the business? Example, a customer using retail churn model for their business customers.
Well, this is a very hard case because you have to deal with people, and people are always harder to deal with than machines. It is extremely complicated if you are late to the party. That's why I mentioned the business contract at the very beginning, or the project contract. Then first of all, educating people and being sure that everyone's on the same page and everyone's on board and everyone understands what the model is aimed for. Then if you have to be more strict, especially in larger companies, then you'll have to restrict access. That's another way to do it. But regarding the communication part, with lots of education specified or driven by the project contract that I mentioned at the very beginning, which is one of the hardest parts of these kinds of projects, because you have to be sure that everyone does agree with what the model is meant to do or to what to be used for. So yeah, it's a combination of many things. Depending on the case, probably you'll have different answers, different requirements. But yeah, mostly education and project contract, and then access restrictions.
Great. We have another one from Terry as well. Do you have any tips for communicating and demonstrating that a model is not biased towards a particular subset of data?
Well, I haven't covered this in this particular session, but it is a very interesting topic. What I didn't need to do that yet, but there are a few very good tools out there, and I saw demos and I tinkered with them for responsible AI. Specifically for Microsoft, there is the fairness monitor in Azure Machine Learning, and then there are a few Python libraries that can be used as well to explain how the model behaves in different cohorts. So you ensure and you demonstrate with data that your model is not biased towards specific subsets of your data, which could be related to geographical areas or socioeconomic profiles or gender or race or any kind of human condition that could generate certain bias, because data is usually biased, and our algorithms and our points of view, even though we are not sure of that, usually they are. So we need to be sure that our models are not, and these tools are there to prove that. I haven't covered this here, but it is a very good idea for yet another session.
Great. We've probably got more time for one more question. So from Gabby, what is the best way of communicating to an audience having a mixed background of tech and non-tech?
Again, going from, well, if you first separating them is a good idea. No, but you have to. It's like that saying that goes, the chain is as strong as the weakest link. So what I do is to be sure that the message is clear for everyone at the very beginning, and then creating analogies all the time, but sticking with the business part, because that's what everyone understands, hopefully. And then if you have to go for a bit of deep technical analysis, then you go for something that it's available or it's easy to grasp for business people who don't have that background, like, as I mentioned, visual metrics or that kind of communicating or Power BI reports, or these kinds of tools and skills that can relate to everyone. And then if you need to go for a deep technical analysis, then you create separate discussions with technical teams, because it's easier. Well, not easier. It is, the messages are more meaningful for everyone if they talk about what kind of problems the model solves, and then you can go to technical details and how are they solved, but that's not usually the interest of the business background people.
Great. And I will squeeze in one more question. So from Terry, do you think tools should be improved to make it easier for non-ML developers to communicate their findings?
Do I think if what? Sorry, I lost the first part of the sentence.
Yeah. So do you think tools should be improved to make it easier for non-ML developers to communicate their findings?
Well, yes and no. There's a trade-off always when you try to make it more accessible to non-technical people, which is losing flexibility and control. Adding tools for that is always nice, but I really think that there are tools that are meant to be used by technical people, because we are not yet to a point where technology is ready to give the flexibility and the control and the level of detail that some solutions need with non-technical tools. Once I said that, I really think that tools should any tool in general, and any strategic communication, let's say, process should aim to engage everyone. And if that includes non-technical people who need to deal at least a bit with machine learning, doesn't matter if it is building models, understanding models, or using models.
Perfect. Well, I think that's probably all we've got time for this slot. So thank you again. It was a really interesting session.
Thank you very much for having me, and it's been a pleasure. I'll see you in next events, and even as a speaker or as an attendee, because I'll be here anyway.
Fab. All right. Well, thank you again.
Thank you, guys. See ya.
So before everyone leaves, I think we've got some closing remarks. I'm going to add my colleagues. Hello, Terry. Hello, Luke.
Hello. Wow, what a day. I can't believe how much content has been packed into all of those sessions. I feel like I need to lie down. My head is ever so slightly fried from everything today. Any particular highlights of sessions that you saw? Obviously, my personal interest is always more around the MLOps sessions, and I annoyingly missed all of those. So I've got a good weekend of catching up on all of the sessions that were shown on your track, Luke.
Yeah, there were some really good ones. I did like, I have to admit, the Power BI offering of machine learning. I'm always a bit worried about those sort of tools because they're the kind of tools that make us unemployable. But it was actually really good, and I don't think it's quite at the level of something like a Data IQ and stuff, which Leon did allude to. But it was definitely good to see what it was capable of, and it still offered the Python integration if you wanted to get snazzy with it. So yeah, really enjoyed that one.
Nice. Yeah, I guess it's all about empowering people to be able to use the models that we build. I think Power BI is a great one for that. Tori, any sessions that you saw today that you thought were particularly great?
I liked all of them. I really liked Liji Thomas's talk on AI speech. She did a demo of a tool her and her team had made called, it was Name Dropper. And it predicted how to pronounce people's names, which I thought was amazing and something that I probably would use every day.
All the time. I'm forever how on earth do I pronounce that person's name?
Yes, and it was cool because I've not actually seen AI speech before, and it is just out the box quite a powerful piece of kit.
Amazing. I think personally, probably one of my favorite sessions, just because it's always on the kind of forefront of what we do, was the last session that I saw about communicating the output of a machine learning model back to business stakeholders. Because a lot of the time when we deliver projects, we're delivering very technical projects, but for a business audience. And if you kind of bamboozle people with various different accuracy metrics and ROC curves and other things, they're not going to actually understand, the kind of power and the ability of what you're making. And it's very easy to mislead people with high accuracy scores. And so I thought that was a really interesting session around how to think about things a little bit differently and communicate them to the right kind of level. And I always think that, as very technical people, that's a skill that we always need to be working on in terms of how we better communicate what we've seen. But yeah, all in all, blimey, what a jam-packed day.
Yeah, you missed a good one on responsible AI, which was really nice. It sort of follows on from that. So with Azure Machine Learning Studio, they offer a nice new cool dashboard, which is the responsible AI dashboard, which it does a lot of the interpretability stuff. So explaining to stakeholders and stuff. You can even tweak slight bits of the model. So if you wanted to tweak a feature, it will adjust the outcome or target variable, so you can see what happens if I was to lower my age by this much, would I get that loan or not? That sort of thing in the predictive models. And also it goes into things like bias and stuff, which is sometimes overlooked, which I thought was a really great thing to look at. And yeah, it's a big part of it, but it's not as well known as some of the other things to do with the AI space. So yeah, it's good.
Amazing. Yeah, it sounds like a great one. I will absolutely catch up. And I think for everyone watching this, right, make sure if you want to go and catch up on the other sessions, they'll all be available on our YouTube channel, along with a whole host of other content that we have available up on YouTube. So do have a look. Hopefully you can learn something else, or just kind of have a look at, as and when you need to. But I really hope that everyone has had a great day and that you've all got a lot out of the incredible content that's been shown today. And I'd just like to finish really by saying a huge, huge thank you to every one of our speakers who donated their time today, but also the huge amount of time that it takes to go in to build a lot of these talks. I mean, I'm always blown away by how effortless it is that for a lot of people to deliver the content that they're showing today. But it just goes to show the hours, the days, the weeks that go into actually producing content of the caliber that you've seen today. So a huge, huge thank you to every one of our speakers. And then again, a huge thank you to all of our organizers. So a huge thank you to Tori and Luke for running the tracks today, for introducing all of the speakers, for managing all of your questions and putting them back to everybody, and to all of the rest of the helpers kind of behind the scenes. And then just a final thank you to every one of you who attended today. And again, hopefully you can take something away. You can ponder it over the weekend, and then you're ready kind of come Monday morning to start, potentially implementing something new that you've learned today. So a huge thank you to everyone, really. Woo! And I guess with that, we can probably close the Global AI Bootcamp London for 2023. Hopefully we'll see you in next year for the Global AI Bootcamp 2024 London edition.
Bye.
Thank you.
Bye, everyone.
Goodbye.